Hi and welcome to this course. My name is Maximilian Schwarzmuller. I'm your instructor in this course and I will teach you React Native from the ground up, step by step, in great detail by building many apps to dive into the different core features you must know and to make sure that you thoroughly understand all these core features and that you can practice working with them. Now, this course requires React knowledge because React Native builds up on that. I did create React the Complete Guide, which is a great course you can take as a prerequisite for this course if you don't have this knowledge yet, but of course any prior React knowledge will do. In this course, you're then going to learn React Native from the ground up, as I mentioned, and of course you will get all the theory you need, but also all the practical examples you also need to understand that theory. And therefore, I would say let's not waste any time, let's dive right into this course and let's start with the most important question first. What exactly is React Native?
So, what exactly is React Native? Well, as the name implies, it is related to React.js. And with React.js and React Native, you can build real React Native-based mobile apps for iOS and Android, which are real apps you can distribute through the app stores and apps that can be used by any user with an iOS or Android device. Now, React.js is a library that's independent from React Native, though. React.js is a JavaScript library for building user interfaces. And it is typically used for web development. That's also the environment for which it was first created. But actually, if you worked with React.js, you might know that it's actually another library, the React DOM library, that adds the actual web support. Because React itself, the library React itself without React DOM, is platform agnostic. Which means you can use React in conjunction with React DOM to build web apps, but React, the library itself, actually does not care about the underlying platform. React just gives you tools for managing state, for building virtual component trees, and then you need an extra library like React DOM for translating the result React produced to an actual platform like the browser. Now, React Native is basically an alternative to React DOM, therefore. React Native gives you a collection of special React components which you can use in your JSX code. So React Native ships with built-in components you can use. And those components are then compiled to native UI elements for the iOS and Android platforms. And React Native will also take care about this compilation step. In addition, React Native also exposes certain native platform APIs, like using the device camera, so that you can use such features in your JavaScript code, even though you need to tap into native device APIs for that. And therefore, in the end, React Native is like React DOM, it just does not target the web, the browser, as a platform, but instead iOS and Android. And React Native gives you all the components and the APIs you need to interact with those platforms and to build apps for those platforms. That is what React Native is all about. And therefore, in order to work with React Native, you also must know React.js, because you will write your code in React.js and then just use these extra React Native components and APIs in your React JavaScript code to produce those native mobile apps for iOS and Android. Now, how does React Native work under the hood, though? If you're building a React and React Native app, then you're typically writing code like this, which should look very familiar if you worked with React.js before, maybe or most likely for building browser-based apps. This is a React component, what you see here. And it's just one way of writing such a component. We could also use the function keyword instead of defining an arrow function, and we could also use a class-based component. But it's code like this which you will write for React Native, and it's code like this that will be compiled to real native app code, so which will be bundled into a real native app in the end. Now, if you take a closer look at the code snippet on the left here, you will see two components, two JSX elements in there, which you don't know from web development: the view and the text element. These are some of these special components that are exposed by React Native, which will be compiled by React Native. It is worth noting, though, that it's really just the views, just this JSX code that is compiled, not the JavaScript logic itself. I will come back to that in a second. So the components, the JSX elements you use, are compiled to native elements for the respective platforms. And to make this a bit easier to understand, take a look at this comparison table here. Here we got a bunch of elements as we would use them in the browser if we would be using React DOM, and then the equivalents for the native platforms, and then the components exposed by React Native to target those equivalents. So for example, if you want to display an input element where users can enter some text, then when building a web app, we would use the HTML input element, which is available in JSX when we're using React DOM. If we would be building a native Android app with Java or Kotlin, then it would be the built-in added text widget that is provided by Android, which we need to build. For iOS, it would be the UI text field element. And with React Native, we would use the built-in text input component, which is provided by React Native and which will then be compiled to edit text for Android or to UI text field for iOS. So React Native maps and compiles reusable components like text input or view or many other components about which you will learn throughout the course to their respective platform equivalents. That's one of the main jobs React Native will take care of. But what about the logic? I mentioned that those views, the JSX elements, are compiled to their native equivalents. But what about the JavaScript code you write outside of JSX? What about all these functions, if statements, state management? What about that? Well, unlike the UI elements, the logic is not compiled. The UI elements, which are those components exposed by React Native, are compiled as you learned. But the logic which you write in JavaScript is actually not compiled, but instead it's running on a JavaScript thread that's hosted by React Native in the native app that was built. So React Native basically spins up a simple JavaScript process as part of your native app that's being built, and it manages this process for you, and it allows this process to talk to the underlying native platform. And therefore, your JavaScript code will run as JavaScript in the native app that's being built, but it will then talk to the underlying Android or iOS platform through a basic translation bridge, you could say, that is provided by React Native as part of your native app. That's how you can think about this. And that is it for now. That's how React Native works under the hood and what it does for you. You don't need to know more. You can, of course, dive into the official docs if you do want to learn more, but that is what you should know in order to work with React Native, because I believe it's always important to have a basic understanding of how a tool works, and this is how React Native works. So I would say it's enough for the theory for now. Let's get started. And for that, you can simply search for React Native to find reactnative.dev, which is the official React Native website. Now on this site, you can learn more about React Native, And it is a great additional resource if you do want to dive deeper and learn more about it. But of course, you will learn all the essentials and everything you need to know to build React Native apps in this course. Now, in here, on this site, it is a good idea to click on Get Started though, because there you'll learn how you can create a React Native project. And what you will learn here is that if you do click on Environment Setup here, on setting up the development environment, that you got two choices. That you can use a tool called Expo CLI, which seems to be recommended because it's the by default selected choice, and that you can use the React Native CLI. Now, as I just said, Expo CLI is selected by default, and indeed it is my recommendation as well, and it is the tool we will use in this course. But you could also use this alternative approach. Both approaches will give you a development environment in which you can build React Native apps. So what's the difference then? We have the Expo CLI and the React Native CLI. CLI stands for Command Line Interface, and both tools are tools that exist in order to help you create React Native projects and run React Native apps on testing devices and simulators, as well as build React Native apps so that you can ship them to the app stores. So these are the tools you need to really build apps and to get those packages, those distributable packages, which you can upload to the app stores. These two tools are crucial. But you don't need to use them both. You can use either of the two, and one tool is enough. But why do we have these two tools, and what's the difference? Well, the Expo CLI, or just Expo, as I will also call it throughout the course, and the company behind this CLI is in the end a third-party service that you can use. A service that is entirely free. You don't have to sign up, you don't have to pay for it. You can sign up and you can pay. They do offer extra paid services, but to build React Native apps and to ship them, you don't need to pay. When using Expo, the CLI, and a couple of other free tools which they give you, you get a managed app development workflow, as I like to call it. Which means creating projects is easy, writing code is a bit easier, tapping into native device functionalities like using the device camera and so on is easier. And in general, when using Expo, the Expo CLI, and also a couple of other tools provided by Expo, writing native apps with React Native is more convenient than with just the React Native CLI and without Expo. There is less friction to this process. And the best thing is that you can still leave this Expo approach and ecosystem anytime if you need to. If you start by using Expo because it's easier to get started with that, and then at a later point you find out that you want to switch to just using the React Native CLI workflow and not using Expo, you can do this anytime. That's why it's also the default selection to start with Expo, because it's easier and you can still switch anytime you want to. Now, why do we have the React Native CLI then? Well, because it existed before we had Expo, because this is the tool provided by the React Native team and the community around React Native. It gives you a bare bone React Native development setup, which means you will need to do more configuration and setup work on your own. There are less convenience features, and if you need to tap into certain native device features like using the camera or other features, then it is often a bit more work when not having Expo around. Because as mentioned before, Expo is not just about the tool that creates projects, it will also give you helpful packages and tools that you can use when writing code that will make your life easier in that case as well. Now, what the pure React Native workflow does have, though, is that it is often a bit easier to integrate with native source code. So with source code written in Java or Objective-C or Swift or Kotlin. So if you must mix JavaScript code and native device source code, then using just the React Native CLI could be beneficial. But the idea behind React Native is that you don't have to do this too often, and therefore this might not really be an advantage. And for all these reasons, and especially since you can switch anytime if you need to, we will use Expo in this course. As you will see, it's super easy to get started with that, and it will make building React Native apps much easier. So therefore, back here on the official React Native website, we will stick to this Expo CLI quick start approach here. And we need to run this command in order to install the Expo CLI, which is the tool that will then allow us to create Expo-based React Native projects. Now, we do install this tool with npm, which is the Node Package Manager, and therefore you need to install Node.js. Now, we don't need to install Node.js because we will write any Node.js code, but simply because we need to install this package, and also because Node will be used by some packages under the hood. Hence, you should visit nodejs.org and make sure that you download the LTS version from there, which in my case is version 16, but simply download whatever the LTS version is for you when you're viewing this. So I will download this and simply walk through the installer. And there is an installer for both Windows, macOS, and also for Linux, so you can and should install this on whatever device you're on. And once you do have Node.js installed, you're ready to run this command in your terminal or command prompt. So here I'm in my terminal, and in there, I'll just paste in this command, and I'm on macOS where I must add a sudo in front of this command in order to make it work. You might not need to do this. You definitely don't need to add this on Windows because this is not a Windows command. On Windows, you just execute npm install -g expo-cli. But on macOS and Linux, you might need to add this, especially if you're getting some permissions error otherwise. So with that, I will install this by also entering my password here, and this will now download and install this Expo CLI tool globally, that's what -g does, on my system here. So I will be back once this finished. So here it finished for me. You can ignore any warnings you might have gotten here. It did finish successfully if you can run the expo command thereafter and you don't get an error when trying to do this. Now this, by the way, shows you all the commands you can then execute with expo. There are a lot, and the official expo documentation is the place to go if you want to learn more about that. You do find that documentation on expo.dev, but we don't need to take a closer look at those commands right now because there's only one command we need to run right now, and that is expo init, which initializes a new project. But since I'm already on this official website, as always, you might want to explore those docs in addition to this course. Simply because in there you can learn more about Expo, the philosophy behind Expo, how you could switch to a React Native only project, though we will take a look at this later in the course as well, and how you can use it. So this is a great backup resource in addition to this course. Now here we did now install Expo. Now we can create a new project by running expo init. For this, I switched to another folder here on my system, the folder where I want to create this new project. I switched to it here in the terminal with the cd command, which you can also use on Windows in the command prompt to switch folders and paths. And then in the place where I want to create my new project folder, I will run expo init, and then I'll name my project rn course here. So this will be the name of the folder which will be created and the default name of the app that will be created in that project folder. So if we now hit enter, we get a little menu here where we can choose which kind of project we want to create. The options and the text here could change over time. Right now, I can choose a blank project with TypeScript support, a project that already has navigation added to it, which we will take a look at later in the course, or a bare workflow project, which is actually a project that doesn't use too much Expo, but again, we will take a look at that later in the course. Right now, we want to have such a managed workflow project where we fully embrace Expo and take advantage of it. And I don't want to use TypeScript. I also don't want to use navigation right now. We will add it later. Hence, I'll just use blank here. And this will now create a new blank Expo React Native project in a folder named RN course, since that is the name I chose here. Now this did now create this project folder, and it shows us some commands we could execute in there to start the Expo development server, which will basically watch our code and create a development app bundle whenever we change the code. And we can then also run that code in preview mode on iOS and Android. And even for the web, though that's not the focus of this course, if you want to build React web apps, then my React Complete Guide is the best choice. Here we'll focus on Android and iOS. Nonetheless, I'll not execute those commands right now. Instead, I want to open this new project first so that we can see what was created in greater detail. So we created this project, this Expo project. Before we run it now, I want to open the created project in an editor that allows me to edit the code in a convenient way. Now you can use any code editor you want. My recommendation is Visual Studio Code, which is an amazing free code editor that's very extensible and fun to use. You can download it for all platforms, and I already do have installed it for macOS. Now with VS Code installed, you can open it, and you might see a welcome screen if you installed it for the first time. You can simply close that screen, and then you should see something like this, where you can open a new folder. Alternatively, you can always go to the menu, File, and find Open on Windows or Open Folder on macOS there. And then if you click that, it will open such a file picker where you can now select that project folder you just created. So here I'm selecting this RN course folder, which I created before, and I'll open this in VS Code. So here I got this Expo React Native project opened up, and you can of course configure the visuals, the way VS Code looks, however you want. By going to View, Appearance, you can hide or show the sidebars, the status bar at the bottom, and you can also go to Preferences and then choose a color theme that suits your needs. I'm using the Dark Plus theme here. So you can configure this editor however you want. But what was created for us here? Well, we see actually not too much. We got two folders, Expo Shared and VS Code, which we can ignore. VS Code just holds some settings I configured for this workspace here, and Expo Shared simply just holds some internally used information. The assets folder will become important later because we can store images there, for example, the icon of our app, but also images which we use inside our app. And we got the Node Modules folder, which holds all the third-party packages that are used under the hood. We got a package.json file, which lists all the dependencies of our project here. And here, for example, we see Expo, because Expo is not just the command line interface, it's also a JavaScript package which we can use and which we will use heavily, as you see, because it gives us many utility functionalities that make writing React Native code easier. But you also see we're using React, React DOM, React Native, and React Native Web, though again, that's not the focus of this course. You could build web apps with React Native, but support is a bit clunky, and yeah, we're simply not focusing on that because you could just use React itself if you want to do that together with React DOM. React DOM, of course, therefore is also just here because of React Native Web. So that's what we have here. We also got a couple of script commands which we could execute with npm. But overall, there's nothing fancy in here, and you know these kinds of files if you worked with React before, which you should have because this course assumes that you have React and JavaScript knowledge. So that's the package.json file. Package log is related to that, and the Babel config.js file just configures how code is transpiled under the hood, and unless you know what you're doing, you also shouldn't change this file therefore. Now we do have the app.json file, which will become important later because here we can configure some settings and behaviors of our React Native app. And this is a file that will be picked up by Expo when our app is built for preview or for the actual app stores. We can set the name here, we can set some background colors here, and we will come back to this file occasionally for configuration. So this is a file which we have because we're using Expo. And then we got app.js. This is the only real code file we have in this starter project. The exact content could change over time. To make sure that we're all on the same page, I attached my app.js file to this lecture so that you can download it and replace yours with it so that you have the same code as I have it, because we'll build up on this code in the next lectures. This in here is a regular React component which uses special components, special JSX elements exposed by React Native. That's what I mentioned before. And then we got some styling which could look a bit weird, but I'll come back to how styling works in React Native apps later. So for the moment, this is our app code. And now it would be nice to see this code in action. For this, we need some device on which we can preview it. So we got our code opened up here. We created this project with Expo. Now it would be nice to preview our app. Because of course, whilst we're working on the React Native app, we want to constantly preview it so that we can see our changes and tweak the app as required. It would basically be nice to have the same kind of workflow or a comparable workflow as we have it with the browser and just React when we're building React web apps. There we can also create a React project and preview it in the browser. Now thankfully, since we're using Expo, previewing our app on a real device is super easy. You just need an Android device or an iPhone. In my case, I have an iPhone here, but the same is true for Android. And you visit the App Store there. And in the App Store, you can search for Expo. Now, you should find an Expo Go app. This is an app provided by the company behind the Expo CLI and this Expo package, which is part of our project here. So you can now download this app onto your device. This app is available for the iPhone and for Android devices. And once downloaded, you can open it. Now in here, you can preview your Expo apps that are built on your local computer. To do that, you should open up your terminal or command prompt. Here I'm using the one integrated into VS Code. You can open this by going to terminal here and opening a new terminal. And this is the default system terminal integrated here into VS Code. And then in here, you can run npm start. Now what this will do is it will actually start the Expo development server, which watches and builds our code and which builds our code basically such that we can preview it. And it also gives us a QR code here. You can scan this QR code with your Expo app on Android. Not on iOS, I'll come back to this in a second, but on Android, you will have a barcode scanner, a button that allows you to scan this barcode in your Expo Go app, which you downloaded. In addition, you also should have a browser tab that opened up where you also find this barcode and where you will find log messages printed by Expo as your app is running. Now on the iPhone, the scanner is not integrated into the Expo app. Instead, there you need to open your camera and then scan this barcode here or the one in the terminal. And then once you tap to open the link that is sent by that barcode, you should click Open, which opens the Expo Go app. Then you should grant any permissions the app might be asking for. And now you see here that the JavaScript bundle is being built. So the Expo app is being built. The React Native app based on Expo is built. And it opens up in this simulator on our real device here. So in this Expo Go app here. We can close this info screen. And now here we see our app, which we're building on our local machine running on a real device. Now we can tell that this is our app by changing this text. If I remove all the text here, and instead I say, hello world, the good old hello world message, and I then save this file, you will see that it basically instantly updates on your phone as well, in this Expo Go app, which we use for previewing. And this is how simple it is to build and test those Expo-based React Native apps with the Expo Go app, and why it's so recommended to use this Expo workflow. It simply makes building and testing React Native apps much easier. And this still is a React Native app here. We're just using Expo to make our life a bit easier. So this is how easy it is to get started with Expo and React Native. You can easily create an app, and with help of the Expo Go app, you can easily preview it. And you might not need more for now. You can now follow along and preview your app changes on your real device. But maybe you don't want to use your real device only. Maybe you also have an iPhone and you want to also preview the app on Android, but you don't have an Android device. For those reasons, you might want to install a simulator, which is an extra piece of software that runs on your local machine that simulates an iOS device or an Android device. Now for this, you can search for Android Studio to download Android Studio to get such a piece of software that allows you to run Android emulators on your local machine. On developer.android.com/studio, you will find a download link that allows you to download Android Studio for your operating system. And this can be downloaded for macOS and Windows. Now, the download can take a while, but make sure you do download and install it in order to be able to run emulators on your local device. Now for iOS, it's different. There you must open the App Store on macOS and search for Xcode and download this Xcode tool, which is Apple's developer environment for building iOS apps. Unfortunately, this is not available for Windows or Linux devices. So if you are on a Windows or Linux machine, you can't run iOS simulators through Xcode. This is a limitation applied by Apple. So unfortunately, on Windows or Linux, you can only build and test for Android. Actually, you will be able to build real iOS apps as well through some cloud build service, about which I'll talk a little bit later. But when it comes to previewing the app on an iPhone, if you don't own a real iPhone on which you can use the Expo Go app, or a macOS device on which you can install Xcode, you have to focus on Android instead. It is what it is. Now, once you did install Android Studio, you can open it and you should see a welcome screen that looks something like this, and that should have some more actions button. And in there you will find a virtual device manager. You can use this manager to build virtual devices, so to build emulators. So here I already have an emulator, but you can click on Create Device to build a new one, and here you can select from a broad variety of presets, like the Pixel 5, for example here. Click Next, then choose an Android version that will run on this emulator. And here I'll choose the API 32 version, which is the latest version in my case. Click Next, keep all the default settings here, and click Finish. And now this will create such a new emulator, and then you can click the play button to launch this emulator. And this will now launch this emulator on your device, so on your Windows or Mac OS or Linux device. I'll just increase it a little bit here. So that's now an Android phone, so to say, running on our computer. Of course, just a dummy phone, an emulator, but a real phone when it comes to testing Android apps. Now, I will show you how to run this app on this emulator in just a second. First, I want to show you how it would work for Xcode and macOS, which, as mentioned, only works on macOS. Here in Xcode, you want to open this as well. You don't have to open a project, you just need to open Xcode, and then you should go to the preferences there. In the preferences, make sure you go to locations, and here, under command line tools, make sure you have a version selected here. By default, no version is selected, and you should do that then. Select a version here. Once this is done, you can close it, and then we can go back here to our Expo app in VS Code. Now I used the terminal to run this npm start process, and this process is still running. You should, by the way, keep this process running as long as you are working on your code. If you quit this process, your code is not watched anymore, preview builds are not built anymore, and they are not pushed to your connected real devices or simulators anymore. You can always quit this process by pressing Ctrl+C, and you can then restart it by running npm start again. But as long as you're writing code, you should keep it running. Now in there, we had this QR code which we could scan to use the Expo Go app on a real device, but we can also press A to run it on Android or I to run it on iOS, and it will pick those running simulators or start a simulator for you. Nonetheless, it doesn't hurt to already start an Android simulator as I did it here, so that I can then press A, and now this is opening this on Android. So this app is now built and previewed on this Android emulator. Now, in case you're getting an error like this, that is most likely related to the emulator you created. You might want to create a new emulator and make sure that you create one, or that you pick a template that has this Play Store icon. Because Expo needs to be able to access this Play Store, so the Play Store must be part of the emulator in order to download this Expo Go app, which is used for previewing, onto this emulator. So use an emulator template that has this icon, then still the latest version, all the defaults, and create this emulator and start that emulator. So now I'm launching a new emulator based on this new template here. And once this finished starting, we can again restart npm start maybe, and then press A again to find this emulator. It will be found automatically by Expo, and then it will install this Expo Go app onto this emulator and open our app there as well. We get this info screen, which we can close. We get this debug screen here, which we can use to reload the app, for example, or turn on certain debugging tools. But I will come back to debugging later. We can close this for now and see our app here. So that's Android. Now for iOS development, you should go to your applications and locate Xcode and show the package contents of that. Because in there in contents, developer applications, you will find this simulator app. And you can double click on this to start an iOS simulator. Now in this case, it's an iPhone 13 simulator. You can change this by clicking on it and going to the menu, and then under File Open Simulator, you can choose all kinds of devices, but I'll go with iPhone 13 here. We can also increase this in size to make that a bit easier to view. And now we can press I here. You don't even need to restart npm start. You can serve the preview on Android and iOS simultaneously. So I just served it on Android. Now I will press I to also start it on the iOS simulator, which also should be detected automatically. And now Expo will also install the Expo Go app on that simulator and open this app in that Expo Go app on our simulator. So here it's opening up, and after a short while, and it only takes that long initially when this is all first installed and set up, of course, after a short while, we will see our app preview on this device as well. Here we go, it's loading up now. And now we see Hello World here as well. So now we can preview our little application on a real device, as I showed it to you a couple of minutes ago, and on those simulators like this. And this process here should always stay up and running as long as you're writing code. So I will just make it smaller, and now we can change our code, add a couple of exclamation marks, and if we save this file, this is automatically picked up and reloaded on those apps without us doing anything. You can still manually reload it though by pressing R in this running terminal here. This will then manually reload those apps. And that's the development environment we will use for this course. This is now what we need to dive deeper into React Native and this course here. Now, that's it for React Native for now. Before we now really start diving into React Native and all its basics, let me briefly come back to this course and give you an overview of what you can expect from that course. Right now, we're just getting started, but we're pretty much done with that. And thereafter, we're going to dive into all the React Native essentials you need. In the next course section, we will dive into the basics, into how you can build user interfaces with React Native components, how you can style your user interfaces, how you can build powerful layouts, and of course, we're also going to practice all these things by building real apps. And thereafter, we're also going to learn how we can add navigation, how we can make sure that users can switch between different screens with nice animations, how you can add drawers or tabs and things like that. Now, this course also has a couple of prerequisites to make sure that you get the most out of all these concepts, out of all these sections, and specifically, you already need JavaScript and React.js knowledge. However, this course also comes with 2 refresher course sections, which you find at the end of this course, to which you can jump ahead if you want to go through those refreshers again before you start diving into all the React Native sections. These refreshers don't replace full courses on these topics, but they are great if it's been some time since you last worked with React, for example, and therefore it's my recommendation that you take a look at those refresher sections if you need them. Now, after all those React Native essentials, though, we're also going to dive into more advanced features, and specifically, we are going to learn how we can connect certain key React concepts with React Native. For example, how we can use the Context API or Redux with React Native. We're going to build a complete example app from the ground up to practice all these things we learned up to this point. We will learn how to handle user input and send HTTP requests, and all these things, again, by building multiple realistic apps. And we're also going to dive into more advanced course sections throughout this course. We're going to explore user authentication and how you could add that to an application. We're going to learn how you can tap into native device features, like using the device camera or the user's location. And we're also going to learn how we can prepare and build our apps for production, how you can get them ready for being published to the app stores. We're going to learn that in detail as well. Now, that's the course content. I also want to make sure that you get the most out of this course though. And the most obvious recommendation, of course, is that you should watch the videos because this is a video on demand course. But of course, watching the videos means that you should watch them at your own pace. You can use the video controls to speed the videos up or slow them down, and you should take advantage of that to make sure that you get the most out of them. You can also pause videos to practice something on your own, even if I don't tell you to practice something. Definitely do this on your own as well. And feel free to go back to the beginning of a video, to rewatch a video or even an entire section if something wasn't clear the first time you watched it, because that is the huge advantage of a video on demand course. So embrace that advantage. In addition, of course, in this course, we're going to build a lot of apps, we're going to write a lot of code, and I recommend that you do code along, that you don't just watch the videos, though you can, of course, also just do that, but you will learn more if you also pause the videos, if you practice things on your own, if you code along, if you try to write the code on your own, if you maybe even experiment with the code a little bit and you write slightly different apps, you add extra features that I might not add in the videos. Do all these things because that will ensure that you get even more out of this course. Now, when following along and when coding along, you will sometimes also get stuck. You might not be able to reproduce a certain result I'm showing in the videos, and for those cases, or if you want to, for example, get the course slides, you should use the course attachments that are also provided as part of this course. To be precise, in the next lecture after this one, you find a link to all the course resources, all the code snapshots and so on, and you should use these resources to compare your code to mine, to maybe even replace your code with mine or parts of your code with mine if you're stuck, to make sure that you can find plus fix your errors that you might be facing. The next lecture also contains instructions on how you can use the provided code resources, how you can download them, how you can use them to compare or replace your code. Now, last but not least, this course also has a Q&A section which you can use if you're stuck, if you have questions, but don't just use this section to ask questions. Instead, also try to help others. Because if you try to help others, if you reply to others, you will get way more out of this course, because when you solve someone else's problem, you are challenged to come up with a solution, to articulate that solution, and that will actually make sure that you really get the most out of this course, that you have to understand the things that I teach in this course, and that you fully understand them instead of just a little bit, for example. So definitely also use this Q&A section to help others and not just to ask for help. That's my recommendation for this course. And with all these recommendations, you will get a lot out of this course. You will learn React Native from the ground up in great detail, and therefore, in the next course section, it's now time to really dive into React Native in detail. So let's dive into React Native, and let's, of course, start with the basics. In this course section, we are going to explore the core React Native concepts. This means that we'll dive into the core React Native components, and we will start building user interfaces with those components. But we will, of course, also dive into styling React Native apps. We will learn how we can style those apps and those components such that we can really build the user interface we want to build. And last but definitely not least, we will explore how we can add interactivity to our app and how we can manage state, how we can make sure that there, for example, are buttons that can be clicked and that something meaningful happens when a button is clicked. Now, for this, in this course section, we are going to build this demo app here. It's a first simple React Native app which allows you to track your goals. For example, your goals for this course, what you want to achieve by taking this course or as you're taking this course. In this app, we got a list of goals, and we can open a modal, an overlay, to add new goals. And once a goal was added, we can also tap the goal to remove it again. This is maybe not the next billion-dollar app, but it's a great first app to learn about many core fundamentals you must know about React Native. So let's dive into React Native. For this, I'm back in this project we created in the first course section. In case you did not create it there, or you did remove it thereafter, Just make sure you got the development environment setup mentioned there, and then you can download the attached starting project. Once you did that, you will get the same code as I have it here. Just make sure that you open your terminal or command prompt. Here I'm using the one integrated in VS Code, and that you install all the dependencies this project needs by running npm install. And once that completed, you can run npm start to start this expo process that watches the code and builds the preview and serves it on our emulators. I'll then press A and I to start and run this app on my running Android and iPhone emulators and simulators. Here you go. These are my two preview devices. Now in app.js, we already got some code on which we worked in the first course section already. And what we have in here, in the end, is a React component. A functional React component, and indeed in this course we will only work with functional components and React hooks. We will not use class-based components. So this is a regular functional component. We also got this styles constant, this style sheet object down there, and I will come back to that in a couple of minutes. At the top of this file we got some imports, and we're importing one component from an Expo related package and the other components, namely view and text, as well as this style sheet object here, from React Native. And text and view are two of those built-in components, actually two of the most important built-in components React Native exposes to you to use in your JSX code. Because in here, you can't use divs or h2 tags or anything like this. These are HTML elements which work in the browser when you have a DOM to work with, but they won't work here on a native device, because native devices are not browsers. They don't have that DOM and they don't support those HTML elements. Keep this slide from the first course section in mind. That is how React Native translates different elements into different native elements for Android and iOS. And that's why these components are exposed by React Native. Now, if you visit the official React Native website, then there you will find various guides, which you can definitely take a look at, but you will also find the Components tab, where you get a list of the components provided by React Native. And as you can tell, we actually don't have that many components here, because it turns out that with a couple of core components, you can build any kind of user interface. For example, we got a button here, an image, and text and view. And especially view and text input are super important components which you will use all the time. And as you will learn throughout this course, you can build very complex user interfaces with those core components that you have here. Now, React Native is all about working with those core components that are built into it. You build your overall app UI and your custom components that might make up that UI by simply combining those core components. Because these core components, as you learned, are translated into native UI widgets, native UI elements for Android and iOS by React Native. That's why we work with those core components that are provided by React Native, and we can combine them in our React code, in our JSX code, to build our own components and ultimately our own user interface. So in the end, we just compose our components by combining those core components. And if you think about it, that's the same for React for the web. HTML happens to have more elements. There are H1, H2 elements, divs, articles, section. There are many HTML elements, but in the end, you also just combine those HTML elements to build the web user interface. It's the same here for native apps. So that's what we do with those components. Of course, another important aspect of building user interfaces in general is that you want to style those apps. And when using React Native, there is no CSS. You can't write CSS code because, again, it's not a browser, so the CSS language doesn't exist here. Instead, you can, of course, still apply styles, but you do this either inline, essentially by using props on those core components that are provided, or with help of these style sheet objects, or this style sheet object, which you already saw in the code before. You therefore write your styling in JavaScript, and hence you have no extra styling language. It's all JavaScript, but the React Native team gives you a lot of JavaScript properties which you can set and pass to those core elements, which are similar to the CSS properties. But it's only a subset of the overall CSS property and feature set. But in the end, as you will learn throughout this course, you get all the important CSS properties and features that you need to build powerful and beautiful user interfaces. But back here in our component code, we can see how these core components that are provided by React Native are combined to build a new component, in this case the only component, the app component, and how we then got this style sheet object, which is used to set various styles, which, if you take a look at those properties, look similar to what you know from CSS. And then actually this styles object is provided to this view component through a style prop. But we will take a closer look at styling and at building our own components in general throughout the next minutes and hours, of course. Now, just one final note about this app component. At the moment, this is our only component here. And indeed, the app component in the app.js file has a special purpose. This is the root component that is rendered in your app. Expo will automatically take this component exported in this app.js file and render this as the root component. So any other user interface elements and components must go into this app component or into children or descendants of this app component. But again, that is also something we'll explore in greater detail soon. So let's start by diving deeper into core components like text and view. And for this, I'll actually delete this status bar component and also this import. If I save that, this is updated here on those devices and not much change there. So we don't need this right now. I also will delete this text component and save that, so that for now we have a blank screen. And now let's try re-adding the text like this: hello world between the view, without the surrounding text. If we do that, we notice that we get an error down here. We get an error that text strings must be rendered within a text component, which is actually a quite helpful error message, which tells us in a pretty clear way what's wrong. Now, before we fix this, let's also take a look at those devices, those simulators, and here we also get the same error message. And this is actually something important, which is why I'm showing this. It's different than what you might know from web development. If you would build a web app, and this would be React for the web, and this would maybe be a div instead of a view, then this kind of code would be fine. We could put text inside of a div there. React Native and native platforms, to be precise, are stricter than that. You can't put a text into a view, which is pretty much the equivalent to a div, because it's not meant for that. Instead, views, so the equivalent to divs in the web world, views are meant to generally build boxes and containers that hold other content. A view could hold some text wrapped into a text component. It could also hold a text input or a button or an image or anything like this. But you have to put the content into an element that is able to display it. and the view is only able to hold other components, it's not able to display text. And that is something really important to understand. If you want to display text, for example, you have to use this text component and wrap the text opening and closing tags around your text. And if you do this and save, then this updates and works again. But that's a first important takeaway. Even though we can kind of compare those components to HTML, and even though it looks kind of similar, there are important differences. Now, what you will often do when building React Native apps is you will build more complex user interfaces that don't just have one piece of text inside of them. And what's important to understand then is that those different core components have different roles. The text is a component that's used for, guess what, displaying text. The view is a component that's meant to hold and lay out other components. Now, we will learn more about laying things out with help of styling in a couple of minutes, but the idea behind the view component is that you typically have multiple child components in there. For example, another text, another piece of text. In a text component, as you learned, but now we got two of them. And we group them together in a view, just as we might group them together in a div if this would be for the web. Now in the web, we also have other components like section or article. Here in React Native world, it's just the view. This is our container component that we use for holding other components. And of course, those other components also can be nested. We could have another view which actually holds this inner text. So this is all something that's totally fine and something you will typically build when building more complex user interfaces with React Native. The view then makes it very easy to use styling, into which we'll dive in a second, to control which of its child elements should be positioned. Of course, we don't just have a view and text though. If you take a look at the official website, the official React Native documentation site, you'll learn that there are more React Native core components, and those components fulfill different purposes. We got view and text, which are two of the most important and commonly used components, but we also could display an image, add some scrolling, something we'll do later as well, or add a text input, which allows users to enter some text. We could also add a button. And indeed, that is what I'll do here. Below this text, I'll add a button, but for this we need to import it. And that is also important and an important difference compared to React for the web. With React for the web, you don't need to import the HTML elements you might be using. With React Native, you do. If you want to display a button, you have to import this core component from React Native. And then you can add your button. Another important difference is that, unlike for the web, you don't build a button like this by adding the caption between the opening and closing tags. Instead, it's a self-closing element where you add a title prop, and then you add your title here. This would now display a button as well, with the kind of default styling and tap effects you would expect for the different platforms. And you see that the look adjusts to the underlying platform. It looks like an iOS button on iOS and like an Android button on Android. But of course, the button doesn't do anything yet because I haven't added any listener. Now we will add interactivity and learn how that works later. For the moment, let's just add the button here, and let's understand that we always work with core components like this, where every component has its clearly defined purpose. And you build your overall UI by combining those components. But of course, a UI is not just about combining components, it's also about styling them. And that's therefore what we'll explore next. So let's dive into styling. And here you learned before that there is no CSS support in React Native, so we don't add CSS files or use the CSS language in general, But you learned that we have two main ways of adding styling, by either adding styles inline by passing a style object to props, or by defining a separate object which is then also passed through props. Now we do define our styles in JavaScript then, but the JavaScript properties we can set are inspired by the CSS language, though it's only a subset of the properties and features supported by CSS, and not all the names are exactly the same, as you will see. But let's now see how styles can be applied. For that, we can use the style prop, which is not supported on all elements, but on some elements. For example, on the view, but also on the text. For example, here on, let's say, this text here, we can add the style prop, and then as a value, you can pass a JavaScript object. And in this object, you can set all the supported style properties. And React Native decides which properties are supported. And these are the properties that are similar to the CSS properties, but not exactly the same. For example, here on this text, we could add a margin. And as you see, as I start typing, we get this nice auto-completion here in VS Code. We get this automatically because VS Code understands which kind of properties can be set on this object that is passed to the style prop. Now here we could add a margin, either in one specific direction or in multiple directions by combining multiple properties, or in all directions by setting margin. Now, different style properties need different kinds of values. And you will see many examples and learn which kind of value goes into which style property throughout this course. Margin, for example, typically wants a number. And this number will then be translated to pixels, which are automatically adjusted to the device pixel density. For example, here we could enter 16 to have a margin of 16 pixels. If we save this, we get some spacing around this. Now it's not super good to see because we don't know exactly where the text box ends. To make this a bit more visible, we could add a border. Now in vanilla CSS, you could add a border like this, for example. This would add a red border with 1 pixel width around an element in vanilla CSS. But if I type this kind of code and save this here in React Native, we actually got no effect here, and I got an error here in the terminal and a warning here on my simulator. We can click on this to get more details, and we see that this is an invalid value for border. Actually, the key border already is invalid, so it's not even the value, but border is not a supported key. The reason for this is simply that this border property doesn't exist. I mentioned that the styling language is inspired by CSS and close to CSS, but it's not exactly the same. Instead, as we type border, we see that various properties exist which we can set. For example, we can set a border width property, and this again wants a number to set a certain border width in pixels, like 1 pixel. Or 2, or whatever you want. And then we can also set a border color. Now this does not want a number, but instead a string. And in this string, you could define a hex code value. Or you provide one of the supported shortcuts like red, or blue, or green, or black and white. And here I will go for red. And this will now add a 2 pixel wide red border around this text. Now I'll press the auto format shortcut to make this a bit easier to read, and then save this. And with this, we now got a border around this text. Now the border is pretty close to the text, but thankfully we can also add some padding. Padding, just as in the browser, is the spacing inside of an element. So here we could add a padding of, let's say, 16 again, 16 pixels, just as for the margin. And if we save this and auto format again to improve readability, Now we got some internal spacing. Now definitely feel free to play around more with those style properties. And of course also take a look at the official docs to learn more about styling if you want to, but you will see plenty of styling examples throughout the course. These style properties were all about styling the element itself that holds a certain piece of content. We will later also learn about style properties that help us with laying out multiple components and with achieving a certain overall look. But again, that is something we will explore later. For the moment, I want to leave this inline styling approach though. This approach of defining the styles in the same line as we define this component. Because whilst this is possible and allowed, it's rarely the best way of adding styling. So typically we should go for style sheet objects. The reason for this is that this allows us to clearly separate our JSX code and our styling code, and it also makes our styles reusable. If we define styles inline, and I want the same styling on this text, I have to copy and paste this so that I can add my style prop here and add the same styling. And I'll auto format this to make it more readable. So now I had to copy and paste to replicate this style, and that is typically something you want to avoid. What you should instead do is create a new style sheet object, or if you already have one, as we have it here, you go to this object and you add a new property. We already have the container property. Now on the same level, I'm adding another property. The name is up to you, and I'll just name it dummy text. Again, this is totally up to you. What's not up to you is what you set as a value though. The value should be an object, as we see it here for container, and in this object, you define your style properties. So here, I could now set my margin and so on. So I can set margin 16, border width 2, and border color, I'll set this to red. And I will also set my padding, and the order does not matter, I just group margin and padding together here since they're both about spacing, but we could also add padding here and it wouldn't matter. Of course, I could have also just copied down my object from up here. Now, with such a style object defined down here, we can use it here in our JSX code, as this container is being used. It is defined down here, but you can still use it in JSX because this only gets executed after the entire code file has been parsed, basically. So here we can now replace this object by referring to styles.dummyText, and I get nice autocompletion for this as well. And I'll do this here as well. And now, yes, we had to copy the word dummy text, but of course it's way less to copy. And if we ever adjust the style, for example, we change the color to blue, we don't have to do this in two places because the name didn't change. We just had to do it in one place instead. So if I save this, we now got a blue border. And that's how we use such a style sheet object. Now, why is it a style sheet object? So an object created with help of style sheet create, which is a built-in method on this built-in object, which is imported from React Native. Well, we could have also created a styles object like this and set our styles there. But using such a style sheet object has the advantage that we get convenient auto-completion as we type our style properties here. And that makes our development life a bit easier. In addition, React Native could potentially optimize style sheet creation and management internally and pick up style sheet objects like this. This is not done right now though, so for the moment the main reason is the auto-completion. But with that, we now learned some important styling basics and some important basics about core components. I would say as a next step, we should take a closer look at creating layouts and positioning multiple elements, because typically you don't just want a couple of centered pieces of text like this. Typically you're going for different layouts, and we need to know how we can create such layouts therefore. So let's explore how we can build real layouts where we don't just have a bunch of centered texts and buttons. And for this, I will actually clean up my JSX content, and I will remove this style prop here on the outer view for the moment, and remove all the styling here in this style sheet object, but I will keep the style sheet object. And now here in my view, I actually want to add another view, and below that another view. Now I'm doing this because I want to start building a basic interface here that allows us to manage goals. And the first view, the first nested view here, I should say, should actually hold the input area where users can enter the text for their goal and click a button to add that goal. And the second view should later hold the list of goals that are rendered. And I'm using two views as wrappers to have a clear separation between these two areas, and because that will help me with styling. So for this, I'll then therefore start by adding a text input component here in the first view. This is a component that allows users to enter text, and like all components, all core components, we need to import it from React Native. Now, text input is a self-closing component, and here we can, for example, add some placeholder text, as you could add it to an input element in the web, and say your course goal. Then, next to it, I want to add a button with a title of Add Goal. And then here in this view, I will add a text element where I say list of goals, and later this will become a real list. Now, if we save all of that, we see that everything is crunched here at the top. We also see that it goes beneath the status bar, and there would be different ways of fixing this. For the moment, I'll fix it by giving this outer view a style prop and defining a style which I'll name app container. And in there, I'll add a padding of, let's say, 50 pixels. And then here we can refer to styles.appContainer to add this padding to the overall outer view. Now, if we save this, we can see that there is more space around our UI. Again, later we will learn about different ways of making sure that we don't interfere with those native status bars and so on. Now, still, this is not the layout I want. For example, I want the button to be next to this input, not beneath it. I also want to have more space between the list of goals, and maybe this area where we add a goal should take up a quarter of the overall height, and the list should take up the rest. And that's where we need new styling features, styling properties about which we haven't learned before. Specifically, we need Flexbox. When it comes to building layouts in React Native apps, Flexbox is super important. And you might know Flexbox from the web and CSS, and in the next lecture, we'll have a little deep dive into Flexbox and how to use it. But Flexbox is a key approach, a key concept, which is basically a collection of CSS properties that you use to control how things look like. And the Flexbox implemented here in React Native, which can be set with all those React Native properties, is very similar to what you know from CSS Flexbox. In the end, Flexbox is all about a couple of CSS properties, or a couple of styling properties to be precise here, that are about positioning elements inside of containers. You can control how much space certain elements take up, and if they are to the left or right, or bottom or top of other elements. And the positioning is then controlled with the style settings that you apply to the container that holds other elements, as you will see in a second. Now, Flexbox is all about two axes which you have on a container. For example, the styles which you see here at the top, Flex1, Flex Direction Column, and so on, would be applied to the container that holds the three boxes inside of it. Now, the Flex1 instruction here, for example, would tell the container that it should expand to occupy all available space. though as you will see soon, this is seen in relation to other containers that might also take up space. And then flex direction controls whether the elements are laid out in a column, as you see it here, or in a row, as you see it here. So that all works. Basically, flex direction controls if the main axis, as it's called, is top to bottom or left to right. With column, it's top to bottom. With row, it's left to right. And then you also got other properties like justify content or align items that allow you to control how the elements are laid out in their axis. So if there is some space between them, if they're crunched together, and so on. So back in our code, this means that we can use Flexbox on this view, which is the container of text input and button, to control how these two elements are positioned. Because you learned, Flexbox is a concept that is applied to container elements to control how much space the container takes up. That's something we'll do in a second. And then how the elements inside of the container are positioned. That is what we'll do right now. For this, I'll add another style property here in my style sheet object, and I will name it input container. Now on this element, we can now set flex direction to row. And then we can apply this input container styling to this view. So here we add the style prop and then refer to styles.inputContainer. If we save that, you see the button is now next to the input element. So this already utilizes Flexbox because by default Flexbox is enabled on all those views. You can start using those flex properties right away. The default setting was that flex direction was column, which is why the elements were beneath each other. But if we switch to row, as I just did, they sit next to each other in the same row, which hopefully makes sense. Now we might want to control how they are laid out, and for this, we can add another property to the input container, and that is the justify content property. You will learn more about all these Flexbox properties in depth in the next lecture, but justify content basically controls how these elements are distributed in the row or column, depending on what the value here is, that they are part of. So here, for example, space between is one of the allowed values, and as you set this to space between, you see there now is more space between these elements. Now we can also still control the width of those elements. For example here, we could add a text input style object in our style sheet object, and I will add this to the text input here. And here I then want to add a border with a width of 1 and a border color of CCC, which is a light gray. By the way, I get a color picker here because of an extra extension which I installed. You don't need that though. And now, in addition, I will give this text input a width of, let's say, 80%. And this is also new. Now, in most places where you can set a size as pixels, so as numbers, you can also set sizes in percentage, though you need to wrap that in quotes. So you set a string in the end. But then you add the percentage sign and your percentage number to set a certain percentage. And with this, I'm saying that I want this element, which has this style, to take up 80% of the available width. The available width will be defined by the container in which the element sits, but then the element which receives this style will take 80% of that container's width. So therefore now I want to add this text input style here on this text input element, and we do this by adding the style prop and then it's styles text input. If we do this and save that, now we got this border and this looks like 80% width. Maybe we also want a little bit of margin to the right so that there is some spacing here. There is no spacing right now, despite having space between, because this takes 80% of the width and the button automatically takes the rest. And therefore, to add some spacing here, we'll add a margin to the right on the text input of, let's say, 8 pixels. With that, there is some spacing again. We could also add a little bit of padding maybe, so that the text isn't directly on the edge. So therefore, I'll also add padding 8 here on the text input object. So with that, we got some padding as well. Now that's it for this basic introduction to Flexbox. This is not all we'll do. This is not the finished layout. I do see that the spacing is a bit off here on the right and the left. I do see that the button doesn't look that great here on Android. And we will work on this, but first let's dive a little bit deeper into Flexbox and the different things we can do with it before we then continue working on this app. In this lecture, I want to dive a bit deeper into Flexbox, especially regarding how you use it in React Native apps. If you know all about that already, you can of course skip this lecture. So for this, I prepared a simple dummy application, and of course you find that attached. It's a normal React Native app built with Expo, and in the app.js file here, what I have in the end is just a view with 3 views in there, where each view then has a text with text 1, 2, 3. This simply creates some boxes with different colors, red, blue, and green. And now we'll use Flexbox to move these boxes around so that you can get a feeling for how Flexbox works, because it's so important. Now, first things first. By default, every view in React Native, even if you assign no special styles, uses Flexbox. And that's different to the web, for example. There, if you have a div, which would be your equivalent to a view, kind of, it doesn't use Flexbox by default. In React Native, it does. Every view by default organizes its children with the help of this Flexbox thing. Flexbox simply is a term, is simply a concept from CSS that is all about organizing child elements in a one-dimensional space. So here, for example, in a column. That's also another default. Not only does every view by default use Flexbox, it also by default organizes children in a column, so from top to bottom. That's also a difference to the web, and I don't want to emphasize these differences too much, because of course you don't need to be a web developer to build React Native apps, but I think a lot of people do know web development, do know CSS, Flexbox, and therefore it makes sense to also talk about the differences. So in the web, when you use Flexbox, not only is it not turned on by default, in addition, if you do turn it on, the default is to organize all child elements in a row, and here the default is to organize them in a column. You can change that default though, so in this case, on the view which holds my boxes, by adding flex direction here and setting this to row, for example. Now you will see that these 3 boxes are organized in a row from left to right. Now besides row and column, you also have row reverse and column reverse, and this simply also, well, does what the name implies. Now we still have a row, but the first element, the red box, actually is on the right and not on the left anymore. So that's also something you can do. Let me go back to row though. So that's the first thing you can do. Another important thing about Flexbox is how child elements are sized. Here, I gave every child element a width and a height of 100. Now, if we would remove that width and height thing on every child element, then you will see that now we have a very, very small row here, because every box now is only as wide as its child requires it to be, and only as tall as its child requires it to be. So every box here which holds a number is only as wide and tall as the number it's containing. Now you can change that with the surrounding Flexbox container too. Let's give that a width of, let's say, 300 pixels, or of 80% of the parent width. So in this case, since it's the root element, of the device width. And let's give it a height of, let's say, 300. If we do that, and now really important, I'm doing this on the view which holds all these boxes. I'm not doing it on the boxes themselves. So if we assign this width and height on the surrounding box, you see something interesting. The height is assumed for all the elements. Now all the views in the Flexbox take the height of the parent. The width has no impact here. That's also a default behavior you got here, obviously, since we haven't changed anything. The default behavior here indeed is that the child elements in a flexbox, so in this outer view here, are organized such that they align themselves along the cross-axis by stretching. Okay, that were a lot of terms. What does this mean? Now, when working with flexbox, we have two important axes. The main axis depends on your flex direction. For a row, which we have here, flex direction row, the main axis is from left to right. For row reverse, it would be right to left. For column, it would be top to bottom. And for column reverse, it would be bottom to top. So that's the main axis. And then you also have a cross axis, and that's simply the opposite of the main axis. So for a row where the main axis is from left to right, the cross axis would be from top to bottom. If the main axis is from right to left, which would be the case for row reverse, then the cross axis would be from bottom to top. Okay, so that's the main axis and cross axis concept. Now you can organize your child elements. So in this view where we have the three boxes as child elements, you can organize these child elements along these axes. You use justify content to organize elements along the main axis, and you have align items to organize elements around the cross axis. Now you see the values you got for justify content here if you add these quotes or if you place your cursor in there and you hit Control Space. You see you can center elements, you can position them at the end or at the start of that container, or you can add some space in between. For example, if we use space between here and we use align item center, then things will change. Now you will see they're taking the width of the surrounding container. Every box itself still is pretty small, but they're split or they're distributed across the width of the parent container. And they're no longer taking the height because along the cross axis, we're aligning them with align items. And there I set this to center. The default here is stretch. And if I set it back to stretch, then unsurprisingly, they do stretch for the entire height. Now, if you want to make sure that they take the available width, you can't set stretch here on justify content, which is your main axis positioning vehicle. So you can't set stretch here. So what can you do regarding that then? Well, that is something you now configure on every child item itself. You can tell a child item how much space it should take of the space it's potentially getting. Stretch here is kind of a special case. There you set this up on the parent item. Normally you set this up on the child item. So for example, if I set this to center now so that the parent doesn't tell the child how much space it should take, then we can fully control the space a child takes by going to the child style, and there you can add flex, the flex property. The flex property is applied to items that are inside of a flex box, so that are inside of a view in this case here. And that can be a view itself, but that could also be another component like a text, for example. So now here you can add flex and you can set this to a value of 1, for example. So flex needs to be a number. If you set this to 1, what you will see is that now the red container, where I did set flex to 1, takes all the available width it can get, just so much that it leaves enough space for the blue and the green container so that they can squeeze their content into the surrounding flex box. Now we can't see the boundaries of the surrounding container, but the boundaries would essentially be where the red item starts and the green item ends on the horizontal axis here. So now flex 1 makes sure that the red item gets as big as it can get. So it takes as much space as it can get. By default, views only take as much space as their child elements require, so as this one character required. But with flex 1, you change this, and they now take as much space along the main axis, so along the width here, as they can get. For the cross axis, again, that's a special case, you have to do this on the parent. For the main axis, and since we have row here, the main axis is a horizontal axis from left to right, you do this with the flex property on a child. Now, of course, you can add flex to other child elements as well, like to that second, to that blue container with the 2 in there. You can add flex 1 there as well. So now I have flex 1 on the red container and flex 1 on the blue container. And what now happens is that both of them take the available free space, and amongst these two boxes, the space is distributed evenly. And that's what this number here indicates. This number is a relative number. All items in the same flexbox with the flex property distribute the available space by considering the number you assign here. And these numbers are relative to each other. So if I give the blue container flex 2 here, then this means that of the available space you have in that surrounding container, after deducting the space every element needs to squeeze its content in there, the blue container will take twice as much space as this one, because here we have flex 1, here we have flex 2. If we had flex 3 here, then this would take 3/5 of the available free space, because we have 3 plus 2, so we have 5 available segments, so to say. And here the red container would take 3 segments, blue container would take 2 segments. If we have 1 and 2, then we have 3 available segments, and the blue container takes 2 of them, red takes 1. So you always add up these flex numbers and then distribute, or that's automatically done of course, but then the available space is distributed accordingly. So now here we'll see that the blue container is twice as big as the red one, or it takes twice as much free space as the red one. So this is how you can work with flex. You can organize how items are positioned with flex direction, with justify content, and with align items. And you can also make your items grow and shrink with the help of flex. So now that's a brief introduction to Flexbox in React Native. As I said, inspired by Flexbox for CSS. So if you knew that, all of what I explained here is probably not new to you. We'll work with Flexbox throughout this course, so there things will also become clearer and we'll work a lot with it, and you'll see how you can create beautiful user interfaces with Flexbox. Flexbox in the end is the tool in React Native to structure your content on a page, to organize your content. And you typically work with a lot of views, which you also nest into each other, so that you can position elements the way you want. Because of course, and that's also important, you don't just have to have one view in your app which uses Flexbox. You could have another view in there which also uses Flexbox. And actually, as I mentioned, every view by default uses Flexbox. And you can then nest these views into each other so that you position everything the way you want. And you'll also see this in this module already. And actually, I'm already doing it here. In my views here, which are in the surrounding view, so my boxes here, there I also use justify content and align items to center my numbers in these boxes so that 1, 2, and 3 are centered there horizontally and vertically. And that works because we have Flexbox turned on by default and we can't turn it off, by the way. And therefore, I just use these two properties here to align my content of this view along the main and the cross axis. And here, since I set no special flex direction for this view, the main axis is top to bottom because the default flex direction is column, and the cross axis is left to right. That's just a side note. So now after this deep dive, let's use our newly gained knowledge to improve this overall layout. One thing I will do, for example, is work on this app container padding. This actually doesn't use any of the new knowledge, but I need to do this to make this look a bit prettier. I basically just want to have a padding to the top of 50, and then I want to have a padding horizontal, so left and right, of 16. So not of 50, but of 16. With that, I'd say this generally looks better, though we can see that this padding is kind of ignored and our button here is going off the screen. This can be fixed by decreasing the amount of width our text input has to 70% maybe. Now this looks better. What doesn't look better though is where this text is in this button. This is something we can improve with align items on the input container though. At the moment the problem is that basically this button is stretched to be as high as this text input. And the text is then not centered in the button because the button doesn't have any styles that would center the text. Now you could think that maybe we can add some styling to the button, but it turns out that the button is a component that doesn't have a style prop. It might look like it has because I'm getting some autocompletion here, but that's actually only some autocompletion I get here because I typed the word style before in this code file. The proper autocompletion that tells me that a certain prop is supported looks like this, with this kind of icon next to it. So the button doesn't have a style prop because indeed it doesn't support styling. You can always check out the official docs and dive into an element there to see which props it supports. And for example, on the button there is no style prop, whereas on the view, for example, you do find a style prop. But that's just a side note. That's why we have to fix it differently, and we can fix it by not stretching this button. That would be one way of achieving this. So we can set align items here on input container and set this to center instead of stretch. With that, the button is now centered and looks better. We could also build our own button, but that is something you will learn later. So now this looks better. I also want to change how much space this input area takes up though, and how much space the list of goals takes up. To achieve this, I'll do a couple of things. For example, I want to add some padding to the bottom on this input container of, let's say, 24. So that there is some space between the view that holds the text input and the button, and the view that will hold the list of goals later. You can see that spacing here now. We also could add a little border here. So we could add a border to the bottom and give it a width by setting border bottom width of 1. And then adding a border to the bottom and giving it a color of, let's say, maybe this gray again. But of course, you can pick any color you want. Now we got this border, and below that, the list of goals. But now I want to make sure that my text input area takes up 1/4, so a quarter of the overall available height. And this can be done with the flex property, as you learned. We can set this to 1, and then add a styling object to this view that holds the list of goals that takes up 3/4 of the available space, which can be achieved by adding flex 3 to this view. So therefore, I'll add another styling object in my style sheet here and name it the goals container. And here I'll set flex 3. As you learned, all the flex values are added together as long as the containers to which they are added are siblings to each other and are part of the same surrounding parent element, which is the case for these two views. And then the space is distributed accordingly. So 1 plus 3 is 4, and therefore this takes 1/4, and this will take 3/4. We just have to add this here, so I will add a style prop to this view and set this equal to styles goals container. With that, it will look horrible. And the reason for this is that we also need to work on the outer container now, the container that holds these two containers on which we just set the flex properties. This outer container needs to take up the entire height of the app so that the inner containers can then distribute this space. By default, without adding the flex property, this container will only take as much space as it needs, and that's only defined by the space the content in the container takes up. But now that we're setting flex on those containers in the container, this doesn't work anymore. And to fix this, we need to force this container to take all the available height, and we do this by simply adding flex 1 to the app container, so that the outer container takes all the height, because it's the only container here, so flex 1 will give it all the space, and then the inner containers can divide that available space. So by adding flex 1 to the app container and saving this, this now looks better, and now this is 1/4, and that here are 3/4. Now if I look at it like this still doesn't look perfect, so what we might want to do is actually give that list here 4/5 of the available space, so that goals container will get 4 and the input container stays at 1. And instead of setting a padding bottom, I will set a margin bottom here. on the input container. And with that looks better. We could maybe even go to flex 5 down there and leave it like this. Feel free to experiment with this and choose your own values. But this will work for me, and this is now Flexbox in action to achieve a first basic layout. Of course, this is not the final layout we will have though. So we did add some styling and a basic layout. This is nice, but of course not all we want to do. In most apps, no matter if we're talking about web apps or native mobile apps, we also want to allow the user to interact with the app. And we got a text input here, and we also got a button that could be pressed. But at the moment, of course, nothing happens if you type here or if you press this button. This is ignored. And this is ignored because we're not handling these events. And just as with a web app that you're building with React, you of course need to handle them if you want something to happen. The good news is that you do handle events in the same way you would do it in web apps though. You can add event listeners and connect them to event handler functions, and you can manage state in your components with the use state hook just as you would do it in any other React app. Because this is just a React app, the only difference, as you learned in the first course section, compared to a React app that targets the web, is that we use a different platform with React Native instead of React DOM. But when it comes to React's core features, like handling events or managing state, that all works in exactly the same way as you know it from React for the web. And here I got 2 events that I want to handle. The first one would be a click on this button, but before we handle that, I also want to handle keystrokes on that text input element so that I can grab the value the user entered and so that we can then use this value to finally add a new goal in this list of goals as a next step. And therefore, these are the first 2 things I want to do. I will add a function that could be called goal input handler that is responsible for fetching that user input as the user types. Then I'll add another function, add goal handler, which should be fired when this button here is clicked. Now to connect those functions, we use special event listening props that are provided by React Native on its components. For example, to connect goal input handler to text input, we can add the special onChange text prop. This is a prop exposed by React Native, which wants a function as a value, a pointer at a function. In my case, I'll point at this goal input handler function, so I'll pass that as a value here. And I'll press the auto format shortcut to make this a bit easier to read. Now please note that I don't execute this function here. I don't add parentheses. If you would add parentheses, this function would be executed as soon as this code is parsed and evaluated. And this would be too soon because that would be the case when this user interface is rendered. I don't want to do that. Instead, I want to point at this function so that React can execute it for me whenever this text changes in this input. And that's what will happen if we set it up like this. Now in this goal input handler function here, we then receive the entered value automatically. Because keep in mind, it will be React that calls this function because it's React Native that exposes this prop. And therefore React, or to be precise React Native, will also provide us a value as an input, as a parameter to this function, and that will be the entered text. So we get the entered text automatically. And then we could, for example, console log this here, like this. If we save this code and we have the npm start process up and running, we can go back here and, for example, enter test. And as I type this here, you see the log update here in my terminal with every keystroke until we have the word test. So that's how this works, and this works totally on its own. So that's how we can get the entered value. Of course, we don't want to get the value because we need it in this function though. Instead, we need it in this function, so we need it when the button is clicked. And for this, we need to connect this function to a button click as a first step. Now, if you would be building a web app and you had a HTML button here, you would add the onClick prop. But with React Native, this prop doesn't exist on a button. But we have a similar prop. It's called onPress. It's called onPress instead of onClick because technically we don't have clicks in native mobile apps. Instead, we have tabs or presses. So here we have onPress, and just as with onChangeText, here I point at my function that should be executed. In this case, addGoalHandler. So now this function will be triggered whenever the button is clicked or tapped. Now we want the value entered in this text input in this function. So what we need to do is we need to store it as state. We need to store it as state, which is updated with every keystroke in this function, so that we can then use it in this second function. And state management works just as it works in any other React app. We can import the useState hook from React, so not from React Native, but from React, the core React library itself. And then we can register a new state here in our app component function, just as we do it in any other React app. So here I'll call useState and set this to an empty string initially, because this will be my user input state or my entered goal text state, which can be updated with the setEnteredGoalText function. And in case this syntax doesn't tell you anything, definitely have a look at some dedicated React resources like my React Complete Guide course, because this is standard React and you should know syntax like this. So now we got this entered goal text state, which initially is an empty string, but with every keystroke in my text input, I will update it and set my entered goal text to the entered text I'm receiving here as a parameter. And therefore now in addGoalHandler, we can access this state and do something with it. And for the moment, I will simply console log my entered goal text state here. But of course, soon we will update a list of goals, which we then output down there. So let's save this. And now here, if I enter test and click add goal, we got this test log here. Or if we enter some other text to see that this is really coming from our updated code, now we see some other text here. So this is working as intended. The next step now is to make sure that we can manage a list of goals, which we then can also output. So let's now manage that list of goals. For this, I will again add some state here, because my list of goals is also some data that changes dynamically. And as it changes, the UI should be updated. And that's a typical case for using state. And this state will be initialized with an empty array because I want to manage a list of goals. And initially I have no goal. Now I'll give this state a name of course goals, because these are my goals for this course, let's say. And the setCourseGoals updating function. And now in addGoalHandler, instead of logging our entered text to the console, we can call setCourseGoals and update our goals. And in the end, I want to take my existing goals and append a new one. Now there are various ways of doing that. One way would be to create a new array and use the spread operator, these 3 dots, which is standard JavaScript code, modern JavaScript code, to spread my existing course goals into this new array so that I keep all the existing course goals, and then I add my new goal by adding the entered goal text, let's say, as a new goal. In this case, a goal is simply a string. We could do this, but if you followed a good React resource like my course or the official docs, then you know that this is not the best way of updating state if your new state depends on the previous state, which this state here does. If your new state depends on the previous state, a better way of updating is to pass a function to this state updating function, a function which will be called automatically by React to then derive the new state. And this function will automatically receive the existing state by React. So here we could turn this into an arrow function that gets the current course goals as an input, let's say, so as a parameter. And again, the value for this parameter will be provided automatically by React when it calls this updating function, or this function that's passed to the updating function to be precise. And now this value, current course goals, can be used inside this arrow function body. And now we do derive this new state in a better way. The other approach would have worked as well, but this is a recommended way, a best practice way of updating your state. So now we're updating this course goal state based on the old course goals by appending a new goal. The next step, of course, is to now output the list of goals here. And how does this work? Well, it works basically as it does in React for the web as well. We have an array of values which we want to output. And in React for the web, we would use the map method typically to map our array of data, of strings or objects, into an array of JSX elements, which can then be output in the JSX code returned by this component. And we can do the same thing here. Instead of outputting this dummy text down there, I want to output something dynamic, which we do by adding curly braces, opening and closing. We can now refer to the course goals array and call the map method on it. A standard JavaScript method, because we are writing standard JavaScript code here, as you learned. Now this map method receives a function, as it always does, and here I'll pass in an arrow function, which as an argument, as a parameter, gets the individual values stored in course goals. So my goals here, the single goals I have in this array of goals, this function is called for every item in the array. So every function call receives a single goal. And then as a return value in this arrow function, we return the JSX element that should be rendered for the individual goal. And in this case, I want to output the goal text. So here I will render a text JSX element. And then between the opening and closing tags, I output goal. Since my goals are just strings here in this array, because I just add my entered goal text, which is just the text that was provided, and therefore just a string, I can simply output the goal between those tags like this, because goal will just be a string. And with that, if we save this, and we give this a try here, learn React Native, if I click add goal, this is added. But we also get a warning here. The same will be true on the iPhone here. If I learn React Native, it works. If I learn it with multiple exclamation marks, I still see that it works. I add another goal now as expected, but we get a warning here. We get a warning that each child in a list should have a unique key prop. And this is actually a warning you might know from React for the web as well, because this is a warning that has nothing to do with React Native. Instead, with React in general, when outputting a list of data as we're doing it here, every item in that list should receive a key prop, which uniquely identifies the individual list item. Under the hood, this helps React update the list in an efficient way, so to say. I do explain this in greater detail in my React course, but you should always add this key prop to the individual items that you're outputting as part of a list. Now, the value you pass to key can be anything, but it should be something unique that uniquely identifies the concrete value that you're outputting here. In this case, I'm just outputting goals, which are just strings, so I'll take the goal string itself. This is actually not necessarily unique, because I could enter the exact same goal text twice, but it's good enough for now. We'll improve this soon. Now, with this key prop added here, though, now if I add another goal, I don't get the warning again. And of course, here we don't have to enter the same text all the time. We can also learn different pieces of text, like learn all the details. And as you see, our list keeps on growing here. So with that, we're now able to handle the user input, store it, and react to a tap on this button. And then we do something which you certainly did many times with React for the web. We're outputting that data here in a list. But that's of course not all we want to do. Outputting the data in a list as we're doing it here is nice, but it would also be nice to have some styling on those list items. And therefore that's what I want to do next. Of course, feel free to also pause the video here and practice this on your own. Apply some styling, any styling of your choice, to these individual list items, and then compare your solution to mine to see how I styled this. Now here's what I will do. I will create a new object that keeps or that holds the styles for those list items, and I'll name it goal item. The name is up to you though, here in this style sheet object. And then in this object, which defines the styles for this identifier, you can set up any styles you want. And I'll give every goal item a little bit of margin, for example, so that we have some spacing around it. Maybe 8 pixels. I also want to add a border radius here so that we have rounded corners. And this also wants a value that's defined as a number. And here I'll set this to 6 pixels. Now to make sure that we can see this radius, I will give this a background color so that this item has an overall background color of a specific hex code that I prepared ahead of time, which is 5E0ACC, which is a nice purple color. I also want to have some padding in here, so I'll actually add it next to the margin, not because it's required, but to keep those related values together. And I'll add a padding of, let's say, 8 pixels as well, so that we have some inner spacing as well. And last but not least, I also want to add a color here, and I'll set this to white, and this will be the text color. So again, you see the property names are pretty similar to what you know from CSS. We of course have this camel casing instead of using dashes, because dashes are not supported in JavaScript. But besides that, the names should look familiar. Now we can assign this goal item style to our text items here. So here we can add the style prop and set this equal to styles.goalitem. And I'll reformat this to make it a bit easier to read. With that, if we save this updates and we see our items here. What you will see is that we got this changed styling, but actually on iOS, the rounded corners are missing. We only have them on Android. Now, why are they missing here? And what can we do to fix the styling there as well? This is a good time to talk about the differences between the two platforms. The idea behind React Native is that you can write code with React that will actually give you native mobile apps for multiple target platforms. So you don't need to write different code to target different platforms, but one and the same code base can get you there. Now, this is generally true, but as you will also learn later in the course, sometimes there are differences. And sometimes you need to make tiny code adjustments to target all platforms in the right way. And for example, here we got a difference. The rounded corners are missing on iOS because we added our styling here that applies the rounded corners directly on this text component. Now it turns out that this text component is translated by React Native to a fitting native widget, a native UI element. And the element to which it is translated, in case of Android, seems to be an element where corners can be rounded. But in case of iOS, it looks like the underlying native text output element does not support rounded corners. And that's why border radius has no effect on the text elements on iOS. Now, to work around that, we can wrap our text here in a view. So in this more generic container element. This is also translated to a fitting underlying element, and it turns out that the underlying element to which view is compiled by React Native is an element that supports rounded corners on both platforms. How do I know that? from the official docs and experience, and I'm explaining it to you in this course so that you don't have to find it out the hard way. So what we can do now is we can grab our style assignment here and add this on this view, and also add the key here on this view, because now the view is the main element that's output here in the list. The text now is a nested element. We still need the text because we still have some text to output, and as you learned before, text must go between text tags. But the styling is now applied to the more versatile view element. If we do that and we save everything, we now see the rounded corners on iOS as well. What we also see though is that the text is no longer white. Now we still have the color white setting here, but this is part of the goal item, which now is actually assigned to this view here, not to the text. And unlike in CSS for the web, the styles don't cascade. That's another important learning here. We do have this CSS-like property language here, if you want to call it like that, these CSS-like property names, but it's not CSS, it never was. So therefore, core CSS characteristics, like the cascading nature of CSS, where child elements and descendant elements inherit styles from parent and ancestor elements, is not part of React Native's styling approach. We don't have style inheritance here. So if we assign a text color to the view, this does not affect this text, or the text inside these text tags to be precise, because that's a totally standalone element. It is not related to this view, it does not inherit any styles from that view. So setting the text color on this view does nothing to the text inside that text element. Therefore, what we need to do is add another style object here, the goal text. That sounds like a fitting name. And we set our text color on that and remove it from goal item on the view. We could leave it there, but it doesn't have any effect anyways. With that, we now set our text color here. And now we can add this goal text style to this text here. So we add the style prop and set this equal to styles.goal text. And with this, if we save this now, we now have the white text back and we have the rounded corners. And this is really important. This is something you must understand about styling and about targeting different platforms. The general idea is that you have one code base that targets both platforms. But still there are differences under the hood. And some differences can simply be solved like this by adding an extra wrapper. Later in the course, you will also learn that sometimes you need to write totally different code for different platforms. And you will learn how that works as well. And you also learned that styling is a bit different than in the browser. It looks like CSS, at least a bit, but there is no inheritance and no cascading going on. That's why you really have to set the styles on the elements where they are supported instead of some global parent element. Just as the rounded corners couldn't be applied to the text color applied to this view didn't have any effect to the internal text here. We need to set that on the appropriate text element. And these are these tiny details which you will see over and over again throughout this course and which are super important when you're working with React Native. But with this, we now got the look we want here. And hence, we can now move on and dive a bit deeper into how we can and should output lists like this. So we got our list here. Now, one thing you will notice about this list is that if I add more and more items here, and I just add exclamation marks to make them unique, at some point we will go beyond the available space. Now, you would expect that you simply scroll now, but it turns out you can't scroll. No matter how you try, this is not scrollable. Because by default, the view generated here, this view that holds everything in our app component, is not scrollable. That's also a difference compared to the browser. On a website, if you exceed the available space, by default, scrolling bars will appear and you can scroll the website. This is not the case here in mobile apps. If you want to scroll, you have to explicitly tell React Native and the native platforms. Now, of course, this is a common problem and scenario though, and therefore making lists or content in general scrollable is very easy. There is a dedicated component provided by React Native that helps you. And that's the scroll view. We import scroll view from React Native just as we imported text input button and so on. And scroll view does what the name implies. It gives you a view, so such a container element, which will be scrollable. And therefore we can now use this scroll view around our goals here. So let's try replacing this view here with our scroll view simply. We add scroll view here instead of view around our list of goals. And I leave my style on the scroll view. Keep in mind, this style here controls that this container takes up a lot of space. If we save this doesn't look too good. This now is indeed scrollable as you see, but the space is different than it was before. We have way more space for the input and way less space for the list. The reason for that is that the scroll view has the job of making something scrollable, but the area that's scrollable is in the end determined by the parent, the container that holds the scroll view. So what you should do here is add another normal view, which restricts the available height, to which you then apply the style that sets the height that will be taken up by that view. So that is the setup we had before, but now we have a scroll view inside of that view. So the outer view controls how much space this area of the screen should take up, and the inner scroll view then makes sure that this space and the items in that space, to be precise, will be scrollable inside that overall space. That's how we set up such a scroll view and how we let it interact with the surrounding container. If we set it up like this and we save everything, we get the same proportions as before, but now indeed, as you see, this list is scrollable here. And that's of course what we want, because now we have a list where we can add more and more items, and it stays scrollable as we exceed the available space. Of course, if I force a reload by pressing R here in the terminal, and I then go back, all the data is lost, and now you see nothing seems to be scrollable here. If I add a single goal here, we do see though that this is indeed scrollable, but of course it's not really scrollable. It always jumps back to the top because we don't exceed the available height. So scroll view is super useful because it does allow you to make lists or content in general scrollable. Now you can learn more about scroll view and the props it supports in the official docs. I want to draw your attention to those props here because there is a lot you can configure about the scroll view. You can, for example, configure how it bounces. And you also see that some props are specific to iOS and others are specific to Android, whilst yet others are available for both platforms. And again, these are some of these platform differences which we will encounter here and then throughout this course. For example, you will notice that in our app here, I can scroll and I have this bouncing effect. If I would want to disable this, I could set always bounce vertical, which is true by default, to false. So if I go to scroll view and I set always bounce vertical to false, and I then save this, you will notice that here on iOS, if I now try to scroll, this bouncing effect which we had before is gone. Now if I add more and more goal to make sure that I exceed the available space here at some point, it still is scrollable, and now it also bounces, but it didn't bounce if there was not enough content to fill the available space, the available height here. If you do want to set this or not is totally up to you and which look and feel you want. But it is important to be aware of the vast configuration options you have here, and therefore taking a look at those props here and understanding what you can set and how you can use this view is definitely something I would encourage you to do, because every app you're building will be different and every app needs slightly different configuration. And therefore, the official docs are always a great place where you can find all kinds of supported configuration settings. So we got our scrollable list here, and this is implemented with this scroll view. Now, this solution has one downside, one disadvantage though. Scroll view is great if you want to add scrolling around some content. For example, if you had an article which would be too long to fit on a screen, or you simply don't know which device sizes your users will be using and you want to make sure that an article, for example, is scrollable, in such situations, scroll view is perfect. For lists as we have it here, it's not perfect though. The reason for that is that lists like this could become very long. Sure, you might only have like 10 or 20 items on there, and especially for such a goal list, it's very likely that you have around that size or around that amount of items. But you could also have lists with hundreds or thousands of items. Now, what scroll view does is it always renders all the items that are inside of it whenever the overall UI is rendered. So even if an item is not currently on the screen, like this last list item here, this item is still rendered behind the scenes even though it's not visible yet. Because scroll view renders all its child items, no matter if we're talking about 10, 20, or 10,000 items. And for very long lists, this can become a performance issue. If you have a long list with dozens or hundreds or thousands of items, rendering them all at the beginning, even though the vast majority is not even visible to the user, will slow down the app, and of course that's not something we want. Therefore, scroll view is great for limited amounts of content, like an article which has a fixed end at some point. But for dynamic lists, which could become super long, we typically don't want to use scroll view. We can, but we typically don't want to avoid possible performance issues. A better solution for such scenarios is another built-in component that ships with React Native, the flat list component. This is another component that will help with scrolling, but as the name suggests, it's specifically built for scrollable lists, and internally it will only render the items that are actually visible, and all the items that are off screen will only be loaded and rendered lazily as they are needed because the user is scrolling. Now, internally, Flatlist will have a small threshold to make sure it already starts loading and rendering items before they are visible, but it will only render them as the user gets closer to them as he or she is scrolling the list. If you have 1,000 items in your list, the vast majority of items will not be loaded and will not be rendered when using Flatlist. So how do we use Flatlist then? Well, you do use it by replacing scroll view with it. So we replace scroll view with Flatlist. Now, regarding this always bounce vertical prop here, this is still supported. So you can leave it there because Flatlist actually supports pretty much all of the props scroll view supports. Because internally it kind of has a similar implementation, but with this optimization of only loading data when it's needed. So this is a first step, but we're not finished yet. We replace scroll view with Flatlist. The next step is that we get rid of our custom mapping code here. We remove that. We no longer map our data manually. Instead, we now have to pass this task to Flatlist so that it can render this list efficiently by only rendering what's needed. Flatlist is now in charge of this, hence we need to let Flatlist do that. And this is done by giving Flatlist two important props. The first one is the data prop, which is a required prop. This is a prop that points at the data that should be output in this list. In our example here, that would be the course goals array. That's the data that should be output as a list, so we pass this as a value to data. But that doesn't tell Flatlist how the data should be rendered. You don't tell Flatlist by passing content like this between the opening and closing tags. That's not how we use Flatlist. Instead, we should cut this, and we can turn Flatlist into a self-closing component, and we add another key prop now. And that's another required prop, the render item prop. This is a prop that wants a function as a value, a function that will tell Flatlist how to render the individual data items. Therefore, it is a function that will receive the individual item as a parameter automatically. Flatlist will pass in this item whenever it calls this function, and it will call this function whenever it determines that a new item must be rendered because the user is scrolling and a new item should be made visible. And therefore, in this function, in this arrow function which I defined here, you then return the JSX code that should be rendered for a given item. Now, of course, we want to output our item data, and we receive this item parameter value automatically by Flatlist. But this item which we get here is actually an object generated by Flatlist internally. An object that is wrapped around the individual data items we have in our data array. And therefore, I will actually name this item data because it's actually an object that does not just contain our values, but also some metadata. Now, item data does, for example, also give us access to an index property. Again, this object with this property is generated by Flatlist, and this holds the index of the different items that are rendered. First item here has an index of 0, the second item has an index of 1, and so on. But item data also holds another property that's very important for us. And that's the property I will output here, the item property. This will hold the actual data items, one for each list item that's being rendered. So with item data.item, we get access to the different data items we have here. Now with that, we can get rid of this key prop because we're no longer mapping this list manually, and hence keys are no longer managed like this. We will come back to keys in a second, but for the moment we'll remove it. And now I will reload the apps by pressing R here in the terminal with the terminal selected. And if I now add another new item here, you will see it shows up, and I can add multiple items here. And if I add enough items to exceed this screen height, so if I add more and more items here, you will see that this list also is scrollable. I can scroll here. But you also see, of course, that I'm getting a warning. I did get it right from the start, actually. And the warning is in the end that I'm missing some keys here. Because it's still a list, and therefore we still should add keys, but we don't add them as we added them before. Instead, when using Flatlist, there are two main ways of adding keys to these list items. The first approach is to turn your data values from primitive values like strings, as we have it here, into objects that have a key property. And that's what I'll do here. When I add a new course goal, instead of just adding the entered text like this as a goal, so as a plain string, I will wrap this into an object where I, for example, have a text property that holds the actual goal text, but where I actually also add a key property, which I set to a unique key. Now, to generate a unique key here, I will actually use math random to string like this, which is not really a unique key. I could generate the same number twice, but it's good enough for this demo here. And now with that, every item in my course goals array is actually an object with a text property and with a key property. And the special thing is that Flatlist will automatically look for such a key property. So Flatlist does work with primitive values in the data array as well, as you saw a couple of minutes ago. But it works even better if your data in this data array is a list of objects. So if you have a list of objects as data, and every object has a key property, because then this key property will automatically be used as a key for the items that are rendered. Now that we turned our items into objects here though, we have to make sure that when we access the data that belongs to a single item, we dive into the text property here on the item. Because every item is now an object with a text property. That's what we set up here. Hence, we have to access this text property down here. And with that, if we save this and again reload this, and I now start adding items here, you will see that now I can add items as many as I want, and I don't get this warning anymore, and I got this scrollable list. And under the hood, only the items that are needed are being rendered, and the other items will be loaded lazily as we scroll closer to them. That's how this flat list works now. Now, if you don't have a property named key, because you're maybe getting data from an API and you can't influence its shape, and you don't want to transform it just because flatlist needs that key property, you also got an alternative to setting up such a key property in the input data. Let's say this would be named ID. This would be a reasonable property name, because this could be a unique ID, but it would be the wrong name because this list is not looking for an ID property, but for a key property. Now, of course, we could transform it, but if you don't want to do that, you can go to your flat list and you can add another prop to the flat list component. And that would be the key extractor prop. The key extractor prop wants a function as a value, for example, an inline arrow function, but you could also define a function somewhere else and pass a pointer at it here. And this is a function which will automatically receive two parameter values, item and index. These two values will be provided by flatlist when it calls this function for you, and it will call this function for you for every list item that's being rendered. Now, the render item function is also called for every list item that's rendered, but the render item function is responsible for generating the JSX code that should be rendered for every item. Key extractor, on the other hand, this function is simply called to get a key out of every item, which then under the hood will be attached to the item by the flatlist. And therefore here you should return the key. And since you get the item as the first parameter value, and since I know that every item for me is an object with an ID property, and since I know that the ID property makes for a great key, since it will be unique, I can return item.id here. And with that, I simply tell flatlist how it gets to a unique key for every item it outputs. So with that, if I save this and I then again reload everything here, if I again learn React Native here, this works as before, and I don't get any warnings. This, of course, also works here on Android, if you want to see it there. I can add multiple goals there as well, and there it's also scrollable. So that's flatlist in action, and you should use flatlist whenever you have lists with dynamic data that should be scrollable, and especially if you have lists that could be super long, then for performance reasons, flatlist is better than scroll view. So by now we already learned a lot about important React Native components and concepts in general. Our app.js file is getting bigger and bigger, and this is something that happens in most React apps, no matter if you're building for React Native or if you're building for the web. Your components get bigger as you add more functionality. Now, what you do in such cases is you break up your components and you split them into smaller components. That is a common approach and a common best practice for keeping your code maintainable. And it's no difference here for React Native. Thus far, we're working with one component only, but this, of course, is the exception. The norm is that you do work with multiple components, and we want to do that here as well. For this, I'll add a new folder in my project, which I'll name components, because I want to store my components in there. You don't have to use this name, but it is a common convention since we will be building and storing components in there. And then I want to add 2 component files in there. Goal input.js, because there I plan to store the data input related JSX code and functionality. And goal item.js, here I plan to store the actual JSX code and functionality that is related with outputting single goal items. And of course, you could split this into more components if you wanted to. Now I'll start working on this goal item component. In there, I'll add a function goal item because I'll create a functional component, and I will export this as a default. So I will build a standard React component in there. Now you don't need to import React from React here. You did need to do that in the past, but with the modern versions of React Native and React, you don't need to do that anymore, and therefore a functional component can be created just like this. Now in this goal item component, I want to return some JSX code. And I actually want to return the code that is responsible for outputting a single goal item. So not the list of items, but a single item. And that means I want to use this code here. Hence, I will cut this code from app.js and return it here in goal item.js. Now, of course, here I'm referring to some styles though. And those styles, therefore, also should be brought over. For this, I have to create a new style sheet object that belongs to this component, so to this component file also. And hence, I will import from React Native, and I will import the style sheet object here, which allows me to call the create method, which creates a new React Native managed styling object, which helps with auto completion and so on. I'll store this in a constant named styles, though the name is up to you. But since I'm already referring to this kind of constant here in my code, I will keep the name here. Now, as a side note, we could have also passed our styles from app component to goal item component via props. We don't have to define the styles here, but it is a good practice to keep your styles close to your JSX code, and therefore I want to move my styles that belong to the goal item from the app component into the goal item component as well. And that would be these 2 objects with their style properties. I will cut them in app.js and move them over to goal item.js. And here in this object, which we pass to the create method, I'll paste in these 2 properties. And with that, I can reference those properties in my JSX code. So with that, we're creating this component. We still need to take care about this text, but we get our first component. And in app.js, we can now import this component. We can now also get rid of some imports which we don't need anymore because I'm, for example, not displaying a text component in there and I'm not using scroll view anymore. But I will now import goal item from components goal item. And this works just as it works in a regular React app. We import our components from other files like this. We have a capital starting character because we plan on using this in JSX. And we want to make it clear to React that this is a custom component. Hence, we start with a capital character. Now, down here in our JSX code, where I return some markup inside of render item, I now return my goal item component, so my own component. And this is how we define and use a custom component. And of course, in the end, it's totally the same as we would do it in a React for web project. There isn't really any difference here. Now, of course, we will need to pass some data to goal item though, because we got the item data here in the app component, and we need it here. And this is a problem solved with props. Again, just as we do it in any React app, because we are building a regular React app here. We have a regular React component, and we can use props therefore. And we can expect and use any props we want, because it's our component. So here, for example, we could expect that on this props object, we get a text property. or a value property, whatever you want. I will go with text here. And now we just have to make sure that in the place where we use this component, so in the app component here, we pass this prop so that we set a text prop here on goal item in the app component. And then here we have to pass in item data dot item dot text. Because again, text is the property that holds the actual text, and I want to pass this text as a value to the text prop in my goal item. And with that, if we save this and I reload everything, if I go back and I learn React Native here, this crashes because of this error, can't find variable view. What's wrong here? Well, what's wrong is that in the goal item component, I'm using the view and the text components, but I'm not importing them. And I showed this on purpose because this is important to understand. If you're working with React for the web, you can use divs and h2 elements just like this. You don't need to import them. That's different in React Native. There, all these components are provided by React Native, and you have to import them in order to use them. So besides importing the style sheet here, we also have to import view and text, because we're using these two components in this JSX code. And once we import them, if we now reload our apps again, you will see that now, of course, if I do learn React Native, this works again. And now it's looking the same way as before, because in the end we get the same UI as before, but we're achieving this with help of another custom component. So now we got this custom component, but we got another custom component which I want to build. And this component should hold the input related markup and logic. Now definitely feel free to extract the appropriate code from app.js into goal input.js on your own and build your own goal input component which you use in app.js. In a couple of seconds, which I give you to pause the video, we will do this together. So, did you succeed? Let's try this together. Now here I want to extract some markup into goal input. For this, I'll first of all create a goal input component here in the goal input.js file and export this. And then we want to return some JSX code in here. The JSX code that should be returned is the text input and the button, but I will also grab the view that holds these elements as the container, because that view holds the input related container styling, and I want to outsource this as well. So here I will add this container with the text input and the button to my goal input.js file. Now, just as before, we need to do a couple of things. We need to import view, text input, and button, and we need to bring over our style sheet objects. Now I'll start by importing, and I will import view, text input, and button from React Native so that we can use these components here. And I will also import style sheet because, of course, I will create a style sheet. I will create such a styles object here with style sheet create so that we can set up the styles that belong to this component in this component file. And in our case, that would be the input container and the text input styles. So in app.js, here I will grab the input container and text input style objects and cut them so that our style definitions in app.js are now much leaner. And I will move them over into the goal input component file. So here in this object, I'll now paste them in, and that makes sure our styles are there. But now we're not done. We also are handling some state here. We're getting the user input and we're interacting with the main course goals state with help of this button. But now the problem, of course, is that the course goals state is managed in the app component, whereas the inputs are in a different component. But that's a common problem in React apps and not specific to React Native, and we can solve it as we solve it in all React apps. We can also talk to the parent component by passing event handler functions via props. So here, for example, we can accept props on goal input and expect a special prop, which could be named onAddGoal, to be provided by the parent component, which actually holds a function as a value that will be executed upon a press. So now in the app component, we can use the goal input component we just added. We can import goal input from /components goal input. And we can use this component here in that place where we had all the input related markup before and set this onAddGoal prop, which we expect to get here in our goal input component. And now since we set this prop's value as a value for the onPress prop, and that prop wants a function to be executed, we should pass a function to onAddGoal in the app component. And we still pass our addGoal handler here, just like this. Now what does change though is how we handle the user input, how we fetch the user input. Because this goal input handler and the state that manages the entered input is in the wrong place now. We don't do this in the app component anymore because the text input element is in the goal input component. What we should do therefore is grab that state and cut it from the app component and move it into the goal input component, like this. For this, of course, we must make sure that we import useState from React in this goal input component so that we can use this function here. Now we got the state. We also need this goal input handler function which updates the state though. So that in the app component, only the course goals state and the addGoal handler function is left. We will tweak this function in a second as well though. In goal input.js, we can now paste in that goal input handler function. And therefore this is now again connected to onChangeText where we point at this function. So this entered goal text is still being handled here. Now the only problem is that this entered goal text is eventually needed in the app component when we add a new goal. And therefore we also need to make sure that this data arrives here in addGoal handler. The easiest way of ensuring this would be to expect the entered goal text as a parameter. So that whenever addGoal handler is called, we get this text and we can use it in here. Now this function is fine. But right now, this text wouldn't be provided. addGoal handler is passed as a value to onAddGoal on the goal input. And onAddGoal is forwarded to onPress. And onPress, which ultimately calls this function, does not provide this entered goal text. To make sure that it does, we have to change something in our code here. For example, we can add another function here in our goal input component file and name this function addGoal handler again. So now we have this function or a function with this name in both goal input and app, but that's no problem because we're in different components here, hence we have no name clash. Now in this function, I actually want to execute props onAddGoal. So I want to call this onAddGoal function, which we receive here, manually. And then onPress is connected to this addGoal handler function, which I just added. By calling this function manually, I can now make sure that I forward my entered goal text. So this state. I pass this as a value to the function I receive on this onAddGoal prop. And therefore, since that function is the addGoal handler in the app component, that addGoal handler function will receive the entered goal text, because I'm passing it manually here. And again, this is nothing React Native specific, this is standard React. Now, as an extra bonus, we could also set our entered goal text to an empty string to clear it whenever we added a new goal. We didn't do that before, but we can do it now, and I think it is a change that makes sense. But of course, it's up to you whether you want to do that or not. Here, I will do it by setting the state back to an empty string. With all of that, back in app component, this should all work. We can now get rid of some unused imports again, which we don't need anymore. And if we now save everything and reload the app on both devices, if I now learn React Native, this goal still gets added. Now what's not happening is that the input would be reset though. Actually, internally it is. If I click Add Goal, you see there was no text, but it's not reflected here in the input element. The reason for that is that I'm resetting the state here in goal input, but I'm not binding the state to text input. We don't have any proper two-way binding here. We just have one-way binding. In the past, this didn't matter because we never changed the text besides typing into the text input field. But now, since we're also changing the state here, like this by resetting it, we should add a value prop to text input and bind this to the entered goal text. So that whenever this goal text changes, because we, for example, reset it, this is reflected in the text input. If we now save this and reload everything, I can again learn React Native. Now it's reset, and I can add my goals. So this is now working, and now we split this into multiple components. And in the end, as you see, here we had absolutely nothing React Native specific. Splitting our app and passing data and functions around, that all works just as you know it from React. We're making good progress. We're now able to add items to our list here, and we're managing this list in an efficient way. Now, what we're not able to do yet, though, is remove items. And it would be nice if we could simply tap those items and they would be deleted. Now, to make them tappable, if this would be a web app, all you had to do would be that you add an on-click prop to the item. That's how you would do it in the web. But this is not how it works in React Native. Instead, here, if you want to make an item pressable, you have to let React Native know. And you let React Native know by wrapping the item that should be pressable into a specific component provided by React Native. And that would be the pressable component. React Native also knows a component named touchable and various related components like touchable highlight and touchable native feedback and touchable opacity. But those are components that are not deprecated, but that should be replaced by pressable now. So these touchable components are the old React Native way. Pressable is the way forward. So we use pressable by simply wrapping the item that should be pressable with it. Like this. In my goal item, I wrap my view with pressable. And with that, this item becomes pressable. And whenever we press any item inside of pressable, so in this case, this view with this text, this onPress prop will trigger the function that we provide to it. So we should provide a function to onPress. And since I plan on deleting items in the future, I will define this function in app.js, because here I'm managing my course goals state, and here I will have to delete items in the future. So I will add a delete goal handler function here in app.js. And for the moment, I'll just console log delete here in this function. We will, of course, replace this with proper code later. Now the delete goal handler should be provided to the goal item, and therefore I'll add a prop here. And since it's my component, it's my choice how this prop should be named. And I'll name it onDeleteItem and pass my delete goal handler function to that. A pointer to this delete goal handler function is passed as a value to onDeleteItem on my goal item component. And now this onDeleteItem prop can be used in that component. And here I can, for example, simply forward it like that. We might tweak it later, but for the moment, we can just do it like this. Now if I save this, if I tap on one of these items, I get no visual feedback. But if I go back, you see that delete was logged to the terminal. So indeed, this already works. Of course, some visual feedback would be nice, and we will add it in a second, but for the moment, it's great that this works. As a next step, we can now make sure that the item actually does get deleted. And for this, in the app component, in the delete goal handler, it would be convenient if in this handler function, we would receive the ID of the to be deleted item, because that allows us to uniquely identify and remove an item. So here in this function, we could then set our course goals again to update this course goals state. And now the new state should be based on the old state, where we want to take the old state but remove an item, and therefore we pass a function to this state updating function, because that's how we should update state in React if it's based on the previous state. So here I again get my current course goals, as I did here when we added a goal, and I return the updated state. And the updated state which I return is current course goals, which is an array, .filter. Filter is a built-in method in JavaScript, just as map was a built-in method, which we can call on an array. And filter will return a new array, which is the old array minus all the items we filtered out. Now filter itself takes a function which has to return true or false, and if this inner function returns true, an item is kept. If it returns false, an item is dropped. Now this inner function is executed by JavaScript for every item in this array, and therefore it receives these items as inputs, as parameters. In my case, these individual goals. And I want to return false if my goal has this ID here. So I will check if the goal ID, so this ID property on my goal object, is not equal to the ID I'm receiving here. This will return true if there is no match, which is good because I want to keep items where there is no match. But if there is a match, if an item has the ID I'm looking to remove, this will return false because then the IDs are equal. And then this item will be dropped and the new array will no longer contain it. That's how we can delete a course goal. Of course, we have one problem though. The ID which we expect to get here is currently not provided. In goal item, where I'm binding on delete item to onPress, onPress won't give me that ID. Now to make sure that that ID is provided, we could again define a little helper function here, as we did it in goal input, where we added add goal handler, where we then manually called the function and passed our own parameter. And that would be absolutely fine. But alternatively, we can also call the built-in bind method on the function which we get through that onDelete item prop. Bind is a standard JavaScript function which basically allows you to pre-configure a function for future execution. Now the first value you pass to bind sets the this keyword in the to be executed function. And we don't care about that here, so I'll just set it to this, but it doesn't matter. The second value, the second argument you pass to bind though, will be the first parameter received by the to be called function. And in my case, that should be the ID of the goal item that should be removed. So here I'll set this to props.id, so that the ID, which I get through props on this goal item component, is sent as a parameter value to the function that we receive on this onDelete item prop, which is this delete goal handler function. Of course, for this to work, we must make sure that we do get an ID prop on the goal item component though. And currently that's not the case, but we can update our code here and make sure that an ID prop is set on goal item, and that would be itemData.item.id. Now there would be other ways of solving this as well, but this will work. And if we save this now and we tap an item, it is removed. So now I can add items multiple items, and I can then tap them to remove them. By the way, you could also add validation to make sure that empty items can't be added, but here I will not do that to keep this app a bit simpler. But with that, we can remove items. Now what's missing though is some styling, some visual feedback. At the moment, when I tap this item, I get no visual feedback other than its disappearance. So let's focus on the styling next. So let's now work on the styling of this pressable component, or of this component, if the item is currently pressed, because at the moment we got no visual feedback. Now adding some nice styling here is fairly easy for Android, because there is a dedicated Android ripple prop which you can set to an object where you can set the color of the ripple effect. And for example here, I could set this color to some dark gray by adding 6 Ds here, this hex code. And if I do that, if I set this value for the Android ripple prop here on Android, if I add a goal and I press this, there is a slight ripple effect. Let me show this again. Here, if I then press this, you see there is this ripple effect around this item. Now, if we want to have the ripple effect inside of that item instead, what we have to do is move pressable into our view here, like this, so that it only surrounds the text instead of the view box as well. If we do that and we reload all apps to make sure these changes get applied, now if we do this again on Android here, you will see there is a slight ripple effect on the item. Now that ripple effect is now only on the text, not on the overall container. And to fix this, what we can do is move our padding from the goal item, which is the view, which is the container, to the text. Because then the padding is part of the text and the ripple effect will take this padding into account as well. So now with that, if we set this up, we got this ripple effect here. And of course, you can play around with the ripple color to get the look you want. You could, for example, also take this purple color here and maybe choose a very dark purple as a color. And now we have this, which maybe looks a bit nicer. So this is pretty easy on Android. Now on iOS, this doesn't have any effect though. Here, if I press this and keep it pressed so that we could see a potential effect, we don't see any effect at all. Now for iOS to add some styling, we can add the style prop to pressable, which generally works like all your style props. It takes such a styling object, but it also takes a function as an alternative. And this function will be called automatically by pressable whenever the press state changes. You get an argument here, a parameter, with information about the current press state, and you can use object destructuring to get hold of the pressed property that's part of this object you get. You could also name the overall parameter press data and access press data.pressed in that function. It's up to you. Here I will use object destructuring to directly get that pressed property. So that's provided by pressable. And now we can return different style objects based on the pressed state. And we can define them down here, of course. We could have our pressed item here. And there we could say that we want to set the opacity to 0.5, for example, to make it slightly transparent. With that up here, we can check pressed, and if it's true, we return styles.pressed item. Otherwise, we return no special styling. If we save this, and I now do learn React Native again, you notice that if I press this, we also get some feedback here on iOS. Now, of course, you could go for all kinds of feedback. You could also bring this view back into the pressable component here and add another surrounding view so that you can influence the style in greater detail, and you can, for example, also change the background color, whatever you want. Here I'll keep this simple feedback, but now we also do have some feedback with help of this function form of this style property here. So again, we made good progress here. To conclude this section, I want to improve the overall look and feel of this application a little bit though. And I want to start by actually outsourcing this input part into a modal. Modals are these overlays that typically slide up or pop up on mobile apps that overlay the main screen and allow you to take some action after which they disappear. Adding such a modal and adding the input logic here into such a modal is thankfully pretty easy in React Native because it comes with a built-in modal component. So all you have to do in the goal input component, where I want to create that modal, is you import modal from React Native, and then you wrap that around the content that should go into the modal. In my case here, that's the view with the text input and the button. If you do that, we have this look here. So our list of goals seems to be gone and the styling is a bit off. And as I add goals, I don't see them. The reason for that is that we actually see the modal here, the overlay which we have on the entire screen. Now, of course, the modal shouldn't always be there though. Instead, it would be nice to have a button on the start screen that allows us to open the modal when we want to add a new goal, and then to have a button that allows us to close this modal here on this modal screen. Now let's start with that button that opens the modal. For this, I'll go back to app.js, and I want to add that button there. We still have the goal input component, but above that component, I want to add a button. And for this, I'll use the good old built-in button, though of course we could also import pressable and build our own button, as you learned it a couple of minutes ago. Because the button here in the end also just uses the pressable component or those old touchable components internally. But here, to save some time, I'll use the pre-built button instead of building my own one, and I'll give this button a title of Add New Goal. I'll also give the button a color through the color prop, because button doesn't take a style prop. It doesn't support it. Because it is already pre-styled, that's why you can't influence it too much. If you do want to style your own button, you have to build your own button with the pressable component and then some text and views inside of it. Here, with the pre-built button, we can change the color through the color prop though. And I will set color here to a string. And I will use the same purple as I use here in goal item for the background of my goals. I'll use this purple color here and set this as a color of this button here, like this. So now we have the button, but of course we don't see the button if we save this because we still have the modal everywhere. Now this button should control the modal visibility. And for this we need state, because the modal should either be visible or not, and that's a typical case for using state. So here in the app component, we can add a new piece of state and use state to initialize it and set it to false initially, because that will be my modal is visible state. And the set modal is visible updating function will allow me to change it. And initially the modal should not be visible. Now we want to change this whenever the button is clicked. So for this I'll add a function here, maybe here, the exact position doesn't matter, which I will name start at goal handler. And in this function I want to set modal is visible to true, because I want to show the modal. Now this start at goal handler function should now be connected to this button, and this button, being a built-in component, has this onPress prop which we now use to connect it to start add goal handler. Now, to show the modal only when this state is true, we could now render goal input conditionally, as we would do it in most React web apps. We can add curly braces around that, and then check our modal is visible state, and if it's true, then we render goal input, which internally contains this modal. If we do it like this and we save everything, indeed we see the button here, and if I press the button, the modal appears. But the modal then is just there. There is no animation and nothing, and therefore that's typically not how you would do that. Instead of just showing or hiding this component like this, a better approach is to embrace some of the props modal, this built-in modal component, offers to you. To be precise, this modal component has a visible prop, and if set to true, the modal is visible, if set to false, it's not. Now, this is useful because in addition, modal also has an animation type prop where you can set how it will be animated, that there maybe is no animation at all, that it should fade, or that it should slide in, and I will go for sliding. And now I just expect to get the should it be displayed or not information via props. So here I'll access props.visible, though this prop name here is up to you. It could also be show modal, but I'll choose visible. And now we have to set this prop on goal input in the app component. So here I'll now add this visible prop and set this equal to modal is visible, which is true or false. And with that, if we now save this and we force a reload by pressing R here in the terminal, now the modal slides up. Of course, we can't dismiss it at the moment, and the styling in there also is a bit off. So therefore, let's next focus on that styling, and let's then make sure that we can also close this modal. So to work on the styling here, in the end we need to go into the goal input component. There we have this modal, and in the modal we have this view, which in the end is responsible for controlling how the text input and button are displayed. Now I want to change the overall look. I now want to have the button beneath the text input, and I want to have another button in addition to add goal, because that other button should allow us to close that modal. Now to achieve this, I will restructure this a bit, and I will actually add another view in here below the text input and move my button into this view and add another button here with a title of cancel, so that I can add the goal or cancel adding. And this should in the future close my modal. At the moment it won't do anything though. Now with that we got that view in a view, but now I want to change the styles of that outer view, which is the main view inside the modal, because it's the first element in the modal, the topmost element in the modal. And on this input container, I want to use flex1 so that it takes all the available space in the modal, but I want to change the flex direction back to column. And therefore we can actually also remove it because that's the default anyways. With this, if I save this, the buttons are now below the text input, but they're totally stretched out because we have space between for justify content. This should instead be center to make sure that all the content is centered. This now looks way better. Now, in addition, these two buttons should be next to each other. And therefore, I added this view around the buttons, and I will give this view some styling. So here, maybe at the bottom, I'll add my button container object and actually give this a flex direction of row so that the two buttons are next to each other. And then add this button container on this view. So here I'll add a style, which is styles.buttonContainer. With that, the buttons do sit next to each other. Now it would be nice if the buttons had maybe a fixed width and some spacing between them. And to achieve this, since I can't style these buttons since they're built in, and since I don't want to build my own button, which we could do, but which is some extra work, I will actually wrap each button into a view as well, because then I can style that view instead of the button, and therefore still influence the look of the button a bit. So here I will assign a style property to those views here, and set up a dedicated styling object for those buttons. I'll name the style object button, and for every button here, I'll just make sure that it takes, let's say, 40% of the available width. And then we might want to add a margin horizontal, so margin left and right, of 8 pixels, so that we have some spacing between the buttons. And it's now this button style here, which I want to add to the views that hold the buttons. And that's a quick and easy way of setting my own styles to the buttons, even though I can't change the button style itself. But you can change the width or height with that. You can add margins between them. You wouldn't be able to change the color or text color though. If that was your plan, you would have to build your own button. And in general, if you need more adjustments, you might want to build your own button by using the pressable component. But this is good enough for now, and it gives me these equal-sized buttons below the text input. I also want to have some spacing between the text inputs and the buttons, and maybe we can shrink them a little bit. So to shrink them, I'll change the width to 30% here, or we set this to a fixed pixel width of 100, for example, like this. And for the spacing between the text input and the buttons on the button container, I will add a margin top of, let's say, 8 or maybe 16. So now if I save this, there is some distance between the buttons and the text input above the buttons. The text input now also can become wider, so I will set the width of the text input to 100%. With that, I reloaded the app in between, so I will reopen this. This is now wider. Now, it would still be nice to have some area around that which is not occupied, and therefore on the overall container, which is that root view in the modal, I will add a little bit of padding in all directions, and let's say add 16 pixels of padding. And now I'd say this doesn't look too bad. Last but not least, we still have some extra spacing to the right of the text input because we had a margin to the right, and I want to get rid of that as well. So now this does look quite good, and of course you can adjust this a bit further if you want to. Now I want to make sure that the modal closes whenever we cancel or click Add Goal though, because at the moment that's not happening. So to close the modal, whenever we click Add Goal or Cancel, we have to react to taps on those buttons, and then in the end, we have to change the visibility state in the app component, because modal is visible in the end controls whether the modal is shown or not. Now we already got a start add goal handler which opens the modal. Now we can add a end add goal handler which should set modal is visible to false. And now we just need to make sure this function gets called whenever a user taps on the add goal or cancel buttons. Now, if a user taps on add goal, the add goal handler is triggered, which triggers the function received on the on add goal prop, which turns out to be this function. So in order to close the modal if a goal was added, we just have to set modal is visible to false here as well, or call the end add goal handler manually here. Both would work. Now to also close it, if we tap the cancel button in goal input, we have to add on press to this button as well. And then expect that we get a pointer to this end add goal handler passed into goal input through props. So here we could expect that we get a function on a, let's say, on cancel prop. It's our component, so the prop name is up to you. Now we just have to make sure that this prop is provided in app component. Here we pass the on cancel prop to the goal input component and point at the end add goal handler function, so that this function is executed whenever the cancel button is clicked or pressed. With that, if we save this, indeed, if I click cancel, the modal closes. And if I add a goal here, like this, and I click add goal, it also closes, but the goal is there. And of course, it also works on Android, both adding and removing and opening and closing. Now to finally finish this app here, I want to improve the overall look and feel by changing some colors and by adding an image, which is something we haven't done yet, but which is of course something you will often do and you should therefore know how to do. Now, adding an image thankfully is easy because React Native has a component for it. There is an image component which you can import from React Native. And just as you have the image element for the web in HTML, this is a component that helps with displaying an image. This image component is used in your JSX code, and here I want to display an image right above the text input. So I will add my image here. On this image, you can then add some style, which we'll do in a second, but most importantly, you can also add a source prop. And this should point at the image you want to add. Now, when it comes to that image, you do find an example image attached. And you should download that image and move it into your assets folder, or to be precise, create an images folder in that assets folder, because that assets folder is generally the folder where static assets like images should be stored. And then move that attached image into that images folder in the assets folder. And it's this goal image which you got attached. And now when it comes to linking to that image, it works different than what you're used to from the web. We won't create some link here which points to assets/images/goal.png. At least not quite. It's not too wrong, but it wouldn't work like this. If I save this, you see I get a warning, I get an error, this doesn't work. Instead, you have to import the image here with a special import syntax. You should use a require function, which you might know from Node.js if you worked with that. And to that require function, you pass the path to the image. However, the path is a relative path from the file in which you're using this require function. So seen relative from that goal input file, which is that file where this require function gets used, we have to go up one level to leave the components folder, and then dive into images and select the image. Now to go up one level, we type ... This means go to the parent folder, and then we dive into assets, images, goal.png. This is how we add an image. Now let's also add some styling to it. And for this, I'll add a image styling object in my style sheet here. And here we could set a width of, let's say, 100 pixels and a height of 100 pixels. And give this a margin of 20 in all directions to have some spacing around the image. As always, you can play around with the styling to find your favorite styles. Now I want to apply that style to my image. And thankfully, the image element, the image component, does support the style prop, and we can set styles.image as a value on that style prop. And with that, if we reload the app by pressing R here in the terminal, you will see nothing as it seems. The reason for that is that the image is white, and we can't see that because the background is also white. But that's no problem because I wanted to change the background as well. And since we're in the modal here, this background can be changed by setting a different background on this input container, because that is our root element in the modal and it defines the overall modal container look therefore. The modal itself does support the style prop, but for styling the overall modal background, you should use a nested view as we are doing it here. And now here on this input container, we can add a background color. And I prepared a nice dark purple, which I'd like to use here, which has the hex code 311B6B. And whilst we're here, I also want to change some other styles. For example, we don't need the border at the bottom anymore because there is nothing below that, and that border here looks really strange. So I will remove that border, and I will also remove that margin to the bottom, which I have here. So that these are the remaining styles I have here. And with this, now we can see the image because now we got this nice purple background. Only in the modal though. We will work on the other background later, but here in the modal we got that. Of course, we now also might want to tweak the text color here when we enter something into this input field, and we might want to tweak the buttons here as well to make those look a bit prettier as well, because currently they don't fit the background. But most importantly, we did now add the image, which was the main task for this lecture. And as you saw, adding an image is super simple with that image component and this way of adding a source. So let's next improve the overall styling of those modal elements, the other elements, I mean. So for improving the overall look and feel here, I want to start by changing the button colors. For this, we can go to our JSX code because you learned that for these built-in buttons, you change the colors with the color prop. And again, I prepared some hex codes which I think look quite nice. And for adding an item here, I want to use the code 5E0ACC. And for canceling, I prepared another code which is F31282. If we save this, this is how the buttons look like, and it looks good on Android, but on iOS, it's a bit hard to read, I would say. This is a bit hard to read. So actually, we might want to tweak this and pick a slightly lighter purple, like B180F0, which I think looks good on iOS as well. It doesn't look as good on Android, but for the moment I don't want to dive into writing different code for different platforms. We will do that later in the course, but for now, let's stick to this uniform solution here where we have the same code for both platforms. Of course, feel free to optimize the app for one of the two platforms. For example, if you're on Windows and you can't test this on iOS anyways, you can of course choose a prettier color for this button there. But we got these buttons now. Let's now work on the text input styling. And for this, we got this text input styling object here. In there, I want to change the border color a little bit and choose E4D0FF. And also give this a background color, which should be the same color. So I'll just copy that as a background for the text input. I will now also change the color of the text that's entered to 120438, which is another prepared hex code. Since I added a border, I also want to change the border radius so that I have some rounded corners with border radius and set this to 6 pixels. With that, that is how this input looks like, and I think that doesn't look too bad. Last but not least, I will ramp up the padding a little bit though and change it to 16. So that we got this padding here. So that's now how this modal looks like, and I would say it doesn't look too bad. We can now learn React Native, and this app looks quite nice. I just want to switch the button order because I find it a bit more intuitive if the add button is on the right. But of course, this comes down to personal preference and is totally up to you. But now this works. Last but not least, I also want to improve the styling of this main screen though, because I think that white background color isn't too pretty. Here I prepared a little color for us, and it has the hex code 1E085A. Now if we set it like this works, and we get this as a background color. And this works just fine here. But if we had multiple screens in this app, so not just the modal but also other screens, which we will have later once we add navigation, then manually setting the background color like this all the time can become annoying. Therefore, what you can do when using Expo is you can go to the app.json file, and in that file, you can actually also add a special background color configuration item and set this to a hex code. And this will then automatically be applied as a background color to all screens by Expo. So if I now reload after adding this to app.json and saving that file, we also got this background color, but now it's applied by Expo to all the main screens. Not to the modal, but to all the main screens that are not overlays. Here we only have one screen, so it didn't matter, but this can be the more convenient approach if you do have multiple screens. Of course, like this, I'm not totally happy with the way this Add New Goal button looks. I think it's a bit hard to see on iOS. Therefore, what I will do is in app.js, I will change the color of this button, and we could go for a lighter purple, like this, and I think that looks a bit nicer. So now with the styling changed, there's one thing that might become obvious. The status bar is really difficult to see on both these devices. The reason for that is that it's still black, that it doesn't know that we have a dark background. Now, thankfully, Expo gives us a solution for that. We can import a special component from Expo. And that component is the status bar. We can import it from expo-status bar, which is a standalone package which is already part of this project, this package here. This is a component which we can use to fine-tune the look of the status bar. We simply use this status bar as a component here in our JSX code in this root app component. So here we can add status bar, and since it's now next to another sibling component right at the top of the returned JSX code, I will wrap it with such a fragment, since you're not allowed to have sibling elements at the root level of JSX code otherwise. So we add this wrapping fragment and add the status bar component next to our root view component. And on this status bar component, you can now set a style prop, which wants a string though. And you can now set the status bar to dark or light, or let it infer it automatically. Now, auto doesn't work here, so I will set it to light. And if I do that, the status bar becomes white and is now way easier to see again. And that is definitely a tweak we also want to apply so that we do have an app that looks good and that still allows the user to see crucial phone information like the battery or the time. But with that, this app is finished now. Definitely feel free to dive deeper into it and tweak it and play around with styles, position things differently, add features. But for now, we're done. We are of course going to dive way deeper into React Native in the next course sections though. So that's it for this course section. We learned a lot about React Native. We built the first basic application here where we can add our course goals. And whilst building this application, we learned a lot about building user interfaces with React Native in general. You learned that you must use these built-in core components, for example. You are not allowed to use HTML elements like divs or anything like that. Instead, you build the entire user interface and all your custom components from those built-in components. But then you can combine them as you need to build your own elements and features. You also learned how styling works, that you create such style sheet objects which hold nested objects, which you can then assign to different elements in your JSX code. In those nested objects, we have CSS-like properties, which allow us to set margins, paddings, colors, and all these things. Now, even though it looks a bit like CSS, or the names are similar, it isn't CSS. We have no inheritance, and in general, it's just not CSS. It's JavaScript, and under the hood, React Native translates our style settings to the native style instructions for the different platforms. We, for example, saw that we had problems assigning rounded corners to these elements on iOS, whereas it worked without issues on Android, and therefore it's really important to keep in mind that we have two different platforms, and React Native just does its best to talk to both platforms and transform our instructions for them. Now, what we also, of course, learned is that besides the components and the styling, we write regular React applications. We can still use state, we can react to events. Those events are just not called onClick, but instead onPress. But then we can react to them, we can change state, we can output state, and we can do all these things. And this part works exactly as you're used to. There's nothing special about this. React Native plus React is exactly as React Web plus React when it comes to managing state and so on. Now, we saw differences when it came to outputting lists though. We did this with a scroll view, but then we switched to flat list for better performance, which is another built-in core component. And you will see cases like this from time to time throughout the course, where we have a special solution for the native platforms for better performance or a native look and feel. But that's it for the basics for now. In the end, it's not too complex. It's a React app just with a different target platform. But of course, it is something you must get used to. Working with those built-in components, setting up styling like this, it takes practice to get used to that. And thankfully, we'll have plenty of practice throughout this course, because this was just the first real section and just the first app. We're going to build way more, and we're going to learn way more throughout the rest of this course. In the previous course section, we got started with key React Native fundamentals and basics. In this course section, we are going to explore how we can debug React Native apps. Because things go wrong, errors happen, and you must be able to fix errors on your own, and you must be able to understand your app and dig into your app and the UI you built whilst you're building it. Therefore, in this course section, we are going to take a look at an example error message and see what we can make of such error messages, which hints we can get out of error messages, and how we should treat and handle error messages. Before we then also take a look at some dev tools and some additions we get by using React Native and Expo that also help us when it comes to debugging React Native apps. Now, for this course section, I'm going to use this app we built in the previous course section. In case you skipped that section, you'll find it attached so that you can follow along just fine. And with that, let's dive into debugging. Now let's start this section by exploring error messages. And at the moment, this app has no error. But we can force one. For this, I'll go to the goal input.js file, and in there, I will simply force an error by actually setting this image source not to the correct source. I will comment this out. Instead, I will set the source to just a string, some path to image. Now, this path doesn't exist, but this doesn't matter because that's also not a good way of defining such a path. If I save this, we now get an error here when we have a look at our emulators at the bottom, and we also get one here in the terminal. And the error message we're getting here is that we provided an invalid prop to be precise that the source prop is the problem, to the image, and that it expected one of type number. Now, I will be honest, this last part is a bit confusing, and you will often have confusing elements in error messages. They are not perfect. But what is important is that you read the message, because often it gives you a first hint at what's wrong and what could be the problem. Here, the hint is relatively clear that it is related to the source prop of the image component, but even if it's a bit more abstract, you might at least get a first idea of where to look for the problem and where you could maybe fix it. Now, in addition, what's also very useful when getting error messages is this stack trace down here. This tells you where the error occurred. The first line isn't too useful because here it points at an image component in some weird path, because that in the end is the bundled code to which it's pointing here, and that's not helping us too much. But if you have a look at the part down here, it becomes more useful. Here we learn that it's in the goal input component, which is created by the app component. This can be useful if you have the same component being used in multiple components, then you know which instance being used by which other component is causing this. And therefore now it's pretty clear that we should dive into the goal input component, and that in there we might want to look for the usage of the image component and then take a closer look at the source prop. And if we're not sure of what should be provided here, then of course it's always a good idea to look into the official documentation. If you search for a React Native image, you should get a direct link to the official documentation for this image component, but you can also just go to the React Native main page and then to components and then find the image there. And here you then learn more about the usage of this component and which kind of value can be passed to the source prop. Now here we forced this error, of course, so it is rather simple to fix, but I wanted to show you what you can make of such error messages. And before I save this fixed code, let's also have a closer look at the emulator again. There we also got an error message at the bottom here. And you will sometimes get warnings or error messages down here, and you can click on them to see more details. Indeed, you see that here it's actually not an error, but a warning, which means, yeah, the app still runs, but not as intended. In this case, no image would be displayed. And you get a similar output as before. You get basically the same error or warning message up here. And then you got a stack trace down here, though I will say that this output here is not that useful compared to what we had here in the terminal. Here in the terminal, it was pretty clear pretty quickly which component, the image component, in which component built by us causes the problem. Here it's not immediately clear. Nonetheless, taking a look at this output can also be helpful. At least here we also learn that it is related to an image. Now with that, I will of course save the fixed code, and with that the apps update and the error goes away. Now we had a look at an error message. Sometimes you don't have an error necessarily, but you want to get deeper insights into your application. Now one thing you can do to get insights is you can log things. You can add simple console log statements to your JavaScript code, as you might be doing it in the browser, and then log something like goal input component rendered. And when you do that, when you add log messages like this, as a result, you will see them here in your terminal where you started this npm start process. So here, if I expand this, we see that this is being output here. And we see it twice because I'm running the app twice on two different emulators. So that can of course also sometimes be useful to understand the flow of your application. By adding this into different places, into some functions, into some component functions, maybe in some other places, you understand which code gets executed at which point of time. And of course, you can also console log things like the entered goal text here to print the value or to print some value of some variable or state. so that if I save this and I now go here and I start typing, we actually see that this text is being output here. So that again, we understand when this code executes, when it logs something to the console, and which concrete value we might be storing in some variable at a given point of time. So console log can be very useful, and you get the log messages delivered to your terminal here. Now, sometimes you want more detailed insights. You don't just want to console log something. When using React Native, especially also with Expo, you got some additional tools. Now for this, let's press question mark here in our terminal where we started npm start to see a full list of available shortcuts we can use whilst this npm start process is running. So you just need to activate this terminal, this console, by clicking into it, and then you can use the shortcuts you see here to trigger certain things. For example, we did press A to open the app on Android or I to open it on iOS before. You can, for example, also press R to force a reload. I also did that before. Now, what's quite interesting is that you can also press M to toggle a menu. To be precise, a developer menu. If you press M here, this menu opens up on one of the two emulators, which you can also open by pressing Command D on iOS or Command or Control M on Android. Alternatively, press M here in the terminal to open it, as you saw. And then in this developer menu, you can also force a reload. You can go back to the home page of your app here, but you can also do a couple of other things. For example, you can debug JavaScript remotely. If you click on this, a new tab in Chrome should open up. And in that tab, you can open up the Chrome Developer Tools. And in those developer tools, you can, for example, see network requests made by your app. At the moment, our app isn't making any network requests, but you could see network requests made by your app here if it's reaching out to some backend or anything like this. Here we just see some development and debugging assets which are downloaded. And you also see a console where you can see the log messages your app might be generating. For example, if I go back to my code here and I re-add console log goal input here in the goal input component and I save this, in that console you should also see output generated by the running app. If you don't see it here, you might need to force a reload or even restart the iOS app. I did have problems with that before. It can be a bit clunky, but ultimately you should see some output here as well. Now, this is just an additional way of looking into your app, and especially having a look at the network requests could be something that is interesting. Now, you can at any time, of course, stop remote debugging to go back to the old state, like this. It's just an addition, not something you have to use all the time, and probably not something you want to use all the time. Now, remote debugging can be nice for certain situations. What I personally find more useful is to use the React developer tools. And not some specific React Native developer tools, but the regular React dev tools. Now, you might know the React DevTools as an extension you can install in your browser, and that extension will not work for React Native. But what you can do here in a separate terminal is you can install them globally on your system, or also as a project-only dependency, but here I'll install them globally with the npm install-g react-devtools. And here on macOS, I need to add a sudo in front of this to make it work. You might not need to do that. On Windows, you definitely don't, because sudo doesn't exist there and isn't required there. And if you hit enter and you install this package, what this will give you is a standalone version of the React DevTools. With the DevTools installed, you can start them by running react-devtools like this as a standalone command in the terminal. And please note that I still have my npm start process up and running. And this opens up a new window. This opens up this DevTools window here. Now with that up and running, you can go back to your simulator, to your app, and open that built-in menu, that development menu, and enable debug remote.js again. And now the React DevTools should connect. Now you see that, by the way, my color gets lost if I do that. Seems to be a bug. I don't know exactly where this is coming from here, but the background color set in the app JSON file is getting lost as I enable remote JavaScript debugging, but it is what it is. Nonetheless, now we got these React DevTools up and running. And in those tools, that's the nice thing, you can see your component tree. You can see the app component, you see all these built-in components like view and button, and then the components that are part of that built-in button, which can also be interesting to look into. You see your goal input, and what's really nice is if you click on a component, you see the props it gets and the values of those props, and you see any state you have in there. And as I, for example, start typing here, you see that this state updates here as well. And you can even change this state here to simulate different things and to test different things. And you see this updated state gets reflected back into the application. And these React DevTools are really nice to have because being able to look into your component tree whilst your app is running and analyzing your state and your props and even changing those values can be super useful, especially as you're building more complex apps. Now, of course, if you don't need it, you might want to not run this, and you might want to actually disable this remote debugging in that case, since it can cause some performance issues, but it is a nice to have feature here. Now with that, I will reload though and get rid of this. So that's it for these core debugging tools you have. On reactnative.dev, if you dive into the guides there, under workflow, you also find debugging documentation. This can also be useful to go through. You find some additional ideas and aspects there, but the tools and approaches I showed you should already get you pretty far and should help you understand your React Native apps a bit better and understand and solve errors a bit better. Even though we had a first look at some important basics like these core components and how you can style and debug your React Native apps, we're only scratching the surface thus far. It's time to dive deeper, and that's exactly what we'll do in this course section. We're going to dig deeper into all these fundamentals, into all these basics that you must know. And for this, we're going to build a complete demo app, a brand new app, a little game where you will be able to enter a number between 1 and 99, and then it's the phone's task to guess your number, and you give the phone hints, and then we'll see how many turns it takes the phone to guess your number. So it's a nice little game, another app which we'll build. And as you can already tell by looking at this app, there are some new concepts in there, like using gradients or background images. We have multiple screens between which we'll navigate, and therefore we're going to dive into many new core components. We'll work on these complex layouts and learn many things about creating layouts like this, and we'll dive deeper into styling and learn about some brand new styling techniques as well. And last but definitely not least, this is a React app after all. A React Native app, but therefore also a React app, and hence we will also build reusable components. We will build custom components, and we will ensure that we don't just create this app in some way, but in a good way by writing good code, good React code to be precise. So plenty of things to cover. By the end of this module, you will have a super deep understanding of React Native and of its fundamentals. And therefore, let's dive right in. Now, to get started, I created a brand new Expo project, and you find my project attached so that you can use the same starting point as I did. It's a very simple app with only one component, the app component with some dummy content and some basic styles. And this will be our starting point for this course section. Now, in this course section, we're going to build this game, which I already showed you. And this game, of course, has multiple screens. It has this starting screen where we, as the owner of the phone, pick a number between 1 and 99. And on this screen, we want to do a couple of things. We want to ensure that no number smaller than 1 or bigger than 99 can be picked, for example. We also then want to allow the user to reset this input and pick a new number, or finally start a game, at which point we'll navigate to the game screen, the second main screen we have in this game. On this screen, the computer, the phone, will guess the number, and we have to tell the phone after every guess if it should guess lower or higher to get closer to our number. Now, on this screen, we, for example, show a little alert, a little warning if we give the phone a wrong hint, if our chosen number is smaller and we tell the phone that it's bigger, something like this. Now, besides that, every guess by the phone is logged, and we see our log here, and this log also is scrollable in case we exceed the max available height. Last but not least, once the phone guessed our number, we get this game over screen with a short summary and this nice image, and then from that screen we can start a new game if we want to. And therefore, in this starting app here, we will have to add all these screens, but also plenty of other reusable components like the buttons we have, because we will build those from scratch ourselves, and many other things. And therefore, that's what we'll do throughout the rest of this section. Now, if you're feeling super fancy, definitely try building a first prototype of this game on your own with the basic React and React Native knowledge you have up to this point. You will not be able to recreate the exact same look because there are new components and new tricks that we will need to build this result. But maybe you can build a basic prototype with React and React Native. And if you want to, definitely try building this on your own first. But of course, otherwise, it's perfectly fine to just follow along so that we can build this game together step by step. And at the same time, we will learn many new important things about React and React Native. So let's dive right into building this app. And for this, I am in this new project. And as you saw before, we will have a couple of screens in this app. Therefore, what I'll do as a first step is I'll add a folder named Screens in this project. You don't have to create that folder. You don't have to name it Screens, but I like to add my components that will act as screens. So that will be full size, taking up the entire size of the screen. I like to store them in such a screens folder to make it clear that this will be full screen components. And I will also add a components folder, which will hold all the other components that are then combined together to make up these screens. So in the past, in the first app we built, we only had one screen in the end. And then we had that modal, which you could count as a second screen, but it generally was all on one screen. And our app component did render the entire screen and all the components that made up that screen. Now we will have multiple main screens between which we'll switch. And you will learn how you can switch throughout this section, though we will also come back to this idea of screens and navigating between screens later in the course when we dive into navigation. But now we have these two folders, screens and components. And in the screens folder, I will add 3 new files. I will add a start game screen.js file, which will hold the component that will act as a, start screen, where we pick the number that should be guessed and where we start the game. I will then add a second component file, I should say, which I will name GameScreen. This will be the component, the screen, that will be responsible for the actual game. So where we will see the guesses by the phone, and where we then let the phone know if the guess is too high or too low. And then finally, we have one last screen, and that's the game over screen, which will be shown once the game is over. At the moment, all 3 files are empty, but we're going to add content throughout this section. Now, it makes sense to start with the start game screen, because that is the first screen we will see. That is the screen that will allow us to pick a number and then start the game. Therefore, I'll start by adding a new functional component in there like this, and I will export it so that we can use it in other files. And that's the first important takeaway, by the way. A screen, as I define it here, is just a regular React component. A React component that will render React Native core components and custom components, which then in turn are made up of React Native core components. That is what a screen is. It's nothing special. It's just a component. And therefore now the question is, what do we want to display on this start game screen? And it is of course up to you what you would want to display, but in this game, which I have in mind, we essentially have this input field where users can enter a number, and then we also have a button which allows users to confirm that number, and a button which allows users to reset the input, and then a couple of titles around that input field to provide some instructions. Now, therefore, we can start simple by adding this input field. And for this, we import another component from React Native. And this is the text input component, which we also saw already in the first course section. This is a component that renders an input field which can be used to enter data, some text, or in this case, a number. Now, I don't just want to display a text input field, I also want to have 2 buttons below that text input field. One button for resetting and one button for confirming. And therefore, we could also import button. We could do that, but I instead want to build my own custom button so that you also see how this could be done, since this will be something you will do quite a lot when working with React Native. Because when you build your own buttons, you have full control over their look and feel. Therefore, I will not add a button, but I will import a view because I want to use a view as a container around my text input and those buttons. So therefore here I then add my text input in that view, and then below that text input I plan on having my buttons. By the way, rendering text like this would not work, as you learned. You can't output text directly in a view. You would need to wrap this with a text component, but here I just place this text for me as a placeholder to remind myself that here I want to display some buttons. So at the moment this would not work, and I'm not even running this npm start process because I know that it won't work. I just want to outline this base component structure that I want to have. Now, speaking of those buttons, I think this is a great next step, building those custom buttons, because this is something we haven't really done up to this point, or at least not in great detail. And it is something that's definitely interesting to do. So let's add custom buttons. And for this, I will add a custom button component, which I'll name primary button. The name, of course, is up to you though. It's just the main button I will use in this course section, and therefore I name it primary button like this. And of course, we also export this primary button component so that it can be used in other files. And this, of course, is just standard React here. We build a component, we make it available outside of this file so that it can be used in other files. Now, when it comes to building this button here, it is important to understand that, again, we're just going to combine core components exposed by React Native. And I think what could be quite interesting related to that is if you search for GitHub React Native. Here you will find the official React Native source code, which is free to access for everyone. You can dive into it and have a look at it. Now, in this GitHub repository, if you dive into libraries, and there into components, you will find the button.js file, which holds the source code for this button, which we can import from React Native. And it can be interesting to dive into code like this to see how that button was built by the React Native team. But what you will notice if you dive into the source code is that in the end, it's also just a combination of other core components, to be precise, of view and text in its core. And then we got a style sheet and a bunch of logic. And therefore here, where I build my own button, I will also use these core components. For this, we simply import view and text from React Native. And now we can build a button with those components. Of course, you don't need to use view and text. Maybe you have a simple button that is just some clickable text. But I also bring in the view so that I can build a nicely styled container around this button, because not all style properties can be applied to text and vice versa. Therefore, here for me, a button is in the end a view with a text, let's say. And the text should, of course, be provided from outside. So in the component where I use the primary button, I want to be able to provide the text for the button between the primary button opening and closing tags. So we want to accept props, and then the content between the opening and closing tags in React is made available through the special children prop. And this is standard React, has nothing to do with React Native. Now what you can do, it's not mandatory, but what you can do is you can use object destructuring here in that parameter place, in that argument list, and simply destructure the children prop like this. This saves you the hassle of having to access props.children down here, and you directly pull out that children property from that incoming props object with that object destructuring syntax. It's optional, but I will do it here. Now with this, we have a simple custom component that renders a view and a text with some text between those text tags. At the moment, this button has no styling, but we can already use this component. So back in the start game screen, we could now display two buttons below that text input. So therefore here we can now access primary button and make sure to add this import that imports primary button from the components folder and that primary button.js file. And then on the first button, we could say reset by passing the text reset between opening and closing tags. And then we add another primary button where we maybe say confirm to confirm our choice, which we will be able to make here in the future. And with this, we won't have any styling at all, but we should have a functional first view here, a first component. Now I want to use this screen component, and for this we have to go to app.js. Because as explained earlier in the course, the app.js file is the first file that will be loaded by React Native, and the component exported in that file is the main component that will be rendered by React Native. So if I want to display the start game screen, I have to use this start game screen component in my app component. I have to use it there. So therefore, what I'll do is I'll import start game screen from /screens start game screen, so from that file. And with that imported, we can simply render this as a standard component. And I will get rid of the styles down there. I'll keep the style sheet because we might need it eventually, but I will get rid of all the styles. And we can get rid of that extra import here and get rid of the status bar import. Now with all of that, this should be an app that works. So what we could do now is run npm start to start this expo build process that watches our code and then previews the app on our emulators, and start our emulators. And as soon as you started your emulators, you can press A in this terminal to start the app on Android, and I to start it on iOS if you also have an iOS simulator. So this will now ensure that the Expo app starts on those simulators and emulators, and that our application will then be started on those devices. So here we go. Now the app is up and running on both virtual devices. Of course, at the moment it's not pretty, it's pretty ugly indeed, but we have something up and running. As a next step, we can start styling these buttons and styling the overall app, creating a layout. We can work on these things to make sure that we slowly get closer to the final state that we want to achieve. So, what would be a good next step? Well, I would say a good next step would be to ensure that the buttons here and the text input, which we can't really see, but which is there, that these elements are a bit more centered and not sitting directly on those edges where we can't really use them. That would be very useful. And to achieve this, we can go back to the Start Game screen, because that is where we have this view with the input element and the buttons. And of course, we can now position this view, and we can change how it's positioned and laid out. And for this, you learned that we do that with help of the style sheet object that is exposed by React Native. Because this allows us to create a style sheet object, which allows us to set up styles that can then be attached to our different components and elements. So here I'll add a styles constant with stylesheet.create, like this. And now in here, the question is, which kind of styles do we want? And I want to start with a basic style for the main view that wraps these elements, which ensures that this view is a bit more away from the edges of the device. So I will name this style object input container. The name is up to you though. And I will add flex1. Flex1, as you learned before, ensures that the element on which we add this styling object takes up as much space as it can. So that could be the entire space on the screen, or if there is another sibling element somewhere, they would split the available space, depending on the flex options set on that sibling container. Here it will be the only container, and therefore it should take up the entire available space. Now in addition, I will also add some padding here, so that we have some distance to the edges, and I will add 16 pixels of padding, though you can of course play around with that to find the right amount for your requirements. I will also add some extra margin to the top, so some extra distance to the top outside of the box, though it won't matter too much right now because we have no background or border anyways, so we don't really see where the view box ends and starts, but still I'll use margin top here. And set a margin top of 100 pixels to push this view, to which I'll add my styling, away from the top edge of the device. And speaking of that, we can now add the style prop to this view that holds the text input and add styles.inputContainer to it, so that these styles are applied to this view. And if you do that and save everything, it should automatically refresh your applications here on your devices. And now the content is a bit further away from the device edges, which is nice. Of course, that's not all we want to do when it comes to layouting. It's just a first step. As a next step, it would be nice to have some background behind this entire input area, so behind the input element and the buttons, which separates the input area from the rest of the screen. At the moment, everything is white here. Later, we will add a background image, but either way, I want to visually separate the input area from the background of this screen. And therefore, what I'll do as a next step is I'll add a background color to this input container, which is the element that holds my input element and the primary button. And I'll add a background color, which I prepared in advance, which has a hex code of 27063C, which is this plum color here. If I save this, we got this background color here, and because of flex1, it's basically taking up the entire screen. We just have some white space up here because we have margin top 100, so the entire container does take up all the space it can, but it is pushed away from the top by 100 pixels, and that's this white area. But the rest now has this color. Now, this is actually not the look I want though. Instead, I just want to have a tiny box around the input and the buttons. I don't want to add a background to the entire screen. Now, this could be achieved by actually removing Flex 1. If we do that, it only takes up the space it needs to squeeze the elements, the content of this box into itself. So now it only takes up as much space as needed by the text input and the buttons and the padding added here. And for the moment, that's closer to what I want, even though we will fine-tune this again later. But for the moment, we have this input area here. As a second step, I will now also add a margin horizontal, so left and right, of 24 pixels, so that we also have some spacing to the left and right. And I want to add rounded corners to this input area. So therefore, I'll also add border radius and give this a border radius of, let's say, 8 pixels. So if we save this, we now have these nice rounded corners. In addition, I think it would be nice to have a little bit of a shadow behind this box. And that's also something we haven't done before. And adding shadows is different from what you know from web development. Because in web development, if you would add a shadow, you could do this by adding the box shadow CSS property. But this does not exist in React Native. Instead, if you want to add a shadow, there are two main ways which differ between Android and iOS. On Android, you can add an elevation property here to your styling, which does not exist in CSS, but which instead is React Native specific. And elevation takes a value like 0, 1, 2, 3, and so on. So we have different levels of elevation. And the higher the level, the more shadow will be added. If I add 4, for example, what you will see is that on the Android device, we now have a tiny shadow behind this box. It might be clearer if we pick a higher number like 8. If we set 8, now we can see it a bit more clearly that there is a shadow. Now I will go back to 4 though. So we have a little bit of a background shadow on Android now, but we have absolutely no shadow on iOS. And the reason for that is that elevation indeed is an Android-only property. It has no effect on iOS because you can't add shadows with elevation. It's an Android-specific concept. And here it's really important to keep in mind that all these views, all these core components which we're using are compiled to native components for the different platforms. And we have different native components for Android and iOS. And these native components support different style properties in their native languages. And the style properties we set here are in the end also translated to native style instructions by React Native. And many style properties can be translated into fitting instructions for both operating systems, iOS and Android. But the elevation property is an exception. It can be translated into an appropriate instruction on Android, but there is no equivalent to this elevation concept in iOS, and that's why we have no shadow there. If we want to add a shadow for iOS, we can do that, but we do it with a different set of properties, with the shadow properties: shadow color, shadow offset, shadow opacity, and shadow radius. These 4 properties together allow us to add a shadow on iOS, in addition to adding a shadow on Android with elevation. Now, shadow color allows you to pick the color of the shadow. You could create a reddish shadow, but here I'll use black as a shadow color. But of course, you can pick any color you want. Shadow offset then wants an object where you control how much the shadow should be offset from the original object to which it belongs to the left and to the right. Therefore, you have a width and a height property here, which you can set. And you set a number here, which will be treated as pixels by which the shadow will be offset. For example, if I choose 0 for the width and 2 for the height, the shadow will not be offset to the left or right, but it will be pushed down a little bit by 2 pixels. And you can play around with these values to find the shadow positioning you want. Now what you also need to set is the shadow radius. This basically controls how much the shadow expands, so to say. And here I'll choose 6 because again here you provide a value which is a number, and you can play around with that value to see the impact of different numbers on the shadow that is created. Last but not least, you can add a shadow opacity to control how transparent a shadow is. For example, here I'll set this to 0.25, but you can play around with this value as well to see how that influences the effect of a shadow and how strong a shadow is. Now with those settings here, if we save everything, we now have a nice little shadow behind the box on iOS as well, and we have the elevation related shadow on Android. Now if I would, for example, crank up the shadow opacity to 1, you would see that the shadow is much stronger on iOS now. So that's what I meant. You can play around with that to get a feeling for how this shadow works. Here I just want to have a little bit of a shadow, and therefore I'll set it up like this. And that's another major step. The app still doesn't work, the buttons don't work, the text input does nothing, but we learned something new about styling. We learned how to add shadows, and we gained more practice on how to set up styling on our own components combined with those core React Native components. And since this is something you will do all the time when building React Native apps, this is of course crucial to understand. And now you also know how you can add shadows. So we got this input box styled a little bit, which is nice. Now let's work on the elements in that box again, on the input element and the buttons, which aren't really buttons at this point. We just have a view with a text inside of it. It's not pressable at all. Now I will work on the buttons in a second step. I want to start with the input element. And for this, in the start game screen component, I'll add another style object in this style sheet, and this style object will be responsible for styling the input. Therefore, I'll name it input or text input or number input, since the goal is that users enter a number in there. But as you know, the name is up to you. Now this will be assigned to this text input by adding the style property to this text input, styles.number input like this. And now the styles I do want to add are the following. I want to give this a height of, let's say, 50 pixels to have a fixed height on this input. And I want to give the text in there a font size of, let's say, 32 to have a nice big text in there. In addition, I want to change the color of the bottom border. I want to set this to a nice yellow color, which I also prepared in advance. And that would be the hex code DD-B52F. Like this. This is a nice yellow color, and that's the color I want to use here. And of course, it's probably clear anyways, but definitely feel free to play around with those colors and choose your own colors. Now, the border color is not the only thing we need to set. We also should set the border bottom width here to make sure that we can see this bottom border. And for this, I'll crank up the width a little bit and set it to 2 pixels. Now, I also want to change the color of the text that is entered in this input field, and I'll set it to the same yellow as we have it up here for the border bottom. So here I add the same string with the same hex code. Now, it would also be nice to have some empty space above and below the text input, and this can be achieved with margin, but to be precise with margin vertical, which adds the same amount of space to the top and bottom. And here I want to add 8 pixels of space. Last but not least, I'll set the font weight to bold to make sure that we have some nice bold text that's being entered here. With that, if we save this, we got this yellow border at the bottom. And if I start typing here, this looks quite nice. I just think that it's a little bit too wide. We don't need that wide of an input field because we only enter a 2-digit number in there, or maybe just a 1-digit number, but definitely nothing longer than that. At the moment, you can enter anything in there, but we will soon restrict this and we won't allow values higher than 99. So this is way too big, way too wide of an input field. Now, to control the width of this input element, we can use styling, but actually not just styling. But let's start with the styles and then talk about the other thing that we can do. Here on the number input, I want to make sure that this is shorter, that it's not as wide, and we can do this by setting a width here on this input. And the width could be 50 pixels as well, though you can of course play around with that value to find a fitting width that looks best for you. If I save this, this is now way shorter. It would be nice if the text would be centered in there though, and this is something which can be achieved with a styling property that you might know from the browser, because that's the text align property. We can set this to center the text in its container, so in this input element in this case. And if we save that, the text is centered. Now the overall input element is not centered yet, we will do this in a later step, but it is now shorter. However, at the moment you can still enter super long numbers in there, which causes this input element to become scrollable. And I don't want to be able to do that. I want to make sure that users can only enter numbers between 1 and 99 into this input element. And therefore will have at most 2 digits, 2 characters that will be entered here. And this can be achieved by adding a special prop to text input, the max length prop. Now, this prop takes the max number of characters that can be inserted into this input element. So we could try to set this equal to 2. If we do that though, we get an error, also here. On Android it crashed entirely, also nice. And if we have a look at this error, we see that in the end we have a problem with the type I chose. I chose type string, but expected is type number. And that indeed is the problem. We provided a string here by using quotes. Yes, it's a prop value, but it is a string. We're using quotes here. What we should pass in instead is a number. And this can be done by using curly braces instead of quotes, and then passing the number between those curly braces, like this. If I save this, now I don't have the error, and now if I try to enter more than 2 characters, it doesn't work. I'm hammering my keys on the keyboard, but nothing happens. I can enter 2 characters at most, and that's exactly what I want here. Now I will try to restart this on Android, so that we can also preview it there again. Sometimes it can crash like this. You can try restarting it then, or you restart the entire npm start process, but here restarting worked, and now we have our input element there as well. So that's now a first step. But we still have a couple of problems here. For example, I can still enter any kind of character here into this input field. I get the regular keyboard, which offers me all these regular characters, and getting to the numbers is a bit annoying. That is something we can also change, because of course that is not the behavior I want here. So let's now dig a bit deeper into this text input field and learn how we can configure it. We already set a max length, but I also, for example, want to control which kind of characters can be entered there, or to be precise, I want to control which keyboard I get when I get a keyboard on my mobile device. Because at the moment, as I show you, we get the regular keyboard with all those regular characters, and that's not what I want. Now, text input allows you to control which keyboard is opened by the device. And it can be controlled with the keyboard type prop. Now, this keyboard type prop takes a bunch of values. And it's worth a look at the official docs to understand which values are supported on which platform. If you take a look at the keyboard type prop description in the official docs for the text input, you'll learn that there are a couple of values that work across platforms. And then there are values which are only available on one of the platforms. So for example, URL is supported on iOS devices, but not on Android. Now here I want to use the number pad though, which works across platforms, because this will open up a keyboard that only shows numbers, which is what I want here. So therefore here I'll set keyboard type to number pad. Now there also are a couple of other properties we can set. And you see that there are a lot of props that are supported, and definitely feel free to browse through them to understand which options you have when working with text inputs. Here, I for example also want to set the auto capitalize option to none. It's not too important when working with numbers, but if this would contain regular text, this would ensure that it's not auto capitalized. Again, that's not really important here, but I want to show that this kind of prop exists. We also have an autocorrect prop that allows us to turn autocorrection on or off. Because it could, for example, be super annoying if you have a field where users should enter their email and you have auto capitalization and autocorrection turned on. We all know these input fields where your email address gets corrected and the first character gets capitalized and you have to fix it thereafter. You can avoid such bad user experiences with props like this. Again, for this input, where we only expect numbers, this is not really needed. Now, with that, if we save everything and I go back, you see immediately that on Android, we now get a different keyboard, which only shows us numbers. And it's the same here on iOS. And that is a huge step forward because that is the behavior we want for this input field. And that's, of course, pretty nice to have. Therefore, as a next step, let's leave this input field and let's work on these buttons before we then start working on the layout of this box by making sure that these elements are laid out a bit nicer. So let's get back to this button. At the moment, it isn't really a button, it's just a view with text inside of it. Now, to make it a button, we need to add a component that allows us to react to presses, to taps. And React Native has a couple of components that do that, for example, the touchable components. I briefly mentioned them before. In the past, these were the main components you would use for adding touch support to elements, but nowadays the pressable component is recommended. Therefore, I will use pressable here. And we can now wrap pressable around our view and text here. So we can create a pressable component here, use it in JSX like this, and wrap it around the view and text. And pressable has an onPress prop, which takes a function as a value, which ensures that this function that we pass to onPress will be executed whenever the button is pressed in the end, whenever anything inside of pressable is tapped. Now, to show you how this works, I'll add a little dummy function here, press handler, and in there I will just console log pressed like this. And I want to connect this press handler to this button by pointing at press handler like this. As you learned before, we're not executing this function here, we're just pointing at it so that it will be executed for us when such a press occurs. With that, if we save this, we can now press these texts and we don't get any feedback, at least not right now. We will add some feedback soon. But in the console, we can see that indeed we did press these buttons successfully and that we listened to those events, which is another big step forward. But of course, having some styling and some feedback would be nice as well. And therefore, that's what I want to work on next. Now, for adding styling, I again will import the style sheet, because that is how we do define our styles typically when working with React Native. And we can add such a styles constant, which is a style sheet created with the style sheet create method. And now in this method here, we can define our different styles. Now, I want to have a couple of different button styles, but I want to start with the main style for this container that I have around my text. So my main style for this view. So I'll name this container. And in here, I want to set a background color. And the background color I want to set is the same color I have here. So I will actually copy this color from the start game screen and use this here for my button. Now, of course, if I use the same color as I have it here for the background, it won't be visible. Therefore, to work around that, I'll change that background color in the start game screen a little bit and simply make it darker, let's say, by switching to this hex code, 4E0329. Now we have a different background color for the button, and I also want to make sure that I have rounded corners, and not just some rounded corners, but essentially no corners, but instead a nice little half circle on the left and right of the button. And this can be achieved by giving this button a huge border radius, for example, with a value of 28. I also want to have some padding in there, and I want to have different padding to the top and bottom and left and right. So I will set padding vertical, let's say to 8, and that's the padding, the distance inside of the container to the top and to the bottom. And I will add padding horizontal, so to the left and right, of 16, so that we have more padding to the left and to the right than to the top and to the bottom. In addition, on Android, I want to add a shadow. Only on Android, not on iOS. You could also add an iOS shadow. You learned how that works a few minutes ago. But here I want to add a shadow only on Android by setting the elevation to 2. If we save all of this, we don't see anything because we need to apply this styling. So we can go to this view, add the style prop, and point at styles.container. And with that, if we save this, now we got these buttons here. Of course, they're still not super pretty, but we're getting here. But we also need to style the text now because the text doesn't look good. We also might want to add a little bit of margin around the button so that there is some spacing between the buttons. Hence, I will start with that and actually add a margin in all directions of 4 pixels. And I will define a second style object, which I'll name button text. And therefore, actually, I'll name this here button container to be consistent. And my button text will receive a color of white, so that the text is white. And I want to center the text, which can be achieved by using text align center, like this. And what's very important, you have to define those styles on a style object that's directly applied to this text component, because as you learned before in this course, if you would add text align center and this color prop on the button container, it would not affect the text inside of the container, because there is no inheritance in this React Native styling approach. It looks like CSS, but it isn't CSS. So therefore now we can add this new style, the button text style, to this text component. And since I changed the name of the container, we also should update the name up here and point at the button container style object here. With that, if we save this and we go back, this is centered and already looks a bit nicer. We can also see that there is a slight shadow on Android, whereas there is none on iOS. Now, what we don't have at all is any feedback when a button is pressed. And that would be nice to have. Now, I did show you how you can add such feedback before. You can add feedback on Android and add a nice ripple effect by adding the Android ripple prop. And as the name suggests, this only has an effect on Android. But there you can pass an object to Android ripple, and then on this object you can set the color that should be applied when this button is pressed. So the ripple color that will be used. And ripple is this little wave effect which you get when pressing a button on Android. So here I'll set this to a color, and I'll use the main button color here, but of course I'll use a slightly darker tint here, maybe like this, switching to the hex code 640233. With that, if we save that, on Android, we should have a nice little ripple effect. But actually, if you press the button, you will see a slight effect outside of the button, but not inside of it. So that is not working as intended. And I'm showing this on purpose because this can be a common problem when building custom buttons on Android or with React Native in general. This is a common problem to run into, that the ripple effect is outside of the button, for example, and therefore I'm showing this here so that you have a solution for this common problem. Because the solution is to restructure this JSX code. What you should do is move your view outside of the pressable element, so that pressable is inside of view. And then we also need to add a new styling object and restructure our styling objects a little bit. I will actually add a button outer container here, like this, and rename this to button inner container, because we will work with two containers now. One container will be that view that holds the pressable, and the pressable will be the inner container that holds the text. And we need to distribute our styles across these two containers to make sure that they work together correctly. And what you should do now is that on the outer container, you add this border radius. You don't add it on the inner container, you add it on the outer container instead. In addition, it's that outer container that receives the margin, like this, which should make sense because it will be the outer container that will be closest to other elements that are used side by side or close to the button when you're using this button component in other components. Now, in addition, on this outer container, you should add overflow hidden, which is a property you might also know from web development. What this will do is, it will ensure that if any effect or any styling from inside that container would go outside of that container, it's clipped, it's not shown. So for example, if the ripple effect would go outside of this container, it will be clipped and it will not be visible. Now on the inner container, we want to have the background color, and we want to have the padding and the elevation. Now we can add this outer container class here to this view, which is our outer container. And on this pressable element, we can also add a style prop. And here we want to add the button inner container style. When we do that and save everything, the buttons look as they did before, but now you will see that the ripple effect is inside of these buttons. You have to watch really closely, and you can of course temporarily switch to a totally different color to make it a bit easier to spot this effect. Now you see the ripple effect is inside of the button. And I'll switch back to the other color now because I just wanted to show you that this works. So working with such combined containers is something you often need to do when building custom buttons. And now here you see one example approach of building a clean button by combining such an outer and such an inner container. Now, of course, at the moment though, this is nice on Android, but it has no effect on iOS because this ripple effect is only available on Android. So if you want to provide some visual feedback on iOS as well, which we typically want to, we have to set up a dedicated style for iOS. And for this dedicated style, I'll add another styling object in the primary button component file. And I'll name it pressed, because this should become active when the button is pressed. And what I want to do in that case is I want to set an opacity of 0.75. Opacity makes the element on which you apply this style transparent, and here I will make it 75% opaque, so 25% transparent. Opacity wants a value between 0 and 1, which then is translated into percentage. So 1 is 100%, 0 is 0%. Now this pressed style here, this object, should be applied to pressable when the button is pressed. And for this we can change this style prop a little bit. Because as I also mentioned before, the style prop for this pressable component takes either a styling object as we're currently passing it in, or it takes a function, for example an arrow function here, which will be called automatically by React Native whenever the pressable is pressed, so whenever the press event occurs. And then this style object receives some data about the press event, which is an object with essentially one property. And therefore we can also use object destructuring here to pull out that one property. And that one property is a pressed property. And this name is not up to you. This is a property named pressed, which is part of that object, which is automatically passed into this function by React Native for this pressable component. And pressed is a boolean, which is true if we currently are pressing the button or the element in general, and false otherwise. So now pressed can be used here in the body of this arrow function to determine which style objects should be applied. And for this, I'll check if pressed is truthy, in which case I want to apply different styles than if it's not true. If it's not true, after the colon here, I want to apply the default button inner container style. But if it is true, then I want to apply multiple styles. I do want to apply the default button styles, but I also want to add my pressed style object here. And this can be achieved by passing an array of styles. And in general, in any place where you use the style prop, even if it's not the pressable component, you can pass style objects like this, but you can also pass arrays of style objects. And in that case, all the style objects in that array would be considered by React Native. So here, I then want to add my button inner container style here, but I also want to add the pressed style. So if pressed is true, then this array of style objects will be applied to the button. If it's false, this single style object will be applied. And with that, if we save this, we now got this feedback here as well, because we got some transparency going on when we click this. On Android, we now also have this effect, and for the moment that is fine for me here. You will learn in the next section how you can differentiate between platforms and how you can write or execute different code for different platforms. So in the next section, you will learn how you can disable this styling behavior for Android and only use it for iOS. For the moment, we will use the same effect for both platforms. So we will add this opacity when the button is tapped. So slowly, this is taking shape, but of course it's still not beautiful, and especially the layout here is not great. So therefore, that is what I want to work on next. And as a first step, it would be nice to position the elements inside of this input box in a different way. The text input, for example, should be centered in the middle, and whilst we could have the buttons beneath each other like this, I want to have them sit next to each other in one row, because they don't need to be that wide. They don't need that much horizontal space. Hence, it's time to go back to the code, and of course, just as a side note, as always, feel free to pause the video and try implementing this on your own. You will need to work with Flexbox, and you learned the fundamentals about Flexbox already, so definitely feel free to enhance the layout on your own before following along with me, where we will then enhance it together. Now, here is what I will do though. In Start Game Screen, we have this view which holds this entire input area, and this view has this input container style object attached to it. So inside this input container style definition here, I want to control how the elements in there are laid out. And since I want to center this text input, we have to add some flex properties that will take care about centering. And the positioning of elements in a flexbox is controlled by using justify content and align items. Now, justify content will position elements along the main axis, which by default is top to bottom, because the default flex direction with React Native is column. And align items will position items along the cross axis, which is the opposite of the main axis. So at the moment, as I just said, the default is flex direction column, So justify content will position items along this top to bottom axis. And therefore here, it doesn't matter too much what we set here. We could set this to center and temporarily remove align items. And it wouldn't really have any effect because the main axis top to bottom is occupied by the elements already. And since this overall container is not higher than the space taken up by the elements inside of it, there is no extra vertical space to distribute. That's why this doesn't matter too much. Now what does matter though is align items, which positions item along the cross axis. And the cross axis in this case is left to right, because the main axis is top to bottom. And here we want to center the elements so that the text input element is centered. And this can be achieved by setting this to center. If we do this, indeed this is centered, and automatically as a side effect, the buttons got smaller. Because before, the default was stretch, which ensured that the elements would stretch out to take the full available width. The text input element doesn't stretch because we set a dedicated width on it. So we restricted the width of that element and didn't allow it to stretch. Now if we change this to center, we also don't stretch the buttons anymore, which is why they only take the space they need to fit the text inside of them. Now that is okay for the moment because I don't want to position the buttons like this anyways. Instead, as I said before, I personally would prefer them to sit in a row next to each other. Now for this to happen, we need to encapsulate these two buttons into a separate container. As long as they are directly in the same container as text input, there is no way of positioning them in a different way. But we can wrap them in an extra view, and now it's this view which is in the same container as the text input, but the buttons are in a separate container. If we save this, this has no immediate effect other than the button sizes changing again, because they are now in a new Flexbox container, because every view constructs a new Flexbox container. That is something you must know, and therefore they stretch again. We would have to change the styling of that view to, for example, center them again to get rid of the stretching if we wanted to. Now I don't want to get rid of the stretching, but I do want to change the flex direction to row so that the buttons are next to each other instead of beneath each other. And for this, I'll add a new styling property here in my style sheet, which I'll name buttons container. Of course, this name is up to you as well, but here I'll set the flex direction to row, because now the buttons should sit in a row. And if we do that, and we add this to this view here, we add styles.buttons container as a style to this view, then indeed they are next to each other. Of course, the buttons now have different sizes again, and an easy way of fixing that is to again encapsulate every button into a new view, but now every button receives its own view. And the idea behind this is that now we have new Flexbox containers where every Flexbox container contains one button, and this Flexbox container here will again have a flex direction of column, and the button will stretch in there. And the two Flexbox containers we have here can now distribute the available space provided by this view, which is the overall container for these buttons. Now just by adding these views, nothing changes though, because by default a view takes only as much space as is needed by its content. But you also know what you can do about that. You can add flex1 to enforce that a view takes as much space as available. For this, we can add another style object, the button container, which only holds one button, and add flex1 to it. And this style object can now be assigned to these two views here. So here we add styles button container like this, and we do the same on this second view. And with that, these two buttons now have the same size and they distribute the available space amongst each other. And I'm showing this to you so that we A, have a layout that we like, but also B, so that we learn more about React Native and how we can create layouts. And indeed, it is super common and normal that you nest views into each other and that you combine different Flexbox properties on different view levels to achieve the final layout you want. And here I would say this layout doesn't look too bad for this input container. Later, we will make sure that the buttons don't look equal, but for a start, this doesn't look too bad. Now I would say it's time to work on the background before we then finally start adding more logic to this game. So as a next step, I want to make sure that we have a nice background behind this input element. And for a start, I want to add a nice little color in the back, which we will then change to a gradient, which we will then change to a background image plus a gradient. But let's start with a single background color. You learned before that there are different ways of setting that. You can, for example, go to app.json, to this configuration file, and add a background color property here, and set this to a hex code that will then be applied as a background color to the screen. And this would be a fine way of doing that. What I will do instead, though, is I will add a background color with help of a view. And for this, I'll go to app.js, because once I add more screens, they will actually still end up in this root app component. So these different screens, which I will add later, will still share this app component as a root. So therefore, any background color we set here around this view, around this screen I mean, will be applied to all screens later once we start adding them to app. Therefore here, I will add a view around the start game screen, like this. Of course, for a view to work, we need to import it from React Native though, otherwise it's not available. So now we got this view here around our start game screen. Now we can add some styling to this view. And for a start, I will add my screen or my root screen, whatever you want to name it, style object here. And I'll set a background color, which should be a nice yellow color. And I'll pick that yellow color, which I chose here for my input element in the start game screen. I'll use that same color here. Now we can apply this root screen style to this view here by using styles root screen. Now if we save this, it only covers this part at the top. And do you know why? Because it only takes up the space it must take up. By default, and that's really important to memorize, views only take as much space as they need to fit their content into themselves. And the content of this root view is this start game screen, which in turn is just this input area. So it's this input box plus the margin reserved by this input box. Now, if I want to apply this color to the entire screen, what can we do? Well, we can use flex1. If we add flex1 here, this container, this view which receives this style, will take up as much space as available. So by adding flex1 here, now everything is yellow. So that's how we can add such a background color with a view. It's a nice first step, but as a next step, we will switch to a gradient instead. So how can we add a gradient in the background here? Well, for this we'll utilize Expo. If you search for Expo linear gradient, you will find that Expo, this extra tool we're using to simplify the process of building React Native apps, this tool and the team and company behind it provides an extra package called Expo linear gradient that gives us a component which we can use in our code to display a linear gradient. So what we have to do here is open a new tab in our terminal here so that we can install this extra package. And we should install it with Expo install, not with npm install. You could do this as well, but by using Expo install, Expo, this tool which we're using, will ensure that a fitting version is installed into this project. So it will take a look at the version of Expo you're using in this project, and it will automatically install a dependency version that works well with that Expo version. Therefore, we'll use Expo install here and install the expo-linear-gradient package like this. If you hit enter, this will execute npm install behind the scenes, but as mentioned, it picks a fitting version. Now, once it's done, you can close this terminal window and keep the npm start process running. And now we can import linear gradient from Expo linear gradient. And as always, the official docs are a great place to understand how you can use this component in case you're not sure. So now we imported this linear gradient component, and with that imported, we can replace this view with linear gradient. And therefore, of course, we can get rid of that view import because we're not using the view component in this app component anymore. Now, linear gradient takes a style prop, and on that style, we still want to set flex 1 because the gradient also should take all the available space. But we won't set a background color anymore because the idea behind a gradient is that we have a gradient between multiple colors. And we set those multiple colors with help of the colors prop that is supported by this linear gradient component. This colors prop takes an array which takes all the colors you want to use in your gradient. That could be 2 colors, it could be 5 colors. Again, take a look at the official documentation to learn more about all the supported properties and how you can configure this gradient. Now, the 2 colors I want to use here are, in the end, the yellow, which we used for the input. So I will pick this. But as a first color, I want to use a different color. I want to use this plum color, which I use for the background of my input container. So I will grab this as a first color here, separate these items with a comma. And with that, if you save this, you have this nice gradient here in the background. Of course, with that added, to make sure that there is a higher contrast between the background and this container, this input container, we could go back to this container and pick an even darker plum color here, like 3B021F. And with that, now this is darker and stands out more from the background. But this is how we can add a gradient. And thanks to this extra Expo package, it's really not difficult. Now, having this gradient here is nice, certainly perfect if we would be building a Tequila Sunrise app. But as a last step for finishing this background, I actually want to overlay a background image above this gradient, but below the other elements on the UI. So below this input container, for example. Now, a background image can be added with another component that's actually already built into React Native, and that's the image background component. Now, we learned about the image component before already. Image background is quite similar, but as the name suggests, it renders an image in the background instead of the foreground. Now, I want to have that above the linear gradient so that the linear gradient shimmers through the image, but below all the other UI elements. So therefore now here, I'll add image background like this and wrap my other content with it so that the other content is inside the background image and therefore above the background image visually. And now on this image background, just as on the normal image, we have to add a source. And this source should provide the image that should be displayed here. Now for this, I prepared an image for you. And I will add an images folder here in the assets folder into which you should store this image. You find the image attached, it's this background PNG file, and this image looks like this, just a couple of dices. By the way, I took this image from Unsplash, and of course I do want to give proper attribution therefore. And there, if you search for dices, I think, you find this image. So this image was not taken or created by me. It's from Unsplash. Unsplash is a great resource for finding free images, and you can take this image here or another image from Unsplash if you want to use it in your app. So now with the image stored in the Assets Images folder, we should point at it. And just as with the normal image component, we don't just pass a path as a string here. Instead, we use this special require function and then construct a path to the image. Now here I'm in app.js, so I don't need to go up one level first. Instead, I am already next to the assets folder. So with /, we tell React Native that we're looking for a folder that's in the same folder as this app.js file. And then it's the assets folder, there the images folder, and in there the background PNG file, like this. Now, image background also takes another prop, which is very important, and that's the resize mode. It's very likely that the image you're using is too small or too big for the screen size of the device on which the app is running. And resize mode controls how the image will be resized if it doesn't have the same dimensions as the underlying device. Here you got multiple options, which you might know from web development, because there you have similar options when working with images, with background images to be precise. And I will use cover, which will make sure that the image always covers up all the available space, but not by distorting it, but instead by zooming in or out. So that's a nice setting when it comes to adjusting the size of the image. Now what's also important is that I will add the style prop to image background. And here I also will point at a root screen so that this also takes up all the available space. It's not enough that the gradient does this. This image should also take up all the available space that is made available by its parent component, so by the gradient in this case. If we now save this, here's the image, but the gradient is gone. Now, you might just want an image, and in that case, this is perfect. But if you also want the gradient back, we now have to make this image transparent. Not entirely transparent, of course, but to some extent, so that the gradient shimmers through the image. And this can be achieved with another special prop that we can set on image background, and that's the image style. Now, we already added style here. But what you have to understand is that image background, this component provided by React Native, is actually, under the hood, a combination of components. We saw that before in the React Native GitHub repository, where you can see all the React Native source code, when we had a look at the button. If you have a look at the image background.js file here, you will see how that works internally. And you will see that it's a combination of a view and the normal image component. Now the style which we set here, this prop, is added to this view. We can see that here the style is set. The inner image can also receive some styling though. And here on this inner image, we want to add some transparency. Because the view is transparent anyways, it doesn't have a background color by default. But of course, the image, well, shows the image. So therefore now we can add the background image style object and add the opacity property to give this image an opacity of, let's say, 0.15. So that would be 85% transparency. So almost entirely transparent. And it's now this style property which we will add as an image style. So to the image that's inside of this view that is exposed by image background. If we save this, now we have the image and the gradient. And now we have a combination of gradient and image, which I think looks quite nice. Of course, as always, feel free to pick different styles, but I'm quite happy with that background. And I would say after all that styling and layouting and all these things on which we worked thus far, it's now time to dive into some actual logic. Because up to this point, we have a nice user interface, but nothing happens when we tap those buttons or when we enter something into the input field. And it's time to change that. So let's start working on the game logic now. And this includes fetching the user input, resetting it if we click this button, and moving on to the actual game screen if we confirm the input. Though we also want to validate the input. For example, we want to make sure that if it's empty, we don't proceed to the game screen. That would not be the behavior we want. Instead, in that case, I want to show a little alert that tells the user that a value must be entered here. In addition, I also want to make sure that you can't enter, let's say, 0 or -1 as a value here. So we'll also have to make sure that this is not possible. Now, how can we fetch and handle the user input with good old state? Because again, it is just a React component. And now we want to fetch some user input as we did it before in the course already. And using state for that is, of course, the standard React way of doing that. Therefore, we should import the useState hook from React so that we can manage state in this functional component. And here I then have my state for managing or for getting this entered value, and therefore I will name this entered value, or actually entered number, since it should be a number. And we have the set entered number state updating function, and here out of the box this is an empty string. Now it's an empty string instead of a number like 0, because actually I will bind this to the text input, and even if you have number pad here, what you will get as a value will always be a string. It will always be of type string, even if the text is a number, even if the text contains a number. And that's the same as in the web. So what we get from text input will always be a string. We can of course convert it thereafter, but since I plan on binding this state to the text input, I also want to manage a string here. Now with bind this to the text input, I mean that I want to set the value prop on text input and set this equal to entered number. I do this so that we can change the state from anywhere in this app, for example when the reset button is clicked, to reset it to an empty string, and such state changes are then reflected in text input. That's why I'm setting the value prop to the state. But of course, we also want to update this entered number state whenever the user types into the text input field. And for this, we can add a function, the number input handler, for example, which should be executed upon every keystroke, which can be achieved by adding the onChangeText prop here to this text input. And then we point at this number input handler, and this will in the end execute this function on every keystroke that is done on this text input. And conveniently, we automatically get the input text or the entered text passed into this function by React Native. So we automatically get a value for this parameter because React Native will invoke this function for us for every keystroke on the text input. And in here, I'll then set my entered number to the entered text. So I'll update my state with the text entered into this input field. Now, that is all nice. That's a good first step. The second step, of course, is to connect this confirm button. For this, I'll add another function here, which I'll name confirm input handler. And the idea here is that we then check the current state that we have. We check if it's a number and if it's greater or equal than 1 and smaller or equal than 99, because I only want to allow numbers in that range. And then we proceed to the next screen if it's valid, and we show an alert otherwise. Now let's first connect this to the button though. And for this, our primary button should expose a prop that does allow us to pass in a function. And if we have a look at the primary button, then at the moment, we don't use any props in here that would take a function. Instead here, our pressable does have the onPress prop, and we point at the press handler, but there we just log to the console. Now I want to make this button reusable. I want to make this custom component reusable. And I want to add a prop that allows components that use this button component to pass in a function that will be executed upon a press. And therefore here, I'll also pull out another prop from that incoming props object, which I'll name onPress. Now this name is up to you because this is your component and your props, but it makes sense to use onPress, I'd say, because we know that we want a function that should be invoked when that button is pressed. So that is a name that makes sense to me, but it's not a must use because it is your component. In pressHandler, we can then execute onPress. Or we get rid of pressHandler and we just forward that value which we receive on the onPress prop to the onPress prop provided by Pressable. Now this name here on the left is not up to you, that's a prop provided by Pressable, but this here is up to you because this is your prop. And now we simply forward the value we receive on the onPress prop to the onPress prop of Pressable. Yeah, it's a lot of presses, but it's hopefully clear how that works. Again, this is standard React, nothing React Native specific here. With that, we can go back to the start game screen, and now we can add the onPress prop here on the primary button. And if you chose a different name here and here, you have to use that different name here now, but I'm using onPress, so I will use this name. And here I point at the confirm input handler. So a pointer at this function is now passed to the primary button, or to be precise, to this instance of the primary button, and there it's forwarded as a value to the onPress prop on Pressable. And therefore, whenever we press this button, this confirm input handler function will be executed. And in that function, we can now add all our validation logic and show an alert if an invalid value is provided. So let's now add this input validation logic here. For this, I'll first of all create a chosen number constant where I want to convert the entered number state that I have here, which is a string, to a number. And this conversion can be performed by using the built-in parseInt function. This function is globally available in JavaScript in React Native apps, just as it is globally available in the browser. So you can just call it like this, and to parseInt, you pass the entered number. This will convert this string to a number, or at least it will try to convert it. This would fail if something is entered that is not convertible to a number, like non-digit characters. Therefore, I next want to add an if statement here, where I check if this is maybe not a number, if the conversion failed. This can be done with the built-in isNotANumber function, which is also globally available and to which I pass chosen number. This will return true if chosen number is not a number, so if the conversion failed. Now I also want to add a couple of other checks, because if this check fails, or one of the other checks which I am about to add, in that case I want to show an alert. Show alert, that's what we'll do soon. So the other checks I want to perform are separated by an or, because I want to show the alert if this is not a number, or if chosen number is a number, but it's smaller or equal than 0. So if it's 0 or smaller than that, that would also be invalid, and I want to show an alert in that case as well. Or I want to show an alert if chosen number is greater than 99. If it's too big, I also want to show an alert. Now, I also want to return thereafter to make sure that this function does not continue its execution if we make it into this if statement, so that we cancel this function's execution. But how can we now show such an alert? That would also be interesting. And here, React Native got us covered. React Native exposes an alert API. Now, this is now not a component which we display, but instead alert is an object that holds a method that we can call to show an alert. To be precise, the alert method. It also has the prompt method, which would display a dialog where we can enter a value. But here I'm interested in the alert method, which shows a dialog which we can only confirm by pressing a button. Now this alert method here wants a couple of arguments. The first one is the title, the second one will be the message, and the third one allows us to configure the buttons that will be part of that alert. And this alert method, by the way, will create a native alert dialog, as you will see in a couple of minutes. So it will use the native alert API built into the iOS and Android platforms. So here I'll say invalid number as a title, and then as a message I'll say number has to be a number between 1 and 99. And then as a last step, we can pass an array where we configure the buttons that should be shown. And you can actually add multiple buttons to the alert, but here I will only add one. And a button is defined by adding an object to this array. And in this object, every button then has a text, which is the caption of this button, in this case, OK. And it has a style. And the style can be default, destructive, or cancel. And this will basically influence which text color is used, if the text is bold, things like this. And here I will use destructive, but feel free to play around with these different styles to see how the look changes as you change the style. Last but not least, you also can add on press property, which allows you to point at a function that should be executed when that button is clicked. So when that button on this alert is clicked. And I do want to do that because I want to reset the input once this button is clicked. So that if an invalid value was provided, we show the alert. And once the alert is confirmed and handled by the user, I want to reset the input to get rid of the invalid input value. For this, we can add a new function, maybe here, the exact position doesn't matter, which is the reset input handler. And here I will set my entered number to an empty string to set this back to an empty string, which also was our initial state. And since we bind entered number to the value of text input, if we change entered number, if we change this state as we do it here, the value in the input will be changed. So therefore now we can point at reset input handler like this, and now the input will be reset whenever this dialog is confirmed. Now, last but not least, I will also connect this reset button to this newly added reset input handler function by adding the onPress prop and pointing at reset input handler here as well. This is not related to the alert, but it's also something we need to do. So now we should show an alert if the value is invalid. Otherwise, I'll just log valid number for the moment. In the future, we will of course make sure that in this case, we move on to the next game screen. But now with all these changes applied, if we save this and we maybe reload all our apps to make sure that all the changes are applied to these simulators, if I try to submit an empty input, I get this alert. And you see I have this red text here because I used a destructive style. And I get this alert, which has the default iOS alert look and feel because it is a default iOS alert. On Android, I get an alert that has the default Android dialog look. Now, if I enter -1 here, I also get such an alert. If I enter a valid number, nothing happens though. Instead, then we see valid number logged in the console. If I click reset, this is reset. And if I entered something invalid and I click OK on this dialog, it's also cleared, as you can see. So this all works as expected. Now we're fetching this user input. Now we can make sure that we then move on to a new screen. Because at the moment, we only have one screen, and that's this screen here, which is also not entirely finished, but good enough for now. So now that we can enter and confirm a number, let's make sure that we're able to switch to a game screen once we get a number. And for this, we already have this GameScreen.js file, but at the moment it's empty. Therefore, it makes sense to also add a functional component in there because, of course, this new screen will also be a component in the end. So we export this component here. And then here, for a start, I will add some text where I just say game screen. And we have to import this text component from React Native, of course, otherwise it's not available. Now this screen here should be displayed as soon as the user picked a number. How can we do that? Well, later in the course, in the navigation section, we will learn about a third-party package that helps with navigating between different screens. But we can also navigate without that package, and to keep things simpler for the moment, I will show you how you can do this without any external dependencies. Because in the end, you just have to keep in mind that we can use standard React tools like state to change what's visible on the screen. And we just want to swap this start game screen here in the app component with the game screen as soon as we have a number. So all we have to do for that is manage some extra state in this app component that basically keeps track of the fact whether we have a number or not. So we can import use state from React here in the app component. And then we want to register some state here with use state. And that state that I do want to register here in the end is simply the number picked by the user. So the user number, for example, which we can set with this state updating function. And initially this is null. We could also set it to 0, but I will set it to null, so to undefined to be precise, to make it clear that we have no number initially. Now we can add a function, let's say the start game handler or the picked number handler, whatever name you want to use. And here I expect to get the picked number, so the number picked by the user. And once a number was picked and confirmed, we know that the game should start. So here we get the picked number once it is confirmed, or at least that's the plan. And then here we can set the user number to that picked number. Now, why is this helpful? Because now we can use this user number state here to either render the start game screen if we have no user number yet, or render the game screen if we do have a user number. So for this, we can import the game screen here from /screens/game screen. And then here I'll add a helper variable called screen, which is the start game screen by default. But I'll then add a if check here directly in my component function. And therefore this if check will be re-executed whenever this component function is re-executed, which will be the case whenever state changes. And in here I'll check if user number, if this is truthy, which will not be the case if it's null or undefined, which it is initially. But if it's truthy, so not null and not 0, which can't be the case because we validate for this in the start game screen. So if it is a valid number, then we'll make it into this if block. And in that case, I'll set the screen variable here to the game screen. And then we just have to render this screen variable here in the JSX code instead of the hard-coded start game screen. So now we either display start game screen or game screen. Of course, at the moment though, picked number handler will never execute, which is a problem. Now we do want to execute whenever a number is confirmed inside of start game screen. And again, we can use props for that, and we can pass a pointer to this function to start game screen with help of props, so that this function can be executed from inside the start game screen component. And this is a standard pattern in React, which we used before with the primary button and the onPress prop we accepted there, and which we will now use again with Start Game Screen. So here we could have a onPickNumber or onConfirmNumber, whatever you want. I'll go with onPickNumber. It's your component, so the prop name is up to you. And here I will point at PickedNumberHandler. Now we just have to accept and use this prop inside of Start Game Screen, and therefore in this component we can use props here or object destructuring to automatically pull out this prop from the incoming props object. And then here we want to execute that whenever a number is picked and confirmed. And that is the case in the confirm input handler after this if check where we currently log to the console. Instead of logging to the console, I now want to execute onPickNumber, and very important, I want to forward the number that has been picked. Because in app.js, I expect to get this picked number. So in Start Game Screen, when we call the function received on this prop, which will be the PickedNumberHandler function, there we now want to pass the picked number as an argument to that function. So we want to pass the chosen number, which is our converted and validated number, to this function. Well, and with that, if we save everything, if I enter something invalid, we still get the same behavior as before. But if I enter something valid here, this disappears and I'm on the game screen, as you can see here in the top left corner. Of course, the game screen has absolutely no layout and therefore it looks horrible, but we successfully switched the screen. And now we can build up on this and start working on that game screen. So let's start working on this game screen now. And we get a couple of things that should be added there. For example, the main thing that's happening on this screen is that our phone, so the program in the end, the app, is guessing a number, and then we have controls to tell the program if the number is too high or too low. Therefore, we definitely need to output the guessed number, and we need to derive the guessed number as a first step. Then we need to output the controls that allow us to provide feedback to the program, and then we need to recalculate a new number based on that feedback. In addition, I want to log all the rounds we had in the game, so I want to log the different guesses that have been made. Therefore, here in the game screen, we will definitely need a view to group all these different UI elements that we need. So we'll have this main view, and then in there, I want to have a text where I say opponent's guess. This is just a title, but I want to have this kind of title here. Then below that, I want to have the actual guess being output. And yes, we can't add text like this in a view, but this is just a placeholder. We'll add a nice component that shows the guess by the opponent here. And then below that, I want to have another view which holds the controls that we have to tell the opponent, the program, whether the guess was too high or too low. So here we could have another text where we say higher or lower. And then below that, we have our two buttons where we basically show a plus or a minus to indicate whether it's too low or too high. These are also just placeholders. We'll add real buttons instead soon. And then below all of that, we'll have another view where we log our rounds. So that's the general structure with plenty of placeholders that we have here. And we'll have to fill those placeholders step by step, and we'll have to style this overall screen step by step. And I'll start by styling this view that wraps everything. I want to make sure that we don't have the content crammed up to the edges here. Instead, it should be centered, it should be clearly visible on the screen. And of course, for that, we can use good old Flexbox. So we'll add a style sheet here in this game screen component as well, and create the styles constant, which then will hold a style sheet that is created with the create method. And then here in this style sheet object, I'll add a property named screen. Name, as always, is up to you though, which gets flex 1 to make sure it takes up all the available space instead of just the space needed by the content of the element that receives this property. We want to take all the available space instead. And I'll already add some padding, let's say 12 pixels, to make sure that we add some distance in all directions so that we have some distance to the device edges. Now for the moment, that's it. For a start, that's good enough. And then I'll add this style to this view as we did it many times before, like this. If we save this, I get an error, of course, because I have these texts here, which must go into texts. And I'll just comment those placeholders out because they are just meant to be used as placeholders, not as actual text. I also have this text, of course. Let's comment this out as well. Now with that, finally, if I go to this screen, we have this extra content, but it's actually still in the top left corner. Now actually, there is some padding here. As you can tell, if I ramp up the padding to 40, now it's moved in further, but 12 pixels wasn't enough. Now we didn't have the problem here on the start game screen, because on this screen, we do add quite a lot of margin to the top. We could add this here as well on this game screen, but actually I want to introduce a new component that is very useful when it comes to adding some distance to the device edges, especially to the top of the device, to the notch as we have it here. And that's the safe area view. Modern smartphones often have notches like this. Here it's the typical iPhone notch, other devices have a smaller notch, but often we do have notches like this. And therefore we want to add some distance to make sure that our content isn't too close or even under that notch. But of course, not all smartphones have such a notch, and it's not the same size for all smartphones. Therefore, it would be nice if there would be some component that would automatically detect on which device we're running and add an appropriate amount of spacing around our content to allow for that notch and for that status bar. And it turns out that such a component thankfully exists, and it's even built into React Native. It's the Safe Area view. And actually, I want to wrap this view around all my screens, not just around the game screen. Therefore, I will not import it in the game screen, but instead in app.js, because there I want to wrap it around my entire screen content. So here we can import the Safe Area view from React Native. And then we use this view by simply wrapping it around our main content. Now I'll go inside of the linear gradient and the image background because I do want that background to be under the notch. I don't want my image to end here in front of the notch. It should be below the notch instead, so that's fine. But I do want to make sure that my main content, my screen content, is not going under that notch. Therefore, I'll add my Safe Area view here and wrap it around this screen. Now we just need to make sure that we also add style here to the Safe Area view, and we apply our root screen style to that as well, so that we still make sure that all the available space, minus the area that is reserved for the notch, which will be taken care of automatically, is made available for this inner content. With that, if we save this, not much changes on the starting screen. If I reload everything, we can see this doesn't look too different, that's fine. But on this other page, we see that now this is pushed down further, and we do have this nice distance to the top. If we have a look at this on Android, we see that it's way further to the top because there is no notch on this emulator. So this is now looking better. Some extra distance would still be nice, so on the game screen, I'm still going to ramp up the padding a little bit, maybe to 24 pixels, but we do use this in conjunction with the Safe Area view to make sure that we don't go under that notch. And this is a super important technique in Vue, which you will use a lot because, of course, typically you want to make sure that your content is not hidden by notches like this. Great, so now we added this save area view. Let's now continue with styling and laying out the rest of this game screen. And this opponent's guess text, for example, should be a title, not a small little text as we have it here. And to make it a title, we can add some extra styling. For this, I'll add a title property here. And then we could say that a title should have a font size of 18 maybe. Maybe it should have a font weight of bold. That might make sense for a title. And we can give it a certain color. The color is up to you, but here I want to use a yellowish color, and I'll use the yellow color I have here in the start game screen. So I will assign that here. Now with that assigned, we can go back and add our style here like this. If we do this, this is looking better, but I'd also like to center it. So I'm also going to add text align center. And maybe we ramp up the font size even more to 24 pixels. And this looks better. Now, what I want to add in addition is I want to add a little border around this title. And I also want to add some padding therefore, so that we have some distance between the border and the actual text. So I'll add a border width of 2 here, and a border color of that same yellow as I had it before. And last but not least, I want to add some padding here in all directions of, let's say, 12. And with this, I have this kind of title. Now, of course, you can adjust the title to look however you want it to look, but I'm quite happy with this result. By the way, the layout is not final. We will make sure that this is all pushed down a little bit more in the future. But now we have this title, and it's probably fair to assume that we might be using a title like this quite frequently in our application. Maybe on different screens, but typically with the same styling, or maybe minor styling differences. And therefore it would make sense to outsource this text into a separate reusable component, because that is what we typically do in React when we do have elements that are used in different places of our app. So in the components folder, I'll add a new file, which I'll name title.js. And in there, I'll add a component function, which I'll also name title, which I'll of course export as always. And the job of this component is to display such a configurable title. So we can grab this text here from the game screen and cut it from there and add it here as a returned JSX code. Of course, for this to work, we need to import text from React Native here in this title.js file. And the text here should of course not be set in stone. Instead, I'll remove it and I'll use object destructuring here to pull the children property out of my incoming props and use that here so that the actual content that is displayed by the title can be set by adding it between the opening and closing tags of my custom title component. And now in GameScreen.js, we can use this custom title component. Of course, for this, you must make sure that it's being imported. And then here, we can output opponent's guess like this. Now for this all to work, we also must migrate our styling, and we can therefore cut the title style from the game screen and move it into the title component. There, of course, we must import style sheet and create our styles via style sheet create like this, adding the title property. With all of that, if we save everything, we got the same title as before and nothing changed here, but we have this reusable component which we could use in different parts of our application. Now in the previous lecture, we added this title component. And by doing so, we made sure that we had this reusable title. But speaking of reusability and repeating certain things and settings, you might have noticed that these colors which I'm using are used in different places of the app. I'm using colors in the start game screen, in the primary button component, in the title component. And having all these colors in all these places is not ideal. It's just as in web development with CSS. If you're using the same colors in different places, which you typically are, repeating them manually is annoying because you always have to copy the exact same hex codes. And if you would change the color at some point, and even if it's just a slight change, a small change, you would have to apply that in different files of your project, which of course is not great. Now in CSS, you could solve this problem by using CSS variables, CSS custom properties. But this feature doesn't exist with React Native because we're not using CSS here. Therefore, what is commonly done in React Native is that you create a helper file that exposes certain constant values like the colors you're using. And for this, I'll add a new folder, which you could name util for utility, or constants, or whatever you want. And I'll go for constants because I'll manage some constant reused values in there. And then I'll add a colors.js file in there. And in this file, I'll create a colors constant, which is just a regular JavaScript object. But in this object, I'm now going to set up various properties which I'll reuse over and over again throughout this app. For example, a primary color, and since I plan on managing multiple shades of that primary color, I'll name this primary 500. It doesn't have to be 500, it could be primary 1 and 2 and so on, but I will indicate how saturated or dark a shade is by higher or lower numbers after the main property name. Now my primary 500 number could be this primary plum color which I have here in my button, for example. So in colors, I'll set this here as my primary 500 color. Now we can export this colors constant here as a default and import it in all the places where this color is needed, like in the primary button. There we also have a different shade, by the way, because of that ripple effect. It's a slightly darker shade. So I'll go to my colors constant and also add primary 600 to store this shade here as well. And then in primary button, as mentioned, we can import colors from going up one level, diving into the constants folder, and then into the colors file. And now here we want to use the darker shade. So I will access colors.primary600 to use that constant value. And down here in the style sheet, we can use this constants array as well, and I can access colors primary 500. And if we would change the colors here in this colors file, those changes would be applied to all the components where we import this constant. That's the advantage of using this approach. Because now we can manage the colors in one global place and then use these colors in multiple components, and changes therefore only have to be made in one place instead of many places. So I'll go to all the other places where I'm using these colors as well, like the start game screen. Though there I'm not using this plum color as it seems, so no change needs to be made there. Oh, I am using it here, an even darker shade. So let's cut this from start game screen and add this darker shade, maybe as primary 800 to leave an extra space for an in-between shade if we should need it, and add this here. And then in start game screen, we also want to import colors from going up constants colors like this. We can then use this down here and use colors.primary 800, which was this super dark shade we added. And we can now also add the yellow color here. This is our accent color, so the alternative color. So I'll name this accent 500 and store the yellow color here. And then again in the game screen, in the places where we need that, in the start game screen, we can replace this hard-coded hex code with colors accent 500. So do that here and here. And we're using that same yellow color in the title component. So therefore here we can now also import colors from going up, constants colors, and use that instead of the hard-coded yellow values here. So that we have colors accent 500 here for the text color, and then also for the border color. And that's how we can use these color constants in those various components. Now we don't use any colors in app.js. Oh yes, we do here. So let's also import it there. Import colors from /constants colors. And then here, this should be, it's an extra shade actually, as I can see. So we might want to add that. And this looks like a shade between primary 600 and 800. So it's good that we left some space here. Yeah, I think it fits in there. And now we can use that. We can use this newly added color, this primary 700 shade here in this app file. And then this is our default yellow. So here we can use our accent 500 color. With that, if we save this, this should work again, and we should have the same look and feel as before. Also, if I reload and end up on the starting screen, this looks good. But now we're managing this in a global place with all the advantages I outlined. So now that we added this title as a reusable component and we added our reusable colors, it's time to work on the other features that should be implemented into this game screen. And for this, we need to output a guess made by the phone, by the device, because we're playing against the device. And the device should guess, the phone should guess our chosen number. Now, to generate this guess, we need to calculate a random number. And for this, attached you find this utility function, which generates a random number between a min and a max number defined as inputs here. And we can also pass in an exclude number, which allows us to exclude a certain number from being generated, which will be important for making sure that we can't immediately guess the number chosen by the user. Because here I want to make sure that the phone is not able to guess the correct number right at the start. And therefore I add this exclude parameter, which allows me to exclude that single number so that the phone can't win automatically in the first round. It's a little extra difficulty that's added here for the phone. Hence these three parameter values. And then inside of this function here, I generate a random number with this calculation where I use mathRandom, which creates a random number between 0 and 1 with 1 excluded. And I then multiply this with the difference between max and min to translate this random number between 0 and 1 to a random number between our max and min. And I use mathFloor to then round this down, since this would give us a decimal number with decimal places, and we don't want that. We want integers, and we round down with mathFloor. And since we're rounding down, we actually add our minimum boundary again, so that the lowest number we can get is not 0, which would be the lowest number otherwise, because mathRandom can produce 0 as a result, but that instead our lowest possible boundary is the minimum defined here. That's what we do here. And then here I just check if that random number happens to be that number that we excluded, in which case we call generate random between again recursively to simply calculate a new random number. And we keep on doing this until we derived a random number that's not equal to the excluded number. And if we did not hit the excluded number, we just return the random number. So this generates random numbers, and now we want to generate a random number when that game screen is loaded. The first guess made by the device should be generated whenever this game screen is rendered for the first time. And this generated random number will change over time and will be reflected in the user interface because I want to output it here, and therefore we should use state. because we got some data that changes over time and where every change should then be reflected on the user interface. Therefore, in order to manage state here, we import useState from React, of course, as we always do. And in the game screen, we can then initialize our state slice. And here I then have the current guess of the phone and a state updating function. And the initial value for this state should be an initial guess, which we make by simply calling generate random between. And I want to generate a random number between 1 and 100 because the upper boundary will be excluded, because with moth random, the upper boundary, which would be 1, is excluded. So we have to go one value, one number above our actual highest number here as well. And then I also want to exclude a number, and that excluded number should be the number chosen by the user on this starting screen. So therefore, we need to make sure that we have access to this chosen number in this component. And how do we get access to values that are derived in different components? Typically through props. We could also use React context, but here I'll just use props. And I'll use object destructuring here right away. Alternatively, we could of course also accept the props object and use the dot notation here, but I will use object destructuring instead. And I expect to get the user number as an input here, as a property on my props object. And I then can exclude this here so that the phone can't guess this user number when that state is initialized. And then this initial guess is set as an initial value for this state. Okay, so now we have that. Now we have this guess that's being made, and now we can output this guess here in our user interface. And for outputting this guess, I want to build a nice looking text here, a nice looking text element, which I actually will outsource into a separate component. Not because we have to, but because I want to keep this component a bit leaner, and especially the JSX code a bit leaner. Therefore, in the components folder, I will add a game folder to add the game-related components into that folder. And I'll move primary button and title into a UI folder to store general UI-related elements in that folder. This is not required, but helps me organize my files. So I'll move these files, and I do want to update my imports automatically, so I will choose always automatically update imports to make sure that all the imports are updated such that moving these files doesn't break the app. And in that components game folder, we can now add a number container. The name is up to you, which will be a simple container that is responsible for outputting the number that was guessed. For this here, I'll add a function, number container, so a default component function here, which is exported. And I want to return a view that contains a text. I add this extra view as a wrapper so that I can nicely position and style this text. Of course, as you learned, we need to import these two core components from React Native, otherwise we can't use them. So that's something we have to do. And then I expect to get the number that should be output as a prop here, and I expect to get it as the prop that is used, or as the value that is used between the opening and closing tags of this custom component when that component is used in a different file. So hence we can use this special children prop to output that content. Now this container is mostly about the styling, of course, and therefore I will add my styles here by using style sheet create, as we did it many times before. And now the styles that I do want to have here are one style for the container, so for the view, and then one style set or one set of properties for the text, for the actual number text, you could say. These names, as always, are up to you. Now for the container, it's totally up to you, and as always, I encourage you to play around with that and come up with any styles you want. I will set a border width, which we already did many times at this point. I will give this a border color, and here I want to use my global colors so that I take advantage of this global definition of colors. So I will go up to constants and then to the colors file with this import. And then I want to use color accent 500, so this yellow color here as a color. I'll add a lot of padding with 24 pixels, and I'll add a border radius of 8 maybe to have rounded corners. That's why we also need a view, because border radius is not supported on the text element. So if I would have used just the text without a wrapping view, I could have added things like the border and padding, but adding a border radius would not have been possible on iOS. Hence, we need the extra view as a wrapper. Now I also want to have some margin around this box, so actually here I'll also add a margin of 24 pixels. And since all these views are flexboxes by default, I will add align items center and justify content center to make sure that the actual text in that container is nicely centered. And then on the number text, which is the style that will be applied to this text component here, I will set the color to colors accent 500, so to the same yellow, and the font size to 36, so that we have a really big number. And I'll set the font weight to bold here. And now we can apply these styles to these elements here. So the container style is applied to the view, and the number text style is applied to the text. And that's now the number container component that should be used in the game screen to output the guest number. So for this here, below this title, I'll output the number container, which therefore, of course, must be imported from components game number container. And with that import added, we can use that here in our JSX code. And between the opening and closing tags, I will pass in the current guess that was made by the phone. Now, if we save that and reload everything, it looks like there is an error with this import. Looks like this import path was not updated by VS Code. The title component is now in the UI subfolder, so we must look for it there. And in addition, looks like a couple of other imports also were not adjusted. Like here inside the title component, we need to go up one step further. We need to go up to a higher level folder because we moved title into a lower level folder, into this new UI folder. So that was also missing. And now it looks like things are working again. So let's force a reload on all these devices. And now if I start this game, here is my guess. And actually, if I look at this, I think it will look a bit nicer if the title is not also yellow, but if it is maybe white. So here in title.js, instead of using colors accent 500, I'll use white. By the way, we could store this white color in our colors constant as well, but since this is already a clear predefined identifier, I'll just use it like this. Yeah, this looks a bit nicer. Now we have our guess here, and this initial guess, of course, will be different every time we start a new game. So here on Android, it's different than what we see on iOS, for example. And if we would restart the game on iOS, we would also very likely get a different number the next time. But of course, that's just the first step. Deriving an initial random number is nice, but now we need to make sure that we have buttons that allow us to give the computer some feedback on whether that number is too big or too small, so that a new number can be derived. So let's work on that feedback area now. And for this, below this higher or lower text which I have here, I want to output two primary buttons using my own custom built button. One button that shows a plus and one button that shows a minus. Now for this, of course, you must make sure that primary button is being imported in this file. So this import must be added. And then we can add a plus and a minus button. We will later replace plus and minus with better looking icons, but for the moment, these default characters will do. Now I actually want to make sure that these two buttons are next to each other in a row below this text here. And therefore I'll wrap them in an extra view, just as we did it a little bit earlier, so that I can then ensure that this view, which holds the buttons, positions its children in a row, whereas this view, which holds the text and then the view with the buttons, positions these elements in a column below each other. And I will add the styling code for creating that layout later, but that's the general structure I'd like to have. Well, and now we can add the onPress prop to both buttons, and then make sure that we have some function we can call that will derive a new random number. And for this, I will add a new function here, the nextGuessHandler function, and the job of this function is to derive such a new number. For this, we need to know if that new number that should be guessed should be higher or lower. Now we could write two separate functions, where then one function is bound to this first button and the other function is bound to the second button. But here I will simply use one function, which takes a parameter, which could be called a direction, which then could be a string that is either lower if the new number should be lower than the previous number, or greater if it should be greater. So that is what direction should hold actually. And since I will be the one calling that function, it's my responsibility to pass in either lower or greater as values. And then inside of nextGuessHandler, we can check if direction is lower, which means we want to now generate a lower number, or, well, if it's higher. Now for that, to derive that number, we of course want to call our random number generation function again. So generate random between, we want to call that again. But now we need new boundaries. And if we know that the new number should be lower than the previous number, we know that our minimum boundary was okay, but the max boundary needs to be adjusted because it was too high. Otherwise, the new number wouldn't have to be lower. So my min should stay the previous minimum number, but how do we know what the previous minimum was? Initially it's 1, but of course that could change over time. If we had to guess a higher number at some point, the minimum is no longer 1. So both the min and the max boundaries are actually dynamic, and they're only 1 and 100 initially. Now what we can do for this is we can add extra variables which we manage outside of the component function, so that the variables won't change just because the component is re-evaluated. And here I'll have my min boundary, which initially is 1, and I have my max boundary, which initially is 100. And then we could use the min boundary here and the max boundary as initial values, but we can also change these variables as soon as we have to. So here, for example, when we know that we need to guess lower, we know that our new max boundary actually should be the current guess. Because we know the current guess was too high, so it makes no sense to guess a number even bigger. Because if we have to guess lower, we know that the current guess was too big, otherwise we wouldn't have to guess lower. And therefore we know that the current guess is definitely the upper boundary. Actually, it's the current guess minus 1 even, because if the current guess would have been the right number, we would have won. So it has to be the current guess minus 1. That's our new max boundary. On the other hand, since the max boundary is excluded here when calling generate random between, we should not deduct minus 1, because if we do so, we actually exclude a number that could be the valid guess. So setting max boundary to current guess is fine. It will be our current guess, which then will automatically be excluded by generate random between because of how this function works. Now the min boundary has not changed here when we need to guess lower. So now we generate a random number between the min boundary, the max boundary, which we did update. And when it comes to excluding a number here, we actually want to exclude the current guess. It makes no sense to guess the same number again, though it would be excluded anyways here, since it is our new max boundary, which, as mentioned before, is excluded anyways because of how this function is written. Nonetheless, we exclude the current guess here, and with that we should guess a new lower number. So here we have the new random number that's being guessed, which should be lower than the previous one. Now else, if the direction is not lower, we know that we need to guess a higher number. So we need to generate our random number as before, but now we need to adjust the min boundary instead of the max boundary. And the new min boundary here in this case should of course also be our current guess, but the current guess plus 1. The min boundary, unlike the max boundary, is included in the set of possible results, and therefore we have to add plus 1 so that we don't guess the same min boundary again. We would exclude it also because current guess is excluded, but still, this is an adjustment we can make here. This exclude parameter mostly exists for the initial guess. For the other guesses we don't really need it, so therefore here setting this to the current guess each time is perfectly fine. And of course, you will notice that this random number calculation, this line of code, is exactly the same, so we can move this out of the if-else statement and remove it in the other branch here, and just have it once and just adjust the boundaries inside this if-else statement. So now we have this new random number here, and this is now the new random number we want to use as a new state for the guess. So now we can call the setCurrentGuessState updating function and set this equal to the new random number. Now with that, this should be updated, and we just need to bind this function to these buttons now. And for this, of course, we want to point at the nextGuessHandler function on both buttons, but we need to pre-configure this function because this function wants a parameter, the direction. And you learned that you can pre-configure a function like this that will be called by someone else, like in this case the button and therefore React Native in the end, by using the bind method on that function. This allows you to pre-configure the parameter value that will be used in a future function execution. Now the first value of bind actually sets the this value, so it sets the value to which the this keyword would refer in this function. And since we're not using this keyword here, this does not matter at all, so I will just set it to this. But the second value is then the first parameter received by that function. And here that should be a string with the content lower, because that's one of the two string values we want, because that's one of the values we're checking for. We're actually not checking for the other value in any place at this time, but still here I will set this to greater nonetheless. And actually now it's wrong. This should be the minus button. This should be the plus button. So update these characters so that they fit the way we call this function. Okay, with all of that, we added those buttons, we added this functionality. Let's see whether it works. We got the buttons here, and if I click a plus, indeed, we get a higher number. If I click a plus again, we get an even higher number. And if I click the minus, we get lower numbers. However, only up to this point, and now the app froze here. Let's try this again. Yeah, at some point, it freezes with a maximum call stack size exceeded error. So it looks like we're somehow entering an infinite loop in some place. And that causes the app to crash. Now, where does this happen? Now, to understand why this happens, let's actually add a console log statement to this nextGuessHandler, and let's log the min and max boundaries. Because there is a reason why this is happening. If we add this and we force a reload, let's say I have the number 31. Now I tell the computer that the number should be smaller than 71, smaller than 63. And if we have a look at the log, we see that indeed we're logging the min boundary, which never changed. And we have our max boundary, which makes sense. And we have no problem right now. Now, if I now give the computer a wrong hint, for example, like this, then we see that the min boundary is now 46 and the max boundary is 63. At this point, the computer has no chance of guessing the right number, which was 31, but that's not even the main problem. The main problem is that if I now say lower again and lower and now higher, at some point we narrow down this area to an area where no guesses can be made anymore. At the moment it's still possible, but if I decrease this again and I decrease this again, now we get to a range where if I press this again, we actually have a range that is no range anymore. Now a random number between 48 and 48 would have to be guessed, and that number can never be found, and therefore we enter an infinite loop. Because this is then also always equal to our latest guess, which was 48, and therefore we always make it into this recursive function here, guessing more numbers, never getting out of that. So actually the problem is that we can make contradicting indications to the computer. And besides entering this infinite loop, this would be a problem anyways, because we should play fair. We should let the phone know if the guess was too high or too low, and we should not be able to say, you need to guess higher, if actually you need to guess lower. Therefore, we should add another check here at the beginning of next guess handler, and there we should check if the direction is lower, and at the same time, the current guess that was made is smaller than the choice made by the user, than the user number, which we get through props. Because if the current guess is smaller, and we're saying that you need to guess lower, then we are lying. Because you already guessed lower than the user number, so telling you that you need to guess even lower is a lie. The same would be true for the opposite if I copy this and combine it with an OR statement, because that would also be a problem. If we say the direction is greater, but the current guess is actually greater than the user number, then we're also misleading the phone into a wrong direction. And this is what causes the infinite loop in the end. So now I'll group this together in parentheses. And now with this extra if check added, if we return here, and not calculate a new number in this case, we won't have this infinite loop anymore. Of course, I don't just want to return silently, instead I want to let the user know that he or she lied. And we could do this by throwing an alert. So by using this built-in alert API again, which we already used before, we can use this to now show a short alert message here by calling alert and saying, don't lie, you know that this is wrong. And then we can add a button here with a text of sorry, for example, and the style of this button could be cancel. You can, of course, configure this however you want. We don't need to add an onPress handler here, because I don't want to do anything when this button is clicked. Instead, I just want to close the dialog, which will happen automatically, and then return. I'm just warning the user that an incorrect indication was given. Now, one thing that's missing here, though, and that was already missing before, to be honest, is the user number. The user number is received as a prop, and we're using it to calculate the initial random number, but actually I forgot to pass this number into this component. So all the time we didn't take it into account. Therefore, what we should do here is we should go back to app.js, where we manage this number with state, and we should of course pass it into this game screen as soon as the game started. So here I'll set the user number prop and set this equal to the user number state that we're managing here in the app component, so that this picked number is exposed to the game screen. We should have done this before. I did it now to make sure that this number really ends up there. Now, with that done, if we reload everything, what we'll have now is that if I enter a number, and now I have a guess that's too high, the number is too big, if I tell the phone that it needs to guess even higher, a bigger number, I get this alert. So now, actually this would have been the right number, we just don't have any exit condition yet, but now I get this warning. And now with that, we get this alert whenever we mislead the computer. So that's another huge step forward, and we're getting closer to implementing this final game logic that we need. Now with this logic added, we're able to give instructions to the phone on whether it should guess lower or greater. Now, the kind of logic that is still missing though is some logic that checks if the game is over. And the game is over once the device guessed the number we chose on this starting screen. So once the device guessed 31 in this case, then the game should end. And at the moment, this is not happening. It just crashes when we reach that number because we then again enter some infinite loop because of how our code is configured. Now, how could we check whether the game is over or not? Well, there might be different ways of implementing this, but I would say that we need to check the current random number and compare it to this number defined by the user. We need to make this comparison between current guess and user number. And if these numbers are equal, we want to let the app component know, because in that component, we then want to switch from the game screen to the game over screen, which we have yet to add. So therefore, there are a couple of things we want to do. In the game screen, we want to check and we want to compare the current guess to the user number, and this should be done whenever the current guess changes. Now, how do you do this with React? Well, typically you use useEffect, because this allows you to run logic whenever some dependencies, some state, for example, change. And therefore, we can import the useEffect hook from React and use that in this game screen component, maybe here. We can use useEffect and add a function here, maybe an arrow function. And in this function here, we want to check if the current guess, which is this state, which we change with the next guess handler, if that is equal to the user number. And if that is the case, then we want to call a function that is defined in app.js, in the app component, that changes the state there to basically tell React that the game is over and that a different screen should be rendered. And for this, in this app component, we also want to find a way of changing that state. And we could do this by registering a new state here in this app component, which is our game is over state. Set game is over, like this. And initially, this is actually true because initially the game hasn't started yet, so it's kind of over. And we want to check if game is over is true, if this is truthy. And in that case, we want to set the screen variable to the game over screen JSX element, to this component. Of course, for this, we first of all need to add some logic in the game over screen JS file. So here I'll add a game over screen component by exporting this here as a default. And then here for the moment, I'll just output some text where I say game is over. And of course, we're going to tweak this component later. For the moment, I'm just going to import this text from React Native like this. And then in the game screen, in the app component, we now can render game over screen. We just also need to import it, of course. We need to import the game over screen from screens game over screen. And now we need to change this game over state whenever the game is over. And for this, we should add a function here in this app component, the game over handler function, for example. And there I want to set game is over to true. And this function should now be passed to the game screen component here, so that from inside that game screen component, from inside that useEffect call, we can trigger this function. Now to achieve this, I will actually define this function before I render this JSX code here. And then we can add a prop to the game screen component, like on game over, for example, where we point at the game over handler, like this. Now inside the game screen, we can use this on game over prop. So here in game screen, we now don't just get the user number, we also get the onGameOver prop, which holds a pointer to this function. And then there, in useEffect, if we know that the game is over because the guess is equal to the number we chose, we can simply execute onGameOver, this function which we receive here. And that will therefore trigger this GameOverHandler function in the app component. So that's that. Now we need to add some dependencies to this useEffect hook to control when this effect function should be executed. And here, the simple rule is that all the variables, all the values that you use in this function should be added as dependencies. So therefore here, our dependencies are the current guess, of course, but also the user number and the onGameOver function. So now with that, whenever the current guess or the entered number or this onGameOver function changes, this effect will be re-executed and we will check if the game is over, in which case onGameOver will be called. So therefore now with that, if we save everything and we force a reload, I start on this game is over screen. And I start on this screen because this is set to true, and yeah, of course, I show this screen if the game is over. What we want to do is we want to check if a number has been chosen and the game is over. So if the game has been played or if it just hasn't started. If it just hasn't started, we don't want to show this screen, so we will check if the game is over and if user number is truthy. So if a user number has been chosen, which will not be the case initially. So now with this, we start on that starting screen again. And now we instantly go to this screen if I start the game though. This, however, makes sense because as soon as we set a user number, we have game is over, which is true, and we have a user number, which is truthy, and therefore we show the game over screen. To avoid this, we must make sure that we also set game is over to false once we start a game. So here, when we pick a number, we also want to set game is over to false to indicate that the game started now and that it's therefore not over. This is important. And these two state updates will be batched together by React so that the component is not re-rendered twice, but only once. That's just a side note, and that's just React specific, has nothing to do with React Native, but is nice to know. So now finally with that, we should be able to enter a number. Now the game is starting, and now we can try to guess this number or let the phone guess this number. And we still get this maximum call stack size exceeded error as soon as we reach the final number. So let's see why this is happening now. This error is occurring because of this code here in the game screen component, where we generate our initial guess. What's important to understand about this code snippet is that this function will be executed whenever the game screen component is executed. So whenever it is re-evaluated, which will be the case whenever a new guess is set. So therefore, we generate a new random number whenever that happens, and we take our current min and max boundaries into account here. The problem with that just is that if we do it like this, we execute this function even at the point of time where min boundary and max boundary are the same because we derived our final result. Now we don't do this in the next guess handler because this handler can't be executed anymore as soon as we have the final result because the buttons won't be shown anymore because we move to that game over screen. But the problem is that this component function is re-rendered one time where the current guess is equal to the user number. Now useEffect runs after this re-render cycle. Hence, we only trigger this function that moves to the game over screen after this component has been executed once. Now, this is early enough to avoid that the user is able to press these buttons again, because the latest buttons won't have rendered yet. The buttons with the updated state won't have rendered yet, but this function here, this will execute before useEffect is evaluated, so before we can move on to the game over state. The workaround is to hard code our default min and max values here. Because we only need this once anyways. We only need this initially anyways, and thereafter we don't care about this. An alternative solution could be to use the use memo hook provided by React to avoid that this gets executed again. This might be a great alternative, but this is a quick and simple workaround that also does the trick. And with that changed, if we now reload, we are able to play this game again, but now you will notice that we move to the game over screen as soon as we reach that number, 31 in this case. So now we got rid of this problem by hard coding these values. And it's really important to understand that we had this problem because useEffect technically runs after the component function has been executed. And therefore this executed with the equal min and max boundaries at a point of time where it shouldn't have executed again. Now this works, and now we can come back to styling and work on this game over screen, but also, of course, optimize all these other screens. And as always, definitely feel free to do this on your own, come up with your own layout and your own styling, and then see what I will do in the next lectures. So let's now finalize these screens. And for this, I want to start on that start game screen again. I want to improve this screen a little bit, and I, for example, want to add my title above this input area. And for that, if we go to the start game screen, we have to actually add another view because at the moment, everything on this screen is only this input area. This entire view here is this entire input area container. So I will add another view on this screen in the start game screen component here. And then in there, above this container that holds the text input and so on, I want to add my title component that I created before, which is imported from components UI title. And in that title component, we could say something like guess my number because that is the title of the game, let's say. With that, we got this title here, but of course this is not looking good. Having this sit on the top edge is not looking good at all. To change this positioning, I will add another property here in my style sheet and name it screen container or root container. Maybe that is a fitting name. And here I want to set up flex 1 so that whatever receives this style takes up as much space as possible. And here I also want to add margin top 100 and actually reduce margin top in the input container now to, let's say, 36. And then we can add this root container style to this view here. So we add the style prop and point at styles root container. With that, this looks nicer, but I also don't want that title to stretch from left to right. Now, there certainly would be different ways of fixing this, but the way I will choose here is that on that root container, I simply change align items, which aligns items across the cross axis, which in this case is left to right, from stretch, which is the default, which leads to this title being stretched, to center. And with that, it's not stretched anymore, but instead centered like this. So that's an enhancement, I would say. What I also want to change is that I want to have a little instruction here inside of that input container box. A little instruction that tells me that I should enter a number that then has to be guessed. So for this, above this text input, we can add a text, a regular text, which we of course have to import from React Native like this. And in this text here, we can then say enter a number like this. Now, of course, this is totally not readable, so we need to add some styling here. And for the styling, I will add another style property here, the instruction text property maybe. And we can give the text a color of colors dot, let's try primary 500, though that might be too dark. And let's increase the font size to 24. With that, we can now add this to this text by adding the style prop and pointing at styles.instruction text. And with this done, we now got this instruction. And I think it's not too easy to read. So as a workaround, we could add a lighter shade. But I think the better workaround is to make this yellow, since the number input field also has yellow text and so on. And therefore, I'll actually switch this from primary 500 to accent 500 to this yellow color, which we stored. And with this, yep, that doesn't look too bad. Now you could add more, you could add an image to this screen, enhance it in any way you want, but I think this looks okay, this is decent. I therefore now want to continue on this screen, where we actually play the game. And on this screen, of course, the buttons currently aren't that good looking. I'm also not entirely happy with that number container, so I will work on this as well, but I will start with the buttons. I want to group those buttons and the instruction text that belongs to them in a box as we have it here on that start game screen. And actually, I like the style of that box, so I would like to use exactly the same box. Now, since I plan on using exactly the same box as I have it here on the start game screen, it makes sense to create a dedicated component that renders this box. So in the components UI folder, I'll add a card.js file, because this kind of component that provides such a container with this kind of look is typically called a card. So therefore here we have our card function, and we export this as a default here. And then we grab the card related code from start game screen. And for this, I'm not going to grab all that code, because of course the specific content that we have in this box on the start game screen should stay in that screen. That's not what we want to outsource into a generic component. It's just a background, just a container itself. And therefore, it's actually this view here, which I'll grab and return in here, also with a closing tag. And then in the card component, I expect to get my children prop, and I output this between the opening and closing view tags. And that means that I can now use my card component as a wrapper around any kind of content to wrap this view with this style around that content. Of course, for this to work, we also need to bring over the style though, and therefore I'll import the style sheet from React Native and create this styles constant here with style sheet create, like this here. And then in the start game screen here, we can grab this input container style property, which is responsible for styling this container, this card container, and cut that from start game screen and add it into this card.js file into the style sheet instead. And I'll rename it to card, because this is now really the kind of style we are applying here. With that, we can now use this card component in the start game screen, and there we can import card from components UI card, like that. And now we just need to replace this view, which is wrapped around our text input elements, with card. And of course, also replace the closing element that belongs to that view. And we can now also use this on the game screen to wrap this around our buttons there. Here, I want to replace this view with card, also replace the closing view, and of course make sure that card is being imported from the components UI card file. I also now want to use my instruction text that I defined here on start game screen, this text with that styling, on the game screen for this higher or lower text. And therefore, for the same reason, we can create a component, the instruction text component, or however you want to name it. The name, of course, is totally up to you. But this also is a default React component, like this. And in here, we want to return this text here, which we have in the start game screen, where we say enter a number. And for this, we then, of course, want to import text from React Native and expect to get that children prop here as well, so that we get this actual content that should be rendered between the text tags from the place where this instruction text component will be used. And then again, we want to bring over the styles, because that's the primary reason for creating this reusable component, so that we have the styles defined once in one place, and we can then use it in different parts of the application. And we therefore create such a styles object here with style sheet create, like this. And then we go back to start game screen. We grab the instruction text styling here and cut that, and bring that over here into the style sheet so that this works there. And of course, this should not be content, but children here. So now with that, we can use this instruction text component here in the start game screen component instead of the regular text component. We now use the instruction text also for the closing tag. And we get rid of this style assignment. We don't have that style in this file anymore, and we don't need it. And of course, you should add this instruction text import. And on the other hand, we can get rid of the text component import, because we're not using the raw text component in this file anymore. And now in the game screen, we can also use this. We can replace this text component with the instruction text, like that, and make sure that we import this component, and we can also get rid of the text component import here. With all those changes made, let's see if this works. It looks like we have an error. Can't find variable colors. Okay, so in the card component, I'm referring to this colors constant, and I'm doing the same thing here in the instruction text. And in both component files, I'm missing the colors import. So of course, we should import this from constants colors and add this line of import to both the card.js as well as the instruction text.js files. With that, we're missing the variable view in card, and that makes sense. I'm rendering a view, so of course we have to import this. Now this should render successfully. It crashed on Android as it seems, so let me restart it there. And now we still have this box here, but we also have it on this game screen now. There, it's now just the positioning of the buttons which I want to change, and then I got a couple of other things I'd like to change as well. So let's now continue on this game screen with these buttons here. Here in the game screen, we already have this card as a container. And then we have this view which holds these two buttons. And I'd like to position these buttons next to each other. For this, we need to convert this view from flex direction column, which is the default, to flex direction row. And therefore, that's what I'll do. I'll add a buttons container here. And as a side note, we have a similar container on the start game screen. And yes, we could outsource this into a separate reusable component as well. Here, I'll not do it because it's just one line of code, one line of styling anyways, this line here, but you could absolutely create a reusable component for this button row as well if you wanted to. You could even create a reusable component that holds these two buttons if you wanted to do that. That would absolutely be possible. Here, I will not do that though. To keep things a bit simpler, I will just add this view. And again, wrap these individual buttons into views for the same reasons as before on the start game screen. And then I can copy over the button and buttons container style, these two style objects, and add them here. And then I'll add these styles to these views. So this outer view receives the buttons container, and this inner view receives the button container, like this. And also this button. With that done, if we save this, this looks better, just some spacing would maybe be nice, and to achieve that, I actually want to add some spacing below the instruction text, or above this buttons container row. Now we could easily add it to this buttons container row, but I'll add it to the instruction text so that I can also show you another key concept and technique that you will likely use quite a bit when working with React Native. Keep in mind that we're not using CSS, so we have no cascading styles, we have no inheritance. But we can kind of replicate a similar behavior. What if we want to add some extra styles to this instruction text that should be applied in addition to the styles applied already inside of the instruction text component? Well, we can use props. In the instruction text component, besides getting the children, we could expect a style prop. Though the name is up to you and doesn't have to be style, but I will use style since that is the prop we used on all these other components all the time for styling. So now we get this style prop here on instruction text. And we can now merge the styles we get from this style prop with the styles we set up inside of this component, which allows us to kind of build such a cascading structure because we can now pass styles from a parent component into this component and merge it with the component-specific styles. Now this can easily be achieved by wrapping our styles into an array here. Because the style prop does not just take style objects, it also takes an array of style objects. If you do pass an array, by the way, the items are parsed and evaluated from left to right, so the right items and the styles defined in the right items can override the styles defined in the earlier items. So here I add the style that's coming in through props, and I add it as a last item so that we could override styles that are defined in this default style set here. So that we could override these default styles from outside and, for example, assign a bigger font size if we wanted to. So now we accept this style prop, we add it to this array, and we add it such that the default styles could be overwritten. But we can of course now also add new styles besides overriding default styles by simply going to the place where this component is used, in this case the game screen, and adding this new style prop as a prop to instruction text. And then here I'll add a new style object, the instruction text object, for example. Name is up to you. And I'll add a margin to the bottom of 12. So I'm not overriding any styles, I'm just setting an additional margin to the bottom. And now we can add this here, like that. But this is an important technique which allows you to rebuild this cascading nature of CSS in React Native by simply passing this style prop into a component and then merging the incoming styles with the existing styles, possibly as we're doing it here, such that you could override the default styles. Though of course you could also add style in front of the default styles if you want to ensure that the default styles override the incoming styles, if there are any clashes. This is up to you and depends on the exact use case you have. Here I will add it such that we could override the default styles. And with this, we now have this margin to the bottom and a bit more spacing between this text and the buttons. So now we're making good progress here. We worked on these buttons, but I'm not done yet. There are two main things I want to change before we move on to the game over screen. And the first thing which I'd like to change is the icons in the buttons. At the moment we have regular characters in there, a minus and a plus, and I would like to use proper icons which are a bit prettier. In addition, I also want to use custom fonts so that I'm not stuck with these default device fonts, which are okay, but which I don't want to use here, but that I instead can use my own custom fonts, because of course that is also a typical requirement that you want to bring your own fonts. Now let's start with the icons though. Thankfully, when working with Expo, adding icons is super simple because Expo and Expo created projects already come with a library, a package, that allows us to use icons. We just have to add an import here at the top, and we import something from @expo vector icons. Now this should be available automatically out of the box without you installing anything, because it is a peer dependency of Expo. And from this package, you can import various icon sets. Now, if you search for Expo vector icons, you should find the official icons documentation. And there you can learn more about this library and that it is installed by default if you created your project with Expo in it, and how you can use it and which kind of icon sets you can use. You can learn more here. Now, one icon set that's built in, which I like a lot, are the Ionicons. Actually, there are more icon sets available, which provide different kinds of icons, but Ionicons is one of them, which I like a lot. Now, on the official docs about Expo vector icons, you can find a list of the built-in icons. And for example, there, if you search for minus, you find various minuses belonging to different icon sets, which are included with Expo vector icons. And you do, for example, also find the Ionicons minus in there. For this, I'll add a little filter here to filter only for Ionicons, and actually search for remove. And then here you find various icons, and I will use this MD remove icon, which is this minus. But you can, of course, use any icon you want. This name is important because you use these icons by grabbing this icon set, which is imported from Expo vector icons. And then in the place where you want to use an icon, you render this as a component, as a self-closing component, which gets a name prop. And now the name is that icon you want to use. And we even get auto-completion here, and we, for example, get help and learn that MD remove is indeed a valid icon we can use here. Now you can, in addition, also add a size prop, which sets the size in pixels, and here I'll set this to 24 to have a nice big icon. And you can set the color, and here I'll set this to white, but you could also add a hex code or anything like this. And with that, now we have this nice minus here. And we can do the same thing for the plus. We replace the plus character with Ionicons. And now instead of MD remove, it's indeed MD add. Same size, same color. And with that added, we now also have this plus here. And I'm using the same icons on both platforms. You could even use different icons on different platforms, but we will learn more about platform-specific code in the next course section. So now with the icons added, let's talk about fonts, because we also sometimes want to use custom fonts. And again, thankfully, Expo makes this pretty easy. For this, we can go to the app component because we want to set up our own fonts in the root component of the app so that they are loaded right when the app starts. Because custom fonts have to be loaded, and we want to do this early on when the app starts, typically. Now, custom fonts can be loaded with help of an extra package. This extra package must be installed, and we can do this with Expo install. And the package name is expo-font. With that, this package gets installed into our project. I still have the npm start process running in a different tab, but I'm also installing this package. And once this is installed, in the app component, we can import something from Expo font. And that something is a hook, a React hook exposed by this package, the useFonts hook. This hook can be called and must be called in an app component, in this case in our root app component, to load these fonts. UseFonts is executed, and to UseFonts, you pass an object with instructions about which fonts should be loaded. Now, if you dive into the official Expo fonts documentation, you'll learn how you could easily include fonts from Google, because including Google Fonts is made extra simple with help of a special Expo Google Fonts package. That might be worth a closer look as well. Here I want to show you how to include any kind of fonts where you might just have your local font files, And therefore in the assets folder, I'll add a fonts subfolder. And attached to this lecture, you find two font files which you should download and add to this fonts folder. The OpenSense Bold TTF file and the OpenSense Regular TTF file. These two files are attached and you should download them and add them to the fonts folder in the assets folder. Now once you added them, they can be loaded with help of useFonts. For this, in this useFonts object, you must set up property names that will later be used for identifying the fonts you loaded, and values for these property names that point to these files that should be loaded. So for example, this font is called OpenSense, so I'll use open-sense as a property name, between quotes, since this name includes a dash and it would be an invalid JavaScript property otherwise. And then to load the font and assign it to this identifier, we use this require function, which we already know from images. And here, just as for images, we construct the path to this font that should be loaded. In this case, it's OpenSense Regular TTF. And make sure you introduce no typo here, because otherwise loading that font will of course fail. Now we also have the bold version, and for this I'll load OpenSense Bold here and point at OpenSense Bold TTF like that. This will load these fonts. Now what you should typically do is that whilst these fonts are loaded, you want to show a loading screen, or you want to show the splash screen of the app, which is the app loading screen, until the fonts have been initialized. And to do this, we can install another package with Expo install, and that would be the expo-app-loading package. This gives us a utility component which we can render, which will prolong the splash screen and will ensure that the splash screen is still shown until some condition is met. So now with this package installed, we can import app loading from Expo app loading. And we want to show this as long as we're loading fonts. Now to find out if we are still loading, useFonts thankfully returns an array where the first element, which we can extract with array destructuring as we did it for useState, where the first element is actually a Boolean that indicates whether the fonts have been loaded yet or not. So we can now use this Boolean to render our app loading component, which will then show the splash screen until the fonts have been loaded. So here I'll check if not fonts loaded, so if we are still loading, and in that case I will return app loading like this. So in that case I will show the splash screen, and once the fonts have been loaded, the component will be re-executed, and then we will not show the splash screen anymore. But now with that we can use our custom fonts, because that is of course the main reason for loading them. And it's up to you where you want to use them, but I in the end want to use my fonts in different places of the app. For example, I want to use my fonts here in the title and instruction text and number container elements. And therefore in title.js, to use my custom font, we can, by the way, remove the colors import here since we don't need it anymore. But here, to use the custom font, all we have to do is go to our style object and add the font family property as we would do it in CSS. And now we can use these identifiers that we assigned in the app component. So in my case, OpenSense or OpenSense Bold. And here I want to use OpenSense Bold since I want to have some bold text. We can now remove the font weight here because this font which we load is already bold. Now in the instruction text, I want to use just OpenSense, so there I'll add font family OpenSense like this. And in the number container, I want to use the bold font again. So here for number text, again, we can comment out the font weight, but I'll add a font family of open-sense-bold, or whatever you chose as your font identifiers. With that, if we reload the entire apps, the font is now a different one, as you can tell, because we're now using this custom font that is getting imported. The difference might not be huge, but it is a different font which we have here. So that's how you can add custom fonts to a React Native app. So we worked on this start game screen. We worked on this game screen, and of course, as mentioned before, you can definitely fine-tune this to your likings. Now I want to work on this game over screen because, of course, this screen is not that pretty right now. Now for this, let's switch to the game over screen. What do we want to do on this screen? Well, I think it makes sense to show a game over title, maybe a nice image, and then below that image also a short summary of the game. How many turns it took the computer, the phone, to guess our number and what our number actually was. I think that could make a lot of sense. And for this, to achieve this, I will start by replacing this text here in the game over screen with a view, with a general container, which we of course have to import. Because as you learned by now, that is very often the first thing you do, since the view is this generic container component that contains all your other elements that make up a screen or a more complex component. Now in here, I then want to have my title, and I will reuse this existing title component, which I import from Components UI title. But of course, you could also build a different title specifically for this page if you wanted to. I will reuse this existing title and say game over. And then below this title, I'd like to have an image. An image which I then also want to style. For this, we can use this image component, which we need to import from React Native, as you learned. And then for the image, I prepared an image for you. Now we already got the assets images folder, and therefore you should simply download and drag and drop that image into this images folder. It's this success PNG file. So now that's the image which I'd like to display here. And for this, we can add a source here, as we always did, and require this from the assets folder like this. And then there from images, it's success.png. That's the image I want to add. Now on this image, I then want to add some styling, but for the moment, let's just save this and take a look at that. So now we get the title and we get the image, and the image is way too big, as you can tell. And it's way too big on purpose because, as mentioned, I want to show you how you can resize and style the image. And for example, I also want to create a round image, so a circle, and we can achieve this with style properties, which we'll dive into next. So for that, I will import style sheet into this game over screen component and create the styles object as we did it many times before. Style sheet create, and then create a style for our image. And now when it comes to creating an image with rounded corners, what works best is that you create a view around your image, and then on that view you add rounded corners and you add overflow hidden, as we also did it earlier for our custom button. If you remember this, there we also worked with this kind of approach, having a container with border radius and overflow hidden. We'll do something similar for this image now. And therefore here I'll add the image container style, where I add a border radius of, let's say, 200, and a width of 400 and a height of 400. And the border radius should be half your width or height, and width and height should be the same amount so that we create a square. And then by setting border radius to half our width or height, we actually create a circle. That is how we can create such a circle image. And I will also add a border width of 3 here to add a little border around that image. And the border color then can be any color you want. I will use my colors constant, which is therefore imported from constants colors. And on this colors constant, I want to choose a dark shade of my primary color, like primary 800, which goes into the black color, but isn't black, but still has some plum color elements to it. Now, very important, as mentioned, we also want to add overflow hidden to make sure that we hide the square or the rectangular nature of the actual image, and we use this container as an overlay, as a mask for this image, you could say. And I will also add a vertical margin, or actually a margin in all directions here on that image. And here, let's say we want to add a margin of, let's say 36 pixels, and we can of course tweak this later. Now this style will be applied to this view, which is the container for this image. So hence I add it like this. The image itself will now also receive some styling, and for this I'll create an image style property, and all I do here is set the width to 100% and the height to 100%. And that 100% will refer to the container, to the view in which the image is placed. That's how percentage values always work in React Native. They refer to the container of the element on which you set up those percentage values. So in this case, I will add this style, this styles.image style, to the image, and therefore the percentage width and height on that image will refer to the width and height of the view that holds the image, and that of course will be 400 each. With that applied, if we save this, now we got this circular image here. Now it's a little bit too big, and in the next course section, we're going to learn how we can adapt this dynamically to the available device size. For the moment, I'll fine-tune it manually and decrease this to 300 pixels height and width, and hence the border radius to 150, so that it's still half the width. With this looks better, I'd say. Now, in addition, I also want to have some general distance to the top and some padding around the title and so on. And therefore, it makes sense to wrap this overall thing here into a view, which we already did, which receives some styling as well. And for this, I'm going to add my good old screen or root container styling property, my styling object to be precise, and add flex1 so that we take all the available space. Then I'll add some padding, let's say 24 pixels. And I want to center the entire content in the middle, both horizontally and vertically. And this can be achieved by using justify content center and align items center. This will center it on both axes, and therefore it will be centered horizontally and vertically. And now this root container style just needs to be applied to this view, which wraps this entire content like this. With that, we got this look, and this doesn't look too bad, I'd say. Now, this is not everything I want to do though. Instead, as I said, below the image, I want to output a short summary of the game. And for this, we can go back to the JSX code. And then below this image container, we can add another view, simply to group together some text elements, though we might actually not need that. So let's just start with a text right away, now that I think about this. And for this, of course, text should be imported here from React Native. And then in this text, I want to say your phone needed X rounds to guess the number Y. And of course, X and Y are placeholders for the actual values. Now we'll derive the values in a second, but what I want to do is I want to highlight X and Y. And React Native makes that very easy as well. Now to highlight X and Y, we can wrap X and Y in extra text elements, in extra text components. And this is something we haven't done up to this point in this course, but it is something that is absolutely fine and which you can do with React Native. A text component actually can't hold too many other kinds of components. For example, a text component should not really wrap a view. But a text component can contain other text components. So having a text component besides the plain text in another text component is allowed and is absolutely something you can do. And what this allows us to do is add different styling to this text than to the rest of this text. So therefore here, I'll add another text wrapper around the Y. And then we can prepare some styles for this text in general and then for the X and Y texts. Now let's start with the text in general. For this, I'll add the summary text styling property. And here I just want to set the font family to Open Sans. That's basically all I want to do. But then I also want to add a highlight styling object here, where I set the font family to Open Sans bold, so that we have some bold text, and where the color is set to colors primary 500, so that we assign a color to that text. And now we can use these styling objects to style the text and the texts inside the text. The wrapping text receives the style prop to assume the style's summary text styling, and the inner texts that wrap X and Y receive style equals styles.highlight. Both these texts receive that. And we could again create a reusable component for that, but here this is also pretty reusable since we assign the same reusable style to these two text components. With that, we now got this summary text below this image. Now, when I look at it, I'm not totally happy with that. To make this a bit prettier, I actually want to increase the text size. So on the summary text, I'll ramp up the font size to 24. And now this is bigger. And please note that the text that's nested into another text element also is resized. This is not inheritance at work, but instead this is related to how this is compiled to a native component internally. If we have a view that contains a text and we add a font size to the view, it would not affect any nested text elements in the view. Nested text elements inside of other text elements, however, are affected by the text-specific styles you do set on the parent text component though. So when we set a font size on the outer text, the nested texts are also affected. That in the end works as you would expect it to work, I guess, and it's definitely worth noting that it works like this. So now we have this styling. Centering the text would also be nice though, so I will also add text align center here for the summary text, so that this is centered like this. Now last but not least, below all of that, I'd like to have a button that allows us to start a new game. So below this text, I'll add the primary button, which therefore of course must be imported from components UI primary button. And then on this primary button, I'll say start new game. And we will later add the onPress prop to trigger some function that does start a new game. When we save this, we have this button here as well. And now maybe some spacing would be nice. So on that summary text, we can actually add a margin vertical, so margin top and bottom of 24 maybe. With that, there is some spacing between the button and the text. And actually, maybe we just want margin to the bottom. Now that I look at it, yeah, I think that looks nicer. So now we have that. We have this game over screen finished, at least regarding the styling and the layout. But what's missing is, of course, that data, how many rounds we took and what the number was. And this button is not working. So that will be the next steps we will work on. So let's work on outputting the actual number of rounds, the actual number that had to be guessed, and on starting a new game. Now here in the game over screen component, in this screen here, it's probably fair to assume that all that data should be passed into this component from outside. So from the app component, since that is the component that is rendering the game over screen. So therefore here in game over screen, I just expect some props. And I use object destructuring here to pull these props out of the incoming object immediately. And the props I want here are the rounds number, the user number that was set up, and on restart or on start new game prop, which should hold a pointer at a function that will reset all these game metrics so that a new game is started. So therefore now here for X, we can output the rounds number like that. For Y, we can output the user number like this. And on the primary button here, we add the onPress prop and point at onStartNewGame. With that, this component is finished, but of course we at the moment get no data for these props. We have to change this in app component. So on the game over screen, we want to provide the user number, we want to provide the rounds number, and we want to provide the onStartNewGame prop. Now, user number is pretty easy because we're managing this as a state in the app component, so we just want to pass the user number into this component. Now, the rounds number is not available right now though, but that is something we can change. Here in app.js, we can manage an extra piece of state, which is the guessRounds state, maybe the setGuessRounds state updating function. And we do this with the useState, and initially we have 0 rounds because the game hasn't started yet. So now we could pass guessRounds to rounds number, but of course we will also need to make sure that guessRounds actually changes at some point. We'll take care about that in a second. Now regarding onStartNewGame, we need a function that can be executed here in the app component. A function which I'll name StartNewGameHandler. This sounds like a fitting name. And then here, I will point at this function, or to be precise, I will pass a pointer to this StartNewGameHandler function to the onStartNewGame prop, so that this function here gets executed when that new game button is clicked. Now in this function, we in the end want to reset some data. We want to reset the state we're managing here in the app component. When we start a new game, I want to set the user number back to null because a new number must be picked. I want to set game is over to true because it is over, though we already set this to true here, so we don't need to set it again actually. But I also do want to set my guess rounds back to 0 because a new game will start and therefore the phone hasn't guessed any numbers yet. So that's what I want to do here. And by setting user number back to null, for example, we ensure that this if check won't become active anymore because user number, if it's null again, is not truthy anymore. So we will automatically leave the game over screen and go back to the start game screen just by setting user number to null, because both these if conditions won't be met anymore. So that's already pretty good. Now what we also need to do when a new game is started though, is in the game screen, once a new game starts, we will need to reset the min and max boundary. Now I'm managing these values as regular variables outside of the component function because they actually should be independent from the component function. When the component function is re-executed, those variables shouldn't be reset back to their initial values all the time. That's why I manage them outside of the component function. But I do want to reset them if a new game started. To achieve this, we can again use useEffect in the game screen component. There, I have an effect which I want to execute whenever this game screen component is rendered for the first time. So whenever it was not part of the rendered user interface and now became part of the interface. And this can be achieved by adding an empty array of dependencies to useEffect. Then this effect function will only execute the first time this component is evaluated, and then if it is removed from the UI and re-added later, this will execute again. But it will not execute if this component was already on the UI and now just updated because, for example, a new guess was made. So therefore this effect function is now perfect for resetting min boundary to 1 and max boundary to 100, because with that we should ensure that this actually only happens when this is rendered for the first time again. Alternatively, we could also do this here when we trigger on game over, because we know if the game is over, we want to reset the min and max boundary for the next time the game is played. That should work as well, but here I'll try solving this with this separate effect function. So now we have all of that. Let's now save this and let's start a new game. Now if I solve this and I start a new game again, I'm back here on this starting screen and I can pick a new number, and then here I can still play the game as I did before, and it again ends. So this looks good. I can also see my number here on this game over screen, but of course the rounds number is currently not updated. And that's therefore the next thing we want to implement. And we also should not forget that the goal also is to output a log of the played rounds here on this game screen. So that's also something we'll have to do. So let's now work on logging the number of rounds and on creating this log that we can output on this game screen. For this, we should add a new piece of state to the game screen, because these rounds are also just some state which we can log. So here I'll add my guess rounds and set guess rounds and initialize a new state, which initially should hold an array. It will be an array because, of course, we have multiple rounds and we want to log the number that was guessed for every round. So therefore also the initial value, the initial first and only element we want to have in this array is the initial guess. That should be part of this array initially. And now we can update this whenever we guess a new number. So in the next guess handler, besides setting the current guess to the new random number, we also want to update the set guess rounds state, or the guess rounds state, with the set guess rounds updating function, and update this to include this new random number into this existing array. Now, since we will update state based on a previous version of that state, we should use the function form of updating this state by passing a function to the state updating function. And here we get our previous guess rounds, so the previous state snapshot, and we return the new array, which is basically all our old array elements, which we can re-add into this new array with the spread operator, plus this new round number, this new random number that was guessed in this round. Now we can add this new random number at the end of this array or at the beginning, which is what I will do, so that when I do output the log, I can simply loop through these items and the latest guess will always be on top. This is not a must do, but something I want to do here for displaying this log. So now we update these guess rounds and we can now output them here. So therefore here we want to output all these rounds. We want to output this log information. We can do this by creating a view and then mapping our array elements into a list of other elements that will be output on the screen. So for this here we can use our guess rounds and simply map through them. And then we get our guess round, and for each round we want to output some text, let's say. For this, of course, you must make sure that text is being imported from React Native, otherwise this won't work. And then here at the bottom we output this text and we output this guess round. Now if we try this, we get an error here. We get an error because we should have a unique key for every element, as you learned. And indeed, here we should add a key, and the key can be the guess round because we know that it will be unique because what's actually in this guess rounds array are our guessed numbers. And since we can never guess the same number again due to how our logic is written here, it's a perfect unique key because we know that every number will only occur once in here. So therefore now if we save this and we reload, we can start a new game, maybe on Android to mix things up. And here 14 is the first number guessed. We see it here. And then you see this is being logged, but actually this is not looking right if we take a look at that. What's the problem here? The problem is that I added a tiny mistake here. It should be the new random number that's added as a new element to this array. So I mistyped and added the entire array again, which doesn't make any sense. It should be the new random number instead. So if we save this and reload and try this again, now this is looking better, and now we see that the correct numbers are being logged here at the bottom. So this is working, and this would be one way of solving this. But of course, you learned before that outputting lists like this works and can be okay, but if a list could get very long, then you might want to use flat list instead. Now, arguably, this list won't get very long because it will very likely not take much more than maybe 8, 9, or 10 guesses at most to derive the right number. And outputting that amount of items with this approach would be absolutely fine. Still, to learn it in the best possible way, we can use flatlist here instead of mapping a list manually. But I want to emphasize that in this situation, where we have a limited amount of list items, it wouldn't be horrible to do it like this. Still, to move to flatlist, we can import flatlist from React Native and use that instead to output all these items. And of course, feel free to implement this on your own first, because you learned how flatlist works. And in the next lecture, we're going to implement it together. And there, we're then also going to create nicely styled list items together. But definitely feel free to do all these things on your own first as a practice before we then do them together. So, did you succeed? Let's build this flat list together. For this here, we render a flat list, and you learned that you need to provide the data prop, which points at the array that holds the data that should be output. And in this case, that's our guess rounds state snapshot. That's the array of data which we want to output. Now then we need to provide render item, which receives a function that is responsible for rendering the individual items. So a function that will be called by flatlist for every item in our data array. Now here we can provide an arrow function, and we want to render, let's say, a text element for every item in this guess rounds array. And you did learn that you automatically receive the item data here as an argument, automatically passed in by React Native, by flatlist. And therefore, between those text tags, we can then output item data.item dot value, if this would be an object with a value property, but in this case, the item itself is already a number, so we just output that item, that number. Now you also learned that the key that uniquely identifies every item is also needed when working with flatlist. But you don't add the key by adding a key prop. Instead, flatlist will add it for you. It will look for a key property on your data objects, but since our data are no objects, but instead primitive numbers, it won't find that. Hence, we can add this key extractor prop where we tell flatlist how to derive a fitting key. And for that, here, we provide a function as well, which will also be executed by flatlist. And in here, we get our item, and we know that in this case, the item itself is a perfect key because the item itself is a number which is guaranteed to be unique for every guess rounds element. So we have a unique key here, and we just tell flatlist to basically use our data itself as a key, since every data item will be unique. Okay, so now with that, we have a flat list. And if we save this and we give this a try, this also is looking quite good, and we now render these items here. As a next step, we of course want to improve the styling of these items, because at the moment they are, well, ugly, to be honest. Now for styling these items here, we can create a new component, maybe in the game folder, in the components folder, and that could be the guessLogItem.js file, which holds the guessLogItem component. So we export this as a default guessLogItem. And then in here, it's up to you how you want to style this, but I want to make sure that for every log item, I show the number of the round, and I also show the actual value that was guessed in that guessing round. Hence, I want to add a view here, which must be imported from React Native, as you learned. So we import this from React Native. And I will also import text here, because inside that view, I want to have a text where I say hashtag and then round number, let's say. And round number should be a prop which we receive. And then another text where I output the opponent's guess, which I also expect to guess as a prop, and therefore that's the guess prop, like this. So now these are the two pieces of information which I want to output in this guessLogItem, and I want to render one instance of this component for every round that's being played. So for every item that's being output in the flat list. Now, of course, we want to style this. So I'll import the style sheet from React Native and then create my styles here with style sheet create, like this. And then here we can give this a name of list item and apply any styles of your choice. In my case, I want to style the border by adding a border color here. And for that, I'll choose my colors constant, which is imported from that constants folder. And I want to use a dark primary shade. The border should also receive a width of, let's say, 1 pixel and a border radius of, let's say, 40 pixels to have some nice rounded corners. I also want to have some padding of, let's say, 12 pixels so that we have some spacing inside of that container. And a margin vertical of 8 so that between the log items, which are basically displayed on top of each other, we have some spacing, some vertical distance between the log items. There also should be a nice background color on every log item, and I'll also get that from my colors constant and use the, let's say, the accent 500 color, so this yellow color. I also want to make sure that these two text items sit next to each other in a row, and therefore the flex direction must be changed to a row, as you learned. Justify content can then be spaced between, so that they are pushed to the edges of this container. So the first item is on the left, the second item is on the right, and the empty space in between is left empty. And I want to add a width of 100% to make sure that the log items take the full width that is made available by the parent component, which is the flat list. Last but not least, we can add a little shadow. And for Android, this can be done with the elevation property, as you learned. And we could set this to a value of 4. And for iOS, we do this by adding a shadow color, which could be black. And then a shadow offset, which is an object with a width and a height, as you learned. And the width can be 0, the height can be 0. And then a shadow opacity of 0.25. And a shadow radius, let's say, of 3. And you can play around with these values to find a shadow that you like visually. Now with that, the styles have to be applied. So on that view, I add styles.listItem. And I also want to make sure that I use the right font for the text in there. And therefore, I'll add my item text styling property where I set the font family to Open Sans. And then this item text styling property here can be added as a style to both these text elements, these text components like this. Now we have the log item. Now we can use it in the game screen. Here, instead of outputting this boring text here, I want to output my guessLogItem, this newly added component. which therefore, of course, must be imported from that file in which we created it. And then here, we have to configure it. We have to pass in the round number, and we have to pass in the guess that was made. Now, the round number can be retrieved from item data, because on this item data object, besides the item itself, we also get the index of the item in the array. And in the end, this index gives us an idea about the round. The index itself is not the round number, but we know that we just need to take the overall length of the list, so the number of items of the list, minus the index to get the round number. We need to do this kind of calculation because the latest round is added at the beginning. So the latest round will always have an index of 0. So if we take the overall length of the list and we then deduct the index of the individual items, we get the round in which this item was added to the overall list. Now, to get this list item length, we can add a regular constant anywhere in this component function before the JSX code is returned. And here we get the guess rounds list length by simply using guessRounds.length. So this is recalculated every time the component is re-evaluated, which will happen whenever a new round is added. And then we can use this to deduct itemData.index from it. And the guess itself, of course, is itemData.item. So the number value itself. This is how we can deduct the round number and then the value for the round itself, the number that was guessed. If we give this a try, you can see this is how it looks, and this looks quite good. And you see, now in the second round, the guess was 5, which is correct. And this gets added, and we still get that warning if we give a wrong hint, until we actually found the right number. And this is scrollable so that we can even view all the rounds if we exceed the available space we have on the screen. So we can still see that. And eventually, of course, we can then end the game and start a new one if we want to. By the way, we will also update this number soon. So this generally works. But if you paid close attention, you might have seen that, well, let me try again, reproduce this so that we produce a list that's long enough. You might see that actually here, once we exceed this space, yeah, we can scroll to see the bottommost value, but actually it's not really scrolling into view. We have a hard time really seeing that last guess. Now, to fix this scrolling issue with the flat list, where the content leaves our screen boundaries, a good solution is to wrap a container around the flat list, which we already do with this view, and to then add some styling to that container that kind of controls how much space this flat list can take up. Because by default, a flat list works such that it basically has an infinite height. Now, if we restrict that height, though, through a parent container that we add around it, then the flat list will become scrollable inside of that container. But with that, we can avoid that it goes beyond the boundaries of our device. So we could then add a, let's say, list container style object to the game screen and add flex1 on that. And add a comma here, to make sure that this container takes up as much space as possible. I'll also add a little bit of padding around it of 16 here. And then this list container style property is assigned to this view here, like this. Once we do that, you will see that if we start a new round and we keep on guessing here and we hopefully don't guess the number too early, now I can still scroll here, but now I can scroll all the items into view and they don't go outside of my screen, which of course is better than what we had before. So now this also works. As a last step, we can now count the number of rounds so that we can also show it here on the game over screen. Now, counting the number of rounds to show it on the game over screen is actually not too tricky. In the game screen, we are already logging all our rounds, and in the end, the length of that list is basically the number of rounds it took the phone, the device, to guess our number. So therefore, all we have to do is count the number of items in guess rounds once the game is finished, and then report that to the app component, because the app component in the end needs that number to pass it down to the game over screen, because there we need to pass in our rounds number. Now for this we already have the guess rounds state here in the app component, which here is not an array but a single number, and we want to update this number as soon as the game is over. For this we got this game over handler already, which is called by the game screen when the game is over. And we now just need to make sure that we report the number of rounds here, that we get this as a parameter value, so that in this function we can set guess rounds equal to this number of rounds. And now we just need to make sure that this parameter is passed into game over handler, so into the on game over prop from inside game screen. So in game screen, where we do call this on game over function, here we want to pass the guess rounds length as an argument, because that's the number of items in this guess rounds array, and that is the number of rounds it took the device to guess our number. We're passing this into the function which we receive through that on game over prop, and that turns out to be that game over handler function. With that, if we save this and we start a new game, if I enter a number here and I then keep on guessing, the game is over and I now see 6 rounds here. So this works, and let's actually also test this on Android now and guess here. So we have 3 rounds, 4 rounds, 5 rounds, 6 rounds, 7 rounds, 8 rounds, and this is reported here as well. So this works, and last but not least, to also quickly show that, if I play this again up to the point where we have a scrollable list, this scrolling also works here on Android. So that is all working, and with that, the overall game is working as intended. Now, that is it for this game. You can absolutely fine-tune this game a bit more if you want to. You can change the styling, the layout, and you absolutely should play around with those fundamentals. Because in this section, you learned a lot about these fundamentals. You practiced a lot, you practiced all these things you learned earlier in the course, and you worked a lot with all those built-in core components, with styling, and you learned how you can build your own components based on these core components, how you can build general UI components as well as app-specific components. You learned how you can switch between multiple screens, here simply with help of state and if statements. Later, we will also learn a different approach, but this approach is perfect for simple apps like this one here. You learned in general how you can use these core React features like state or use effect in React Native apps. And you learned how you can implement such a game with React Native. Now, we did have a look at a lot of special cases. You learned some tips and tricks regarding styling and laying things out, and for example, building custom buttons. And that's what I mean. I can only encourage you to build up on that and practice all these things in your own demo apps, dive into the official docs, and get comfortable working with those core components and with styling those components. Now, the final app we built here could definitely be improved even more. You could extract more components, you could build more reusable components, you could maybe use this style cascading effect, which we used here with the instruction text, where we merge an incoming style with a built-in default style. You could definitely use all these things in different parts of this game. I did not optimize all that code in the best possible way because I, A, wanted to keep related concepts and styles together to a certain extent, And B, this already is a huge section and we want to move on and learn more exciting features React Native has to offer. For example, in the next course section, we're going to build up on this game and we're going to make sure that it adapts to different screen sizes and platforms, that we render slightly different styles or layouts on different platforms, that we can, for example, rotate the device and then also use this in landscape mode instead of just portrait mode, and a couple of other interesting things. That's what we will explore next, but for the moment, that's it for this section. This course section will build up on the previous course section. Now, in that previous section, we learned a lot about building real React Native apps, how we can build nice layouts and styles, and combine multiple components, custom components, and built-in components to build real mobile apps with React Native. In this course section, we're going to learn how we can make our mobile apps and our mobile user interfaces more adaptive and responsive. How we can build apps that adapt to different platforms and different device sizes, and how we can, for example, write platform-specific code, which means that we generally have one code base for both iOS and Android, of course, but that in some cases we can differentiate between those platforms and execute slightly different code based on which platform we're running. In addition, we're going to learn how we can adjust to different device sizes and, for example, update our styling or our layout based on the available width and height. And we're going to learn how we can also react to the screen orientation chosen by the user. In general, the idea behind this course section is to teach you a broad variety of tools that you have to adjust your interface as needed, and to teach you how you can build adaptive components which live in one and the same code base and still can adapt to different environments. Now, for this course section, I want to build up on the app we built in the previous course section, and therefore you find the code of that finished app which we built in the previous section attached to this lecture so that we can all start with the same code base. Now, here is the app running on iOS and Android, and I would say the look and the layout is quite good. There isn't anything obvious that I would want to change. But, of course, not all our users are going to use one of the latest iPhones or Android devices. Instead, they might be using older or smaller devices, and our app typically should be able to adjust to that. And we want to adjust our look and feel. For example, here I also started an Android emulator based on the Nexus 5 image, and I'll close the more recent Pixel 3 device emulator. Now, this is a fine Android device, but as you can clearly tell, it is a bit smaller. If I resize this, it just gets bigger here on the screen, but if we talk about available pixels, it is smaller, it has less space available, and if that would be a real device, the screen would be smaller. We can tell that everything is smaller because everything is bigger here on the UI. And the starting screen still looks alright, but if we dive into the game, we notice some differences. For example, the title is right at the top here. It's really at the edge of this screen because this device is smaller. Now, if we play this game here until it's over, then we see that also on this game over screen, yeah, it fits on one screen, but the title is really already a little bit below the status bar. And everything probably is a little bit too big for this small of a device. So therefore, we might want to adjust some of our style settings, some of our layout styles, such that the app looks a bit better on smaller devices. And that's what we're going to start with in this section. So how can we make everything a bit smaller? Let's maybe start with this game screen. This game screen is okay, But some things are a little bit too big. For example, besides the position of that title, which in my opinion is a little bit too far at the top, we might want to decrease the width of this a little bit. And if we have a look at our GameScreen.js file, there we have various styles, but of course for this title, we don't have any specific styles because that is a custom component stored in the Components UI folder. And if we go there, we see that in the end, we have no real settings regarding the width that should be taken up by this title. Instead, we basically take all the width we can get, and the only spacing around this title therefore is margin or padding applied to this title or to the container holding this title. And that might be fine, but what we could do here is we could give this a max width of, let's say, 80%. And that then should be a string, so we should wrap it between quotes. If we do this, then this title gets a bit smaller. It's also not centered anymore because the parent container, which uses Flexbox, because all views use Flexbox in React Native, doesn't center its child items. So we would have to go to the game screen and then in there, go to this view, this screen view, and make sure that all the children in there are centered by adding align items center here like this. And now that is all centered again. Now it is up to you whether you like this or not, but what I want to show you and emphasize is that you can use relative units like this, and we have used them before, to control widths and heights, and that you can not just set the width and height itself, but that you can also set max width or min width besides the regular width to create more responsive sizes. Because when you set the width, then it's always that width. It's now always 80%. With max width, it's up to 80%, but it could be less if less space is needed. We could, for example, also set a width of, let's say, 300 pixels, which would be the default, but we could then also add max width 80% to make sure that 300 pixels is taken unless that would be more than 80% of the parent container, in which case the 80% become active. So with this on bigger screens, we can take a little bit more space. As you can tell by the available space to the left and the right of the text, there is less space available here on the smaller screen. On the bigger screen, this gap is wider. But we only take the 300 pixels, which we seem to take here, if there is enough space. Here on the smaller screen, 300 pixels would be more than 80% of the available width, and therefore the 80% are taken instead, since that is our max width, and therefore the upper boundary of the width of this container. And what's really important to note is that percentage settings like this always refer to the parent container that holds an element. So if I set the title to a max width of 80%, those 80% refer to the parent container that holds the title. So in this case, to this view, because of this title, this view is the parent container. So it's the width of this view of which 80% are taken by the title because of this setting. So percentage units and min and max width combined with the regular width can be very helpful. And of course, it's not just about the width, you also have min and max height in case you have similar scenarios where you want to set a minimum or maximum height. So these extra style properties are properties you should be aware of. So min and max width and min and max height are useful. But sometimes you have problems that can't be solved with these properties alone. And for this, let's get back here. This overall UI on a small screen is okay, but everything is a little bit too big. We might want to choose a smaller font size. We might want to choose less margin between this number container and this input box. We might want to make everything a little bit smaller because we know that we're on a smaller device. Now, how can we do that? There might be different ways of achieving this, but a great way of solving this is to use the built-in Dimensions API. Now for that, I'll go to this number container as an example, and there I want to reduce the padding and the margin if we're on a smaller screen, and I want to reduce that font size if we're on a smaller screen. And for this we can use this Dimensions API. And we use this Dimensions API by importing it from React Native, because it is an API built into React Native, but it's not a component we would use in our JSX code. Instead, it's a JavaScript object which we can use anywhere in our JavaScript code, including our styles, to get information out of it. Now, which kind of information can we get out of the Dimensions API? Well, for example, we can get the device width or height. So here we could get the device width by using dimensions, and then there is a get method which you can call. And the get method takes an argument which is a string which holds either a value of screen or window. On iOS there is no difference. On Android, screen is the entire available width and height including the status bar. Window is excluding the status bar. So the actual part of the screen where the UI should be painted and usable. So I will use window here to get that available device size. And then on this object, which we get from this get method, we can access various properties. We can access font scale to find out which kind of scaling a user wants in the app, and you could then take this into account and multiply your font sizes by that factor. But here, I'm interested in height and width. And we can, for example, get the width here and then use that in our styles. But how can we use it? Well, for one, you could use it in mathematical calculations and say that the padding should be something like device width divided by 10. But what's probably more useful here is that you can use it in if conditions or ternary expressions. We could say if the device width here is, let's say, smaller than 450 pixels, then we want to use a padding of, let's say, 12, and we want to use 24 if it's bigger than that. So on smaller screens, we take a padding of 12 pixels. On bigger screens, we take 24. If we save that, you see the padding is reduced now. It's now less here. But it looks like here I actually chose the wrong breakpoint, because now on both devices, including the iPhone, we have very little padding. But if we find a better breakpoint, like 380 in my case here, then I have less padding on the left device and more padding on the right. We can also use this for the margin, of course. So here we could then use the same formula or a different condition with different values for the margin, so that also the margin around this number container is affected by that. Now this gap here is not just the margin we set here, therefore it's still pretty big, but we'll work on this gap soon as well. So that could be a useful tool for controlling some sizes. And you could, for example, now also use it here for the font size and stick to 36 on bigger devices, but reduce this to 28 on slightly smaller devices, so that the font is a little bit smaller compared to the device size than it is on bigger devices. Now, this is absolutely something you can play around with, and you can adjust to your requirements and what you want, but you should be aware of this Dimensions API, which can help with finding out which available space you have to then adjust certain settings based on it. And it's up to you whether you adjust based on some if statement as we do it here, or if you have some dynamic calculation where the width or height is used as part of a formula. Now what I'll do here is I also want to reduce this gap here a little bit, as I mentioned, and therefore what we can do is go back to the game screen. And there it's the gap between the card and the number container. And here it's that margin to the top on the card, which I want to change. And therefore in this card component, we can also include the dimensions API and then get our device width just as we did before with dimensions get window and then the width. And then we can use this here for the margin top and check if this is smaller than 380, in which case the margin top maybe should just be 18 pixels and otherwise it's 36 pixels. So now on smaller devices, there's less margin to the top. And with that, we indeed did reduce this gap a little bit on the smaller device, and we still have the bigger gap on the bigger device. Now, again, play around with that, find your favorite settings, and maybe adjust other components as well if you want to. I just wanted to introduce you to that Dimensions API because it can be a useful tool for situations like this here. Now, as a next step, I want to solve this game and come back to this game over screen, because here things are also a bit too big. And it's mostly this image which is too big. The rest could be adjusted as well, but the image is definitely too big. Now, with our newly gained knowledge about the Dimensions API, we can improve this as well. In the game over screen component, we get this image, and this image has the styles image style object. So this one here. And there we set the width and height to 100%, which, as you learned, refers to the container. And the container around the image is this view with that image container style applied to it. If we have a look at this image container style, we see that the width and height is hard-coded to 300 pixels. And hard-coding values like this is very often not a good idea because you don't know on which device size your app will run in the end. So again, we can solve this with the Dimensions API. And the Dimensions API might be better than using an alternative like percentage values, which are also relative, because we want to ensure that width and height do have the same value so that we create a square with rounded corners to ultimately create that circle. If I would say that width and height should maybe be 50%, then you could think that you also get a relative size relative to the available width and height. But the problem is that these values are now not the same. Yes, they are both 50%, but 50% of different values. The width of the container will not be the same as the height. So 50% of the available width will be a different number than 50% of the available height. And therefore, percentage values are not helpful here. Instead, this is a great scenario for the Dimensions API because we want to have a hard-coded value, but the hard-coded value should be different for different device sizes. So therefore here, again, we can import the Dimensions API from React Native. And then, as many times before, we can get the device width. And by the way, you could of course also get the device height if that would be more important than the available width for you. The Dimensions API gives you both width and height, and it's up to you what you want to use. But here I'll get the available width. And then here, I want to actually, again, check if we're smaller than 380 pixels. In which case I only want to use 150 pixels as a width for this image, and 300 pixels only if we are on a bigger screen. And now we use the same formula that uses the device width for the height, because I want to use a height of 150 if we're on a small device that has a width less than 380 pixels available, and 300 pixels as a height for the image in other cases. The border radius should also be adjusted because the border radius should be half the image width and height. And therefore here we have the same check, but then we use 75 for the small screen case and 150 for the big screen case. And now with that, this image is much smaller and this screen looks much better on smaller devices. On bigger devices, we have a bigger image which also looks good there. So again, that's the Dimensions API in action, and as you see, it can be a very useful API. And also keep in mind, it's not limited to just the width, even though I just used the width here. you could also use it for working with the height. So that was the Dimensions API. Very useful, as you can tell. Now there's one thing we can't do with it and with our app at the moment though. And that is rotate our screen. I mean, we can rotate it. Here I'm using a shortcut, but you can also do this here with the menu on iOS and rotate your device. And on Android, you can use these buttons to rotate it. But as you can tell, the screen doesn't adjust to that. It doesn't flip. The reason for that is that this app here by default has the orientation locked to portrait. You can set this in app.json, which is a config file picked up by Expo, and this locks the orientation of the app to a certain aspect, in this case to portrait. Now, this is maybe what you want, and to be honest, for this kind of app, for this game, it would probably make sense to lock it to that orientation. But of course, you could also be building apps where this is not locked in place, and you can also unlock it with Expo by setting this to default instead of portrait. As a side note, you can also set it to landscape to lock it to that mode, but here I'll go to default. Now it's not locked anymore, and if we now flip this, it still doesn't adjust because typically you need to restart your app for this to have an effect. Here I pressed R in the terminal to force a reload, and thereafter it's now flipping on iOS. On Android, it might still not be adjusting. For me it is, but it might not be adjusting. In that case, open this menu here and make sure that auto rotate is on. And once this is on, you should be able to flip this screen on Android as well. Now, what you can see is that if you do change the orientation, the app might get broken. Here on Android, we can barely use it still, but it doesn't look good. And here on iOS, it looks better, but still not perfect. There's too much space to the top now. And if we open that keyboard on iOS, and by default it's not open because you can type with the keyboard, with your regular keyboard into the simulator. But if you do force that keyboard by going to IO keyboard, and then you use that, you toggle that software keyboard, then you see that that keyboard actually overlaps the input, and you can't actually close it by tapping anywhere else. So now the app is not usable anymore here. I can only close it here in the simulator by using this toggle shortcut again, but of course the real users of your app won't have that. So therefore this is not working this well in different orientations, as you can tell, and that is what we will work on next to improve this app for different orientations. Now what can we do about different orientations and this app looking better? Well, for one, we can again use the Dimensions API, and we could, for example, take a look at the available height to base this margin to the top here on that available height, so that we don't have as much of a margin to the top if we have less height available on our device here. Now for this, we can go to the Start Game screen, where we have this margin to the top here on this view with the root container style. There we have this hard-coded value. And as you learned with the image on the Game Over screen, hard-coded values aren't that great. And therefore in Start Game screen, we can of course import the Dimensions API from React Native, and then use that to change that margin to the top. So now we could get the device height here instead of the device width by using dimensions get window and now the height. And then here we could again check if the device height is maybe, let's say, smaller than 400. And in that case, we want to set a margin to the top of 30 and otherwise 100. And you will have to play around with that value to find out what looks good and what works well. But if we save this, now we have less margin to the top if we are in landscape mode on both iOS and Android. And we could go for 380, since that was our width before. If we rotate the device, that is our height breakpoint that sets these two devices apart, to still have the bigger margin here on iOS and the smaller margin on Android. Now, it is totally up to you how much margin you want to have, but this would be one way of doing it. But even with that solution, it's still not perfect. What if a user changes the orientation whilst he or she is using this app? If we switch back to portrait, now we have that smaller margin still. And the same, of course, on iOS. It just left my screen for a second. And the same would be true for iOS if you would switch back, but there, of course, thanks to this breakpoint, the margin was bigger anyways. But you can see it on Android. If we have that smaller margin because we start in landscape mode, then we keep it even if we rotate back. Because that is important. This code here, where we get the device height and so on, is only executed once when this component code, this entire file code, is parsed and executed for the first time. So if we adjust the screen orientation after starting this game, this code down here will not get executed again. Yes, the component file, this file will execute again from time to time, for example, when our state changes, but the code outside of this component function will not be executed again. So therefore, if it's possible to switch the orientation whilst using this game or this app in general, then you might not want to use the Dimensions API like this. You could, but you then might be locking in values that you don't really want thereafter. What you should do instead is you should write this in a more responsive way, which adjusts to changing device orientations. And thankfully, this is also very simple and easy to do with React Native. Instead of locking in the device height here, and instead of setting the margin top here, what you should do is move that code into your component function. So any code that should react to device orientation or size changes should go into the component function, because this function, unlike the overall file code, will get executed multiple times. Now, React Native gives you an alternative way of accessing the Dimensions API, which allows you to then react to device size or dimension changes inside of component functions. React Native gives you a hook, the use window dimensions hook, which you can use. Now, like all React hooks, you have to use it inside of a component function or inside another hook. And you then simply call this to get back an object on which you can use object destructuring to get the width and height of the device. So now here we get width and height, but internally, this hook will watch the device dimensions, and whenever they change, for example, because the device gets rotated, this component function will get executed again, and we will get an updated width and height. And that means that now we can derive our margin top dynamically inside of this component function based on this dynamic height or width, and then use this in our JSX code. So maybe here, right before returning JSX, we could get our margin top by simply using height, and then the same logic as before, where we have this check here to then set a margin top of 30 or 100. But we now do this here, in our component function right before we return JSX code. And now we just need to make sure that this value gets applied. So here I'll name it margin top distance, but this name is up to you. So that means that we now want to merge this dynamic style into our style sheet object that we're setting here on the view. And thankfully, as you learned before, merging styles is simple. You could, for example, turn this into an array, and then add another style object like this, where you set margin top equal to the margin top distance that is derived here. And since this component function will now re-execute whenever the dimensions change, this will adjust whenever the device orientation changes. So now with that, If we save that and we force a reload on all devices, here we start with a lot of margin to the top. But if I rotate this, you see, it gets less margin to the top. It's less margin to the top now. But if I rotate back, it's more margin again, because of this dynamic usage of the Dimensions API. Now, you don't always have to use it like this, but it makes sense to use this hook instead of the other way of using the Dimensions API if you need dynamic dimensions. If you are fine with locking in certain values initially, then you don't need that. But if you do want to adjust dynamically to changing sizes, you should use this hook instead of the other way of using it, which we saw before. Now, I will not adjust the other components here, simply to save some time for now, but feel free to experiment with that hook here to see which other parts of this app could be adjusted to different device orientations. Here I'll keep it like this, but again, definitely feel free to experiment and find different areas where you could optimize that. Now, for the rest of this section, we will work ourselves through the different screens and make sure that they look good on different sizes and orientations. But for the moment, I want to stay on this starting screen here. And here we have a problem with the keyboard. Now, on Android, we might get that full-size overlay keyboard, which we can close ourselves, which looks and works okay. But on iOS, we have a problem. There, if I toggle this built-in keyboard, which our actual app users would be getting, we see that we can't close it. There is no button here, and tapping on the background doesn't do anything. And I also can't get to the input anymore, so I basically broke the app now. And that, of course, is totally unacceptable. The solution for this problem is thankfully built into React Native, though. We can use a specific component that helps us with that, the keyboard avoiding view, which in the start game screen can be imported from React Native. This is a component which you can use in your JSX code to wrap other content with it, other content that involves or contains an input field. And whenever the keyboard then opens up that content that holds your input element and other elements, can be moved up so that you can still access it even though the keyboard is open. For this, all you have to do is wrap this view here in start game screen with this keyboard avoiding view. You wrap this around your view here. The view with root container now is wrapped by the keyboard avoiding view. Now, since this will now be our root view, the topmost view in this component, this would break our style. If we save this, everything would be broken. The reason for that is that we no longer get as much space as we can, but we need to get as much space as we can on this root element for the rest of the elements to get their appropriate slices and to look good. Now we can add the style prop here to add a style that makes sure that we take all the available space. And for this, I already added a new style object in the style sheet, which I named screen, which sets flex to 1. That's all I do here. And this screen style object can now be added to this keyboard avoiding view with styles screen like this. With that, it looks better again. Now, if you tap in there, nothing changes though. It still is not accessible, because you can now also configure the keyboard avoiding view. You can add a behavior which either wants height, padding, or position as a value. Now, I do recommend that you play around with those values to see the differences. Very often, in my experience, position works best. Now, if we save that, however, we notice that everything is broken again, because what position will do is it will try to move this, as you can see if you tap in there, that is working now, out of the way so that we can still see it whilst typing. But for this to move effectively, this needs to be in a scrollable container which it at the moment isn't. Therefore, to make position work great in this case here, we should wrap the keyboard avoiding view with a scroll view, because we learned before that we can use a scroll view to add scrolling. We don't want flat list here because we don't have a dynamic list with possibly an infinite amount of items. Instead, we have a clearly defined user interface which should be scrollable in case we run out of space. Therefore, we simply wrap scroll view around the keyboard avoiding view like this. And on the scroll view, we should also add the style again and set this to styles screen to make sure that the scroll view occupies all the space it can get, because screen sets flex to 1, so that we still get all the space we can get here, and then all our other styles can style themselves and lay themselves out based on that available space. Now with that scroll view wrapped around keyboard avoiding view, if you save this looks good again, and now you see this moves up as I start typing. And I can scroll this to reach the different parts of this UI. Here on Android we don't really see this, but that's okay, because we just needed it here on iOS. Now with that, we can also tap somewhere else to close this keyboard. That's a nice side effect of keyboard avoiding view. If you now tap this card here, the keyboard closes. Now if I tap here, it does not really close, at least not always, but we do have this main area covered, and therefore we now of course allow our users to always reach all these buttons, and they can also close the keyboard. So that's the keyboard avoiding view in action, which is another super important component exposed by React Native, has nothing to do with Expo as you see, but instead it's built into React Native, and it can help a lot with building accessible and usable user input areas. Now let's continue with improving this app. If we move on to the next screen here on Android, we notice a new problem. In landscape mode, there isn't enough space available. Even here on iOS, it's not really that great. It would be usable there, but it doesn't look good. And on Android, on this device here to be precise, it's not really usable in landscape mode. Sure, we can always switch back, and that should theoretically work. It does work here on iOS. And it should be a problem with the simulator here on Android, because theoretically we should be able to switch here as well. But either way, the problem is that it should also work well in landscape mode, and that is not happening at the moment. So how could we improve this? There are certainly many ways of improving this, but I want to dive in one specific way. I want to totally change this UI, or at least parts of this UI, when we are in landscape mode, or when we have more width but less height available. And we can achieve this pretty easily with the Dimensions API, but now we're using it for a brand new concept, to dynamically adjust the layout structure and the component structure. For this here, in the game screen, that is our UI as we display it when everything is normal, so in portrait mode. Now what I want to do is I want to change this. I want to render a different UI in landscape mode. For that we can use the Dimensions API, and I want to use it such that we can listen to changes in the dimensions inside our component function. So therefore I want to use this hook, the use window dimensions hook. And then as you learned, we can use that in our component function in the game screen. We can call use window dimensions, and then we can get our width and height. And you don't need to always get both. You can of course just get the one value you might be interested in. Here I'm just getting both to show you that both properties exist on this object returned by use window dimensions. Now I just want to find out if we have plenty of width available, in which case I want to display a layout that is optimized for more width. So therefore, maybe down here, right before we return JSX, I in the end want to create a variable. Content could be the name, and that content should be the JSX code that should be rendered by default. So that could be this number container with the card below it. Like this. Therefore, I'll cut this from here and then add this between those fragment tags here. Like that. I use these fragment tags since I have two root components next to each other. Card and number container are root sibling components, and this would not be allowed without such a fragment tag. Now that is my default layout, and therefore I'll inject this content variable here below the title above the view. With that alone, nothing changes, of course. We got the same look and feel as before. But now I do want to change the layout if we have more width available. And for this we could add a if statement here and check if width is maybe greater than, let's say, 500 or 600. You can play around with that. If we have that much width available, then we are likely in landscape mode. But even if we're not, then I want to display my UI differently. Then my content, which will be output down there, is not this number container with the card next to it. Instead, I then want to have my number container, but to the left and right of that, I want to have my buttons, and above the number container, I want to have this higher or lower text. So actually here, I will also add the fragment tags, but now above the number container, I will have the instruction text here. So copy this down there. And then left and right of the number container, I want to have my buttons. Therefore, I will wrap this in a view overall. And in that view, I then add these two buttons here. So I copy the views that wrap the buttons like this. But now one button is in front of the number container, one button comes thereafter. If we save that, now the layout changed, as you can tell. It's not looking the way I want because I haven't added all the styles yet, but you see the card is gone, and instead one button is here, and the other button comes after the number container, as you can see here on my iOS simulator. Now, of course, the styling is not the styling I want, therefore I'll add a new style here to this wide screen content. And set this to buttons container wide maybe. The name is up to you. Here I'll choose buttons container wide and add this down here. And then here for buttons container wide, I want to set flex direction to row. The default is column, so here I'll override it to row and set align items to center so that everything is centered vertically. If we save this, I now have this user interface, which I personally find much better. However, you can see here on iOS that still the log is pretty cut off and hard to use. So therefore, we might not even want that higher or lower text here and simply get rid of that. Because you don't need to have the same elements, you can render two totally different user interfaces or layouts with different content based on the width, as we're doing it here. So now this is gone, and now the log is a bit more accessible and easier to see. We might also want to reduce the spacing around this container and the spacing above the log. And therefore, on this list container that holds the log, we could, for example, adjust the padding so that there's less padding around the log, or at least reduce the padding to top and bottom. Alternatively, in the number container, we could of course tweak the margin so that there is less space around the number container that will be reserved. Feel free to do that. Here, we now at least got a basic style that we can use to play this game. It might still be optimal in portrait mode, but now it is at least playable in landscape mode as well, thanks to adjusting this dynamically. And with this, we're left with this game over screen, which doesn't really work in landscape mode, as you can tell here. Now, definitely feel free to find a way of fixing this on your own. In the next lecture, we will fix this together. So let's now work on this game over screen. At the moment, it doesn't look that good here, and I think an easy way of improving the way it looks is to shrink the image a bit more and make it scrollable so that we can always reach this new game button even if it would be outside of the screen. And at the moment that is not possible. Now actually in the game over screen we are already setting the image width and height, but at the moment we're only changing it based on the width, and we probably also want to take the height into account. We also want to make sure that if the device orientation changes, we adjust the image size. Now, to do this, we can use this other form of the Dimensions API. We can use the Use Window Dimensions hook instead. So now instead of setting the width, height, and border radius down there, we now want to do this dynamically in the component function to react to changes in these values. We therefore, of course, also want to get rid of that code. And here I'm just commenting it out so that we can still see it. So now inside of the game over screen, we can, of course, use this hook to get the width and the height of this screen, of this size, like this. And now we can use this width and height to adjust the image size. For this, we can set an image size of 300 as a default. And then we can add an if statement to calculate various alternatives. For example, if the width is smaller than 380, which was the check we had before, then we might want to use an image size of 150. And I'll use the image size for both the width and height later, and also for calculating the radius. But we also know that if the height is maybe smaller than 380 or smaller than 400, let's say, then we also want to make this smaller. Then we might want to set the image size to just 80. And then we got a certain image style here, which in the end sets a width which is equal to the image size, and a height which is equal to the image size, and which sets a border radius, which is image size divided by 2. And now it's this image style that should be merged with the other image styles dynamically on that container, though, because it was that container on which we set width, height, and border radius before. Now we don't want to override it because we're still setting some other styles in there, but we want to merge in our new styles. So therefore, again, we can wrap this into an array and then simply add our image style object to that array so that these styles will also be taken into account. With this, the image is smaller, but if we rotate, it gets bigger again. So this works the way it should here. Now, in addition, as mentioned, we might want to make this all scrollable, even though it's not needed here, but it could be needed on some devices. And therefore, we can also include the scroll view here and import that and add this as a wrapper around this entire screen in the end. So we wrap the root view with this scroll view, and now we just want to make sure that we set flex 1 on this scroll view here again. So we add style and set this equal to styles.screen maybe again, which we have yet to add. And then we add a new style object here, the screen object, as we did it before, where we set flex 1, like this. With that, this now also is scrollable, even though it's not needed here, but we could scroll if we would need it. And with that, we also fixed that game over screen, and now we should be able to use all these screens here and play this game on different screen sizes, even though it might still be best on portrait, but it now also works on different screen sizes. Now that was a lot about screen sizes and orientations and adjusting to changes in those sizes and orientations. And as mentioned before, Definitely play around with those different tools to learn more about how they work and to optimize the UI for your personal preferences. What I want to do here is I now want to move away from adjusting to sizes and instead adjust to platforms, because that is also quite interesting. Now for this, I'm back here on Android and iOS, portrait mode, but now let's say there are certain elements that should look different on the two platforms. To be honest here, I like the style, I like the similar style for both platforms, and it is one of the advantages React Native offers that we can write one code base and target multiple platforms. But sometimes you want slightly different styles for different platforms, and React Native also gives you tools for this case. Now for that, let's say that in here we wanted to change this title based on the platform we're running on. On Android, we might want to keep it like this, but maybe on iOS, we want to get rid of the border. How can we do that? Well, we go to the title, and now we want to adjust the styles based on the underlying platform. For this, React Native gives us another API we can use, the Platform API. The Platform API allows us to detect on which platform we're running. Now we don't need to set up a dynamic listener here because the platform is not going to change whilst the app is running, unlike the dimensions. Instead, it is always the same for the entire lifetime of this app, so we can use this Platform API anywhere and we don't need to react to any changes. And if we would want to get rid of the border, we could say here for border width, instead of always setting this to 2, we use the Platform API. And then on that Platform API, we can access OS, this OS property, which is actually a string that's equal to Android, iOS, or since you theoretically could also build desktop apps or web apps with React Native, macOS, Windows, and web. But we will focus on Android and iOS in this course. And if I only want to set a border width on Android, then I check if this is equal to Android, and then I set a border width of 2, otherwise of 0. With that, you see the border is gone on iOS, but it's still there on Android. And that's how easy it is to use that Platform API. But when it comes to working with the Platform API, there also are other ways of using it. You can use it in a ternary expression like this, and there's nothing wrong with it. This is short and easy to read. But there also is an alternative way of using it. You can use the Platform API object here and use the built-in select method. Now select wants an object as a parameter value, and in this object you should specify an iOS property and an Android property. And then you can set different values that will eventually be returned by select for these different platforms. So here I could then set 0 for iOS and 2 for Android. So that's simply a different way of writing such a conditional statement. In a place where you want a value that should be different for iOS or Android, you can use platform select to define the iOS and the Android values, and then select will return the appropriate value in its place based on the platform on which this code is executed. So with that, we achieve the same result as before, but this is maybe a bit more readable, or it's simply an alternative that you should also know. Now, another alternative, which I also want to show you, which can be very useful when writing platform-specific code, is to write platform-specific files. Now, up to this point, we always added component files like this, which had a component name and ended with .js, and that's the default. But you can actually also write platform-specific component files, or code files in general. For example, if I want to write an Android-specific title component version, I can copy this and name this file title.android.js. And then I could name the other component title.ios.js. Now, you don't need to adjust your imports. in the places where title gets used, you should make sure that you don't have .ios or .android at the end. And since my IDE added the .ios extension automatically here, I removed it. And you want to make sure you remove that on all the screens where the title is used, because you still import as if the file would just be named title.js, and under the hood React Native will pick the proper file based on the platform on which you're running. And so now we could go to title.android and get rid of the platform API usage here, and just set border width to 2 here, because we know that this file with these style settings will only be executed for Android. And on the other hand, on title iOS.js, we can also get rid of that code and always set border width to 0, or simply get rid of all the border settings altogether since we want no border. Now, it might be overkill here for the title, where this simple switch was actually enough to achieve the desired result, but it is a feature you must know. And therefore, here I'm showing this to you by building the same component twice in different files with different file endings with slightly different styles. And with that, if we reload everything, we still get the different styles as before, but now we achieve this with help of platform-specific files. And you're not limited to component files, you could also be importing from other files, like maybe different colors files, where one file defines the colors for Android and one file defines the colors for iOS. Then you would just add the different extensions here, and you would make sure that you always import from just colors, so you don't include the extension here in the import statements. And then React Native would pick the different files for the different platforms, and you could easily set up different color palettes with a trick like this. And actually, why don't we give this a quick try? If I add colors.android.js here, and then colors.ios.js, we have to make sure that in all the places where we import colors, we don't have .ios at the end. So we want to make sure that we search for all the imports and we never have colors.ios or colors.android here, but always just colors. That's really important. So we want to search all those imports and get rid of these extensions here, which is what I'm doing here, so that ultimately we can then set up different color palettes for the different platforms. So now with all those imports adjusted, we could say that for Android, maybe this primary color here should be green. And this accent color should maybe be this color here. Now that's probably ugly, but we can see that it's only used on Android and not on iOS. Now I will actually revert this because here I was happy with my colors on both platforms, and therefore here of course we don't need those different platform files. But it is worth noting that this feature exists, that it's not exclusive to components, and that you can use this feature to define different components, different styles, different colors, and different code in general for the different platforms. After exploring a lot of important React Native fundamentals, we're going to dive into another key topic. In this section, we are going to explore how we can improve the navigation between different screens. Now, of course, in the sections before, we already had multiple screens. When we built that game, we, for example, had a start game screen, a game screen, and this game over screen. But navigation between these screens was pretty rough. There was no animation and no way of going forward or backward, which for this game actually made a lot of sense. But in many apps, like the example apps we're going to build in this course section, you want smoother navigation and you want to be able to go forward and backward and so on. Therefore, in this course section, we are first going to explore what exactly navigation is, what that means, and then we're going to take a look at different navigation approaches and concepts like stack navigation, and you will learn what that is and how that works, but then also add drawers and adding tabs. And we're going to explore all of that by building multiple small dummy apps. So, what exactly is navigation in the context of a React Native app? Well, in the end, it just means that we can move between different screens as we did it in this little game we built before. But, as mentioned before, there we had no real way of going back from one screen to the previous screen, we had no animations, and we simply replaced one screen with another. And that could be fine, but in many apps, you want a more fine-grained navigation. For example, in one of the demo apps we're going to build in this course section, you will be able to go forward to a specific screen and then go back if you want to go to the previous screen. We're also going to explore how you could add tabs to switch between different screens and how you can combine different navigation patterns. And that's what I mean with navigation in native mobile apps and therefore also in React Native apps, since we use React Native to build native mobile apps in the end. Now, when we think about navigation in the web, in the browser, then of course we just enter a URL and we land on a page. And we can then use links to navigate to different subpages. On mobile apps, it's a bit different. There, we don't have such a URL. Instead, we navigate by tapping buttons and going from one screen to another, and then maybe back, and so on. And in this section, we're going to learn how we can implement such a navigation pattern, or to be precise, these different navigation patterns I talked about in React Native apps. Now, for that, I'm back in a brand new React Native app. You find this starting project attached, and it's a very simple starting project which we used before in the course already with just a dummy Hello World screen showing up on our emulators. But we're going to build up on that, and as a first demo app, we're going to build a meals app where users will be able to choose a category of meals they're interested in, and then they will be able to explore different meals that belong to that category and view the details about a specific meal. Now, the categories and meals data will be provided to you, but that is what we'll build, and as you can already see here in this finished app, which we are going to build, there we can navigate between those different screens, forward and backward. So that's what we'll build here. Now for that, we have this starting project here, this starting app. And as a first step, we need some dummy data so that we can, for example, show all these categories we want to be able to navigate to. For that, attached you find a dummy data.js file. And in your Expo project that you set up, you can create a data folder. And in that data folder, you can copy in that dummy data.js file. And this file gives you some dummy meals and category data that was set up. Now, in addition, you also find a models zip file attached, which you should also download and extract and also add into your Expo project folder next to that data folder. That models folder contains a category.js file and a meal.js file, and I'm just setting up some blueprints for the data objects that are created in that dummy data.js file. So we need all these three files organized as they are organized here with those file and folder names you see here. And with that, we got the dummy data, which we will use in this course section. So now with that, let's start using it and let's start building a screen on which we output all these categories for a start. And of course, feel free to do this on your own first as a practice. In the next lecture, we're going to do this together. So, were you successful? Let's build this screen on which we output these categories together. And for that, we don't need any special package or any navigation-specific tricks. Instead, what we can do is create a new folder that we could name screens, since I want to store my different components that will act as full screen components in there. And I'll add a categories screen.js file. The file name is up to you, but of course you want to describe what's in that file. And in that categories screen file, I want to create a function, categories screen, and of course export that because this is a component function, a React component function, as we created it many times before in this course. And then in there, we want to return some JSX code that outputs our categories. Now, to output the categories, we should import them. So I'm going to import them from this data folder, and there from the dummy data.js file. And from there, I'll import the categories. The constant that holds the categories has an all caps name. It's this constant. So I'm importing this into my categories screen.js file. And now we want to output all those categories. Now, there will be different ways of outputting the categories here. We could, for example, use a flat list to output all the categories. And you could do that if categories would be a list with a lot of items or a dynamic list where you don't know in advance how many items will be in there. And then for performance benefits, you want to use a flat list which renders elements lazily, as you learned. But here, actually, we wouldn't have to use a flat list because it's a limited amount of categories. And in this case, it's also some static data, which is not going to change. Nonetheless, I'm going to use a flat list so that we get more practice with that component. But I want to emphasize that here, for this limited list, it would not be required, and using a scroll view wrapped around the category items being mapped into JSX elements manually would be fine as well. Nonetheless, for the reasons mentioned, we can import flat list here from React Native, not React Native Web, but React Native. And then we can return our flat list here in the categories screen. And of course, now we need to set the data, and the data, that's our categories list. Because categories, as defined in dummy data, is an array. So that is what we want to expose as data. Now, if you take a look at these category items, you see that I'm creating them with help of one of my models, the category model. And if we take a look at that, you see that the first parameter received in the constructor is stored in an ID property. And besides that, the categories have a title and a color property. So therefore, we have an ID property for every category object and no key property as flatlist would expect it. Therefore, since we need a key, we should again set up the key extractor function as we did it many times before in this course. And you learned that this is a function that receives the item as a parameter automatically, and it should then return a value that can be used as a key for the individual items that are rendered by flatlist. So in this case, we can access item.id since we know that the ID will be unique for every item. Now, of course, we also should add a render item prop to define a function that is executed for every item that then determines how this item should be rendered. And for this, I'll add a little helper function, which is totally optional, not something you have to do. But here I'll add a helper function called a render category item. And I get my item here. And then here I want to return the JSX code for a single item. And I'm just doing this to keep the JSX code down there a bit leaner. That's the only reason you would not have to define a separate function like this. Please note though that it is defined outside of the component function since it doesn't have to be recreated when the component re-renders. At the moment the component should never re-render, but even if it would, this function doesn't have to be recreated and therefore it can be defined outside of the component function. So now we can point at render category item here. But of course, in render category item, we now have to set up the JSX code that should be output for a category. And for this, I'll add a brand new component in a components folder. This is also not required, but I want to keep my individual files lean. And then in that components folder, I'll add a category grid tile.js file. And I'm naming it grid tile because the categories will actually be rendered as a grid of categories. And therefore here I'll then create my category grid tile component function and of course export that category grid tile component function. And then in that component, simply return some JSX code. And now it's totally up to you how such a grid tile should be styled. I will use a view here. And for that, I'll import view from React Native. And in that view, I want to have a pressable component also imported from React Native because those grid tiles later should be pressable so that they lead us to a new page, a new screen. We don't have that screen yet, but we want it for later. So here I'll use pressable inside view, and I'm structuring it like this because of the styling which I'll apply, which then should lead to a good looking result. So then in there I'll have another view, again just for styling purposes, and in there I want to have some text, a text component, which also has to be imported from React Native. Text like this. Now inside that text, I want to output the category title. And therefore here, I expect to get some props in this component. And regarding the props that I do get, I expect to get a title prop and a color prop. I expect these two props because my dummy data, or in my dummy data, every category has a title and a color, as you can also see if you take a look at the category class here. So therefore, I expect these two props, and I want to output the title here. The color will then later be used for styling. So that's now the base structure for such a category grid tile. It's not finished yet, but we have this base structure. We'll add the styling later. For the moment, we can use this component here in the categories screen, in this component, in the render category item function. Here, I want to output the category grid tile component for every item we are rendering as part of that flat list. And then we have to set the title prop, which should be item.title, or actually, to be precise, this is an item data object, which will have an item property, and then we have the title on that item property, because render item gives us such an item data object, which has an item property. So that's how we should pass the title into the category grid tile. And I'll also pass in the color by simply accessing item data.item.color here. And now again, we won't have any styling, but we should be able to see some grid tiles on the screen, at least if we now display this categories screen component. And this can be done by going to app.js, and there, instead of outputting this view here, which I have here, I'm going to output my categories screen component, like this. And we can then remove the text and the view import from here. We can also get rid of these styles since we don't need them at the moment. With that, if we save this, we should see a list of categories on both devices. The styling and the layout is not the way we want, but we have these items here. And that is, of course, a great first start. Now let's work on the styling and on displaying these items in a grid before we then finally leave this little exercise practice part and dive into navigation. So let's work on styling and on displaying this in a grid. And of course, as always, you can build your own styling and own layout. But here, for a start, to display this in a grid, I want to make sure that my flat list actually displays two columns of items next to each other. And that is something we haven't done yet. We can easily force this behavior or add this behavior by adding a num columns prop to flat list and setting this to 2. The default is 1, so only one column and therefore a simple list, but we can set this to a number like 2 or 3 to actually render these items in columns. If you do that and you reload the app, you should actually have these items sit next to each other. Of course, this looks ugly since there is no styling attached to it, but it is a start. Now we can add some styling in the category grid tile component. There, I will set up the styling with a style sheet, and hence I import style sheet from React Native. And we can then add our styles object with style sheet create, as we did it many times before in this course. Now here, I then want to add various styles. I want to add a style to this outer view, but then also to this inner view later, and also to pressable. So therefore, I'll first of all add a, let's say, grid item style object, which I'll apply to this outer view. Of course, you can pick any name you want, as you learned. And here I'll set this to flex1 to make sure that this actually grabs all the space it can get. The space will still be restricted by flat list later, but inside the flat list, it should grab all the space it can get. Now, besides setting this to flex1, I'll add a margin of 16 pixels in all directions so that we have some spacing around every grid tile, so around every item in the flat list. And I'll set a fixed height of 150 for every grid item. Now feel free to use the Dimensions API, as you learned, to derive different settings for different device sizes and so on. I will not do this here, and I will keep the app locked to portrait here, simply to keep things simpler here and focus on navigation. But feel free to optimize the styling however you want. I'll also give every item a border radius of, let's say, 8 pixels here. And then I want to add a shadow on Android and add a little bit of elevation there for, let's say, level 4. Now this grid item can be added here to this view, and therefore I'll add the style prop and point at styles grid item. With that, we got this setup here. And as you can tell, it's definitely not perfect, but we have a grid of items now, which is scrollable thanks to flat list. We have some spacing around the items. The text is definitely not positioned correctly and it is quite ugly, but you can see that we now have some grid. Now to make it less ugly, we also want to style this inner container. And I'm differentiating between these containers so that we can apply proper styling once we make these items pressable later. So now for this inner view, I'll add a second style object here, the inner container, for example. That sounds like a fitting name. And here I also want to use flex1 so that we still take all the available space, which now is the available space inside this outer view though, because flex, when you set it to 1, takes all the space you can get, but only inside the parent container. So it's the parent container that sets the available space for the inner containers. So here with flex1, I take all the space I can get. And then I want to actually add a little bit of padding here, let's say of 16 pixels, so that we also have some inner spacing. And I want to center the text by using justify content center and align items center. With that, we can add this inner container to this view here with styles inner container and save this. However, if you now go back, you see that this does not give you the desired look. Instead, the text is gone now. The reason for this is simply that, yes, we want to take all the space we can get, but actually we get 0 space because the parent container of this view is pressable, not this outer view. And pressable at the moment doesn't take any space at all. So therefore, what we should do is we should add the, let's say, button style here like this and set the flex to 1 here. And then add this button style to pressable. So here I'll set style to styles.button like that. With this, the text is now nicely centered. Now I actually also want to add some shadow on iOS now. And for this, we can go back to the grid item here and add a shadow color of, let's say, black. A shadow opacity of, let's say, 0.25. a shadow offset of, let's say, width 0, height 2, and a shadow radius of, let's say, 8. But if we save that and go back, we actually see no shadow. The reason for that, and that's also good to know, is that for iOS, for shadow to have an effect, you should add a background color as well. So here, if I add a background color of white, we do have a shadow now. So that's something worth knowing, and that's why I'm showing it to you here. So now we have this shadow on both platforms, and of course the shadow is different, but feel free to adjust it to your requirements. It also looks better on Android now, and we're going to change the background color for every item soon anyways, but it's a nice first start. But that's not all I want to do though. I also want to change the font a little bit, and I want to make sure that we can tap these items and we get some visual feedback. So therefore, as a next step, we want to make sure that we add another style object, the title style object, where we could set a font weight of bold, and then maybe a font size of, let's say, 18. And of course, feel free to bring your own font, as you learned it in the previous sections with custom fonts. Here I'll use the standard device fonts though. With that, we can now add the title style here to our text with styles.title, and then save everything and have this look and feel. Now for some feedback, when we press the pressable items, we need to add some conditional styling. Now, as you learned, for Android, you can actually add the Android ripple prop, and then, for example, set this to a color of CCC, which is a light gray. If you do that, then here you get a ripple effect on Android. So that's quite nice. But it doesn't do anything for iOS. And as a side note, on Android, if you watch closely, you can see that it goes beyond the rounded corners, though that's super hard to see. So therefore, we might want to add overflow hidden here on this outer grid item, overflow hidden, to make sure that the ripple effect does not go beyond the rounded corners. With that added, this now looks better. But still, this doesn't do anything for iOS. For iOS, as you learned, we have to add our own styling, and you see that now we actually also lost the shadow because of overflow hidden. Because if we set anything that goes outside of the grid tile as hidden, the shadow, which is actually outside of it, will be hidden. Therefore, we actually only want to use overflow hidden on Android, and we want to add iOS-specific styling when that button is pressed. And for that, we can use the Platform API, as you learned. We can import Platform from React Native, and then here check if Platform OS is equal to Android, in which case we want to set overflow to hidden, otherwise we want to set it to visible. So now with that, we got our shadow back on iOS because now overflow is no longer hidden there. But now to also have some specific styling when this gets pressed, we want to replace this style property value for pressable with a function which returns a style conditionally. Actually, we can return an array of styles here because I always want to have my default button style, but I want to destructure this object, which we get as a default here for this function we can set as a value for the style prop, and use the pressed property that's provided by React Native to then add another style conditionally to this array of styles. For this, we have to set up a specific style like button pressed here. And now it's up to you how you want to change the appearance if it's pressed. I'll just set the opacity to, let's say, 0.5 in that case. And then it's this button pressed style that should be added conditionally. So therefore, in this array, the second value depends on the state of pressed. If that's true, I want to add styles button pressed. Otherwise, I'll add null. I'll add no style, no extra style. And with that, if we save this, now we got this little opacity effect here on iOS. And this will be a bit easier to see once we change the background color here. So now with that, we got those tappable grid items. As a last step, I now want to change the background colors of those grid tiles based on the color that's set for the category data here in the dummy data.js file. This last parameter value is used as a value for the color property on category, and I want to use that for the background color of the grid tiles now. To do that, we get this color prop, and we can now use that to change the background color dynamically. For example, we can change this styling that we add to this outer view to an array to always add the grid item base styles, but then also merge in another style object where we set the background color to color. With that, if we save this, we got these colored items. Now what this also does though, is that we still have this ripple effect, and you could change the color by that ripple effect as well if you wanted to, but the opacity effect on iOS is a bit hard to see. It would be nice if the background color would also get that opacity. To achieve this, we can actually add this background color, instead of adding it to this outer view here, to the inner view. So I'll switch back to just setting the default style object on the outer view, but for this inner view, I will change this to an array and add the background color there. What you'll notice though is that if you do that, it does look better, but the rounded corners are gone, because they are on the outer view. The simple fix is to add them on both the outer and the inner container here. And with that changed, we got rounded corners and this nice opacity effect. And it's of course up to you how strong that effect should be. With that, we got the grid, and now as a final step, I want to change the background color of this application here to make it a little bit prettier. And for this, I prepared a color which I want to set in app.json. There you learned before that you can add a background color property to this JSON object and set this to a hex code, for example, that should be used as a background color. If you save this and you force a reload by tapping into the terminal and pressing R, we got this background color, and now this looks better. Last but not least, we could now change the status bar to be a light status bar by going to app.js and adding the status bar component here as a sibling to the categories screen. Therefore, wrapped by these fragment tags, since we have two root sibling components. And then, as you learned, we can add the style prop here and set this to light. And with that, we got a light status bar. So that's now the grid. And all of that has nothing to do with navigation, of course. But this is the prerequisite we need to now add navigation as a next step. Because now we're going to learn how we can make sure that when we tap an item here, we actually go to a brand new screen with a nice animation and with the opportunity of going back thereafter. So the next step is to add navigation, that we tap an item and we're taken to a new screen. We could add it as we did in the game before. We could add a second screen and then just use an if condition and some state to switch between screens in app.js. This would work and this wouldn't even be wrong. But as mentioned before, we want to have a nicer navigation experience now, with nice animations and with the ability to go back and so on. And building all this on your own would be rather cumbersome. That's why in this section we will use an extra third-party package, React Navigation. If you search for React Navigation, you find the official website. And even though it's called React Navigation, this actually is a package that's built to add routing and navigation for Expo and React Native apps, as you see here. Of course, Expo apps are React Native apps, but as you will see, React Navigation is super easy to integrate when using Expo. That's why they specifically highlight it here. It's super easy to use if you are already using Expo, but you could also use React Navigation with just React Native. Now, the best way of getting started is to read the docs. And in general, as always in this course, I do recommend that you take a closer look at the docs whenever you're stuck or you want to dive deeper. Because this package is a super powerful package, and we will only be able to dive into the most important aspects in this section and this course, and specific niche use cases which you might have are therefore best solved by taking this course and then also consulting these docs. Now, the first step is to get started and install this package. And therefore, as a first step, what we have to do is run this command here. Hence, we should go back to our project, and in the terminal, in a new terminal window maybe, we can run npm install @react-navigation/native. This installs the core React Navigation package which we'll use. And you can ignore if you get warnings like this, it's just important that it finishes without any error, which it did here. As a next step, as you can see in the official docs, we should install some extra dependencies if we are using Expo, which we do here. If you don't use Expo, you find instructions further down below. It's the same set of packages, but the installation command is slightly different, and you have to do more thereafter, but that's why we're using Expo, to make our life easier. All we have to do is copy this command here, and then install these extra dependencies with expo install react-native-screens and react-native-safe-area-context. Yeah, that's a lot of dashes. So now these packages were installed, and with that, with this npm start process still up and running, we can now use React Navigation. Now, how do we use it? Well, thankfully, using React Navigation isn't too difficult. It's a component-based library, which means it gives you a bunch of components that allow you to set up your navigation configuration. And here we start in app.js because the entire app should be navigatable with help of this package. For that, in app.js, we import something from @react-navigation/native, which is this package we installed. And that something that we do import here is the navigation container. This is a component that should be wrapped around all the components in your app that should benefit from navigation, and therefore typically that's your entire app. So here I will actually wrap this around the categories screen. You don't need to wrap it around the status bar because that's just a utility component that allows us to adjust the styling of the status bar. But I will wrap it around my categories screen. So the navigation container is used as a component to wrap it around categories screen. This alone doesn't do anything though. If you would save this and you go back, the app looks the way it did before. It didn't change. Because this is just step number 1. When using React Navigation, you need to create such a navigation container, but you also need to use one of the supported navigators. Now, in the official docs, you can learn more, and of course, you will learn it in this section as well. But there actually are different navigators you can use, like the native-stack navigator. Under API reference navigators, you find all the supported navigators. And these navigators simply implement different navigation behaviors. You will see stack and native stack in action in a second. Drawer would give you a side drawer. And then you have various kinds of tabs that, well, give you tabs between users can switch. We're going to take a look at drawers and tabs later. For the moment, we're going to start with the stack. And therefore, we need to install another package with expo install @react navigation/native stack, native-stack to be precise. You can also use npm install, but expo install also works because it uses npm install under the hood. So this now installed another extra package here. And now with this package installed, we have to create a so-called navigator and then register the different screens that should be part of that navigator. For that, we again import something from @react-navigation/native-stack, so this package which we just installed. And that something that we import is create native stack navigator. This function, that is what we import. Now you can call this function outside of the app component to create a stack. This name is up to you though. But we create a stack of screens and therefore this is a fitting name. So we simply call create native stack navigator, this function here, without any parameters. And what stack now actually is an object with two properties where every property holds an object that acts as a component. Therefore, we can use those nested component objects inside of stack in our JSX code, and we should use it. Inside the navigation container, we can use stack.navigator to use the first of the two components that is exposed here. And then in there, we nest stack.screen. And this screen component is a component that allows us to register a screen that will be managed by this navigator. And typically we'll of course have multiple screens, but here we'll start with one. Now we can configure this screen and also this navigator, as you will see later. And we can, for example, give every screen a name. This is a unique identifier which then can be important for navigating between screens. Here I'll name this categories or meals categories. And then we need to set up a component that should be used for serving that screen. And that is our categories screen component, but not as a JSX element, but instead just the name of that component. So just a pointer at that component function, as I have it here. And then we get rid of our JSX element down here and have this finished setup. With that, if we save this and we force a reload on all the connected devices, we see that something changed. We still see the grid, but our background color is gone, and we now have a header at the top. The status bar is also gone or not visible anymore, but we can change this by changing it to dark here. Now it is visible again. Now this is a layout which we get out of the box by this React navigation package. It adds a nice header for us, it adds a background for us. And it also adds such a safe area which makes sure that we don't collide with a notch or the status bar. So we get a nice default wrapper layout out of the box just by using this package. Now you can configure and fine-tune this, and we will dive into configuration options later, but it is nice to get something like this out of the box. Before we dive into any configuration though, let's focus on adding a second screen so that we can finally see navigation in action. So let's add a second screen. And I would say as a second screen, it would make sense that we can tap a category and we're then taken to a screen where we can see all the meals that belong to a category. If we take a look at our dummy data, that means that we would have to load all the meals from that meals array that have the category that we chose here. Meals have this array that maps them to various categories. We can use that to then find the fitting meals. This will be step number 2 though. Step number 1 is to simply add such an extra screen. So here I'll add my meals overview screen. The name is up to you though. In that file we can add a function, meals overview screen. That's the name I will assign to this component. And of course we then export this component function here, the meals overview screen component function. Now in there, as I mentioned, we have to import some data from our dummy data file. So from the data folder, from dummy data. So from that file, we'll have to import the meals so that we can later identify the meals that we want to display. But as mentioned as a first step, I don't want to display any meals. Instead, I'll just return a view here, imported from React Native. And in that view, I'll add some text, which also has to be imported from React Native, where I say meals overview screen, just so that we see something on the screen, we can tell that it worked. I will also add a style sheet object already, since we'll need some styles here. So let's add some styles here with style sheet create. And I'll add a little container style object here, which takes all the available space, adds a padding of, let's say, 16 pixels. And yeah, that's good for now. And I'll add this to this outer view, or to this only view we have here. There we add styles.container. Now this meals overview screen should be loaded when we tap a category. How can we make that happen? Well, as a first step, we have to register this screen component as an additional screen in our screen setup here. So besides registering this meals categories screen, I'll add another stack screen component with, let's say, a name of meals overview. The name is up to you, of course. And then the component which I want to load when we reach that screen is that meals overview component we just worked on, that meals overview screen component we just worked on. So now both these screens are registered in this stack navigator. This alone doesn't change anything though. If we save this and force a reload, the app is still running as before, but tapping one of these items doesn't take us to this extra screen. Because how would it know that we want to go there? It doesn't know that. Just because we registered this screen does not tell React Native or React Navigation that tapping one of these items should take us there. It would be horrible if React Native or the React Navigation library would take guesses on how the app should work. No, instead, we have to make it very clear where we want to go under which conditions. And for that, we can go back to our categories screen, or to be precise, to the category grid tile, and define what should happen when this pressable component is pressed. We do this with the onPress prop, of course. And then here, we want to define that we want to navigate somewhere else. Now we could do this directly in this component, but I want to keep this component dumb and instead let the parent component that uses this component decide what should happen upon a press. So I'll just accept a brand new onPress prop, though this name is up to you because it's your component, and forward this to the onPress prop of pressable, so that I expect to get a pointer at a function on this onPress prop here, so on this onPress prop. And then I use this onPress prop down here. And whenever this onPress prop here is fired, then this function which we receive on this onPress prop will be executed on our behalf. That means that now in the component where we use the category grid tile, which is this categories screen component here, there we now have to decide what should happen upon a press. So if we're here, I'll add this onPress prop, which we just added. If you chose a different name, you have to use a different name here as well. And then here I'll add a new function, the press handler, let's say, and I'll point at this function here. But what should happen inside of press handler now? Well, here we want to navigate. And React Navigation gives us tools for doing that. Most importantly, in a screen component. So in a component that is bound to a screen, as categories screen and meals overview screen are, they are bound to screens through stack screen. So in components that are set up as components here on such stack screen components, in those components, you get a special prop provided by React Navigation. You get a special prop here, which you can pull out with destructuring, for example, because you get a special navigation prop. That is provided to those components which you use as screens, not to any child components, but to the screen components. And now this prop value, which you get here, this navigation prop value, will be an object with a method that can be used for navigating between screens. Now to use this method inside of this function, we could use bind on this function here. But we can also just define this function inside the component function, even though it's not needed. But now with this structure, this inner function has access to the arguments received by the outer function. So now we can use the navigation object inside of render category item and therefore inside of this press handler function. And inside of this press handler function, we can now call navigation.navigate. This navigate method is provided by React Navigation on this navigation object, which we receive as a prop. And navigate now wants the name of the page to which we want to navigate. So in my case, I know that I want to navigate to the meals overview page. So that's where this name now becomes important. I am on meals categories and I want to go to meals overview. So we use the name of the target page and we pass this as an argument to navigate as a string like this. With that, if we save this, now if we press such an item here, we are taken to the meals overview screen, as you can tell, with a nice animation, with a back button added to the header automatically, and we can use this button to go back. And we get the platform-specific animations and looks out of the box. So on Android, for example, we get the Android animation. And this is, of course, now a real navigation where we now give the user more control and where we do have nice animations. Now, a couple of words about these navigation actions here and these animations. We are using the React Navigation native stack navigator here. If you take a look at the official docs and there at the API reference and the available navigators, you see that besides this native stack which we are using, there also is just a stack. In general, these two navigators work the same way and give you the same kind of navigation. So this stack-based navigation where you push another page on top of the screen and you can then go back to the previous page, to the previous screen. But there is an important difference. Native stack, which we are using, uses native platform elements for this animation and for these screens. Therefore, it can be more performant than Stack, which emulates the native behaviors. That's why native Stack should probably be your preference and why we are using it here in the course. But if you're facing any kinds of problems with native Stack, you could fall back to Stack, which also gives you this stack-based navigation. Another note I want to make is related to this navigate method here on this navigation object, which we get through props. You do get it through props, but as I mentioned, you only get it in the component that is loaded as a screen. So that is set up as a screen on stack screen here. Often that is what's needed, and you can, for example, define a function that does navigate in such a component and then pass it down to another component if it is actually another component that initializes the navigation action, as it is the case here. But what if I would want to navigate from inside category grid tile? I don't get the navigation prop here. Well, of course, we could forward the prop. I could expect to get it here. And then in the categories screen, we could set the navigation prop and forward the navigation prop, which we're getting here, so that we in the end forward that down here. That would be possible. But as an alternative to this approach, you can also use a special hook provided by React Navigation if you would need access to this navigation object in a nested component. You can import something from at React Navigation /native. So not this native stack, but just native from the core package itself. And from there, you can use the use navigation hook. You can import the use navigation hook. And you can execute this hook in any component function, no matter if it is registered as a screen or not. And this will give you this navigation object. So that's an alternative to using these props, and there's nothing wrong with using this alternative. We don't need it here, but I wanted to make you aware of this alternative because, of course, often you will have a case where you want to navigate from inside a component that's not registered as a screen itself. So we got this basic forward-backward navigation. One crucial thing is missing here, though. At the moment, we're not passing any data between these screens, and of course, you don't always need to do that. You often have navigation between screens that don't need to pass any data, but here we definitely want to pass some information about the selected category to that meals overview screen. Because, for example, we maybe want to show the category name in the header instead of this standard name here, but we'll talk about configuring headers and so on later anyways. But most importantly, we want to load the appropriate meals here on that meals overview screen. Now, this is of course a super common use case, and therefore passing data between screens is extremely easy. You can do that with that navigate method that is exposed by the navigation prop. This navigate method takes the name of the screen to which you want to navigate, and this is a required parameter value, but you also have an optional second parameter value which you can pass in, which is actually an object. Now, this object, which you pass as a second parameter value, allows you to define the params, the parameters that should be passed to this to be loaded screen, so to the meals overview screen in this case. And here you could pass a parameter called category ID. This name is up to you though, this identifier is up to you. And then set the value for this parameter. In this case, I get my item data here, and we should keep in mind that item data is provided by a flat list in the end, and therefore we have an item prop here. And then on this item here, we have all the properties defined on a category. So title, color, and ID. So therefore, we can get the ID of a category by using item data.item.id. And now we're passing the unique identifier of a category through that category param to the meals overview screen. That of course brings up the next question, how we can extract that value on that screen that will be loaded. To extract parameters that are passed with help of navigation, you go to the target screen, in this case the meals overview screen here. And there we of course also get our navigation prop. So we can use object destructuring to pull that out of this prop object. We get the navigation prop because this component is registered as a screen here. But we don't just get the navigation prop. You do get that if a component is registered as a screen, but you also always get a route prop. We didn't use that before, but now we will need it. So just like navigation, you get a route prop in any component that is registered as a screen with React Navigation. And this route prop here has a params property. Now it also has a couple of other properties, and the best way to learn all about the available properties is to go to the official docs, to the API reference, and there you can learn more about the navigation prop, which we used before. We'll take a look at some of its other methods later though. And you also see the route prop there, and there you see that on this route prop, you get a params property, which is actually an object containing the parameters that you might have passed to this screen. You also get some other information, like for example the name of the screen that was loaded if you need that. But in our case here, it's the params property, which is very useful. So back here in meals overview screen, we can use route params to get hold of that params object. And the params object we get here is the params object we set up when navigating there. So here we defined this params object when calling navigate. In the meals overview screen, we now get this object by accessing params on route therefore. And hence, since I set category ID as an identifier in this params object in the categories screen, we can use this same identifier here on this params object to extract that category ID. And I'll store it in a constant called cat ID here, but of course the name is up to you. So this is how we get the ID of the category that is passed through navigation to this new screen. And for the moment I just want to output it, so I'll just output it dynamically down there in my text like this, so that we can see that we do get different values here. With that, if we go back, you see I got C1 here for Italian, for German it's C4, and for Asian it's C8. And these are the different IDs that are stored for the different categories. So that's how you can pass and extract parameters, and this is a super common thing to do, and therefore it's of course important to know this pattern. It's also worth noting that just as before with the navigation prop, you also have a hook which you can use alternatively to using the route prop. There's nothing wrong with using the route prop, but you can also import a hook from @ReactNavigationNative, and the hook which you want to import is the useRoute hook. And just as before, this gives us a route object, the same route object we get from props here. And then on this route object, we got our params and so on. So you can use this hook as an alternative to this prop, especially if you need access to the currently loaded route information in some nested component which is not registered as a screen. In screen components, you can simply use the route prop instead, but you also don't have to. Now that we pass and extract this category ID, we can use it in the meals overview screen to load the meals that we want to display. Now it's worth noting, if we take a look at our dummy data, that the IDs assigned to meals are actually arrays of IDs, because a meal can belong to multiple categories. Therefore, in the meals overview screen, to get all the meals that are loaded or that belong to this category, we should add a new constant or variable, which could be called displayed meals. And then we want to call filter, the filter method on this meals array. And inside the filter method, we want to return true for all the meals that belong to this category. Now filter takes a function, that's how it always works. And we get our meal item here as an argument automatically passed in by JavaScript. And we want to return true if we want to keep a meal and false if we want to drop it. So we want to return true if a meal has this category ID in its array of category IDs. Therefore, we want to return true if meal item dot category IDs, which is the property that holds this array of category IDs, has this category ID inside of it. And we can use index of for that, since we have a bunch of primitive values in category IDs. We have a bunch of strings in there, and then we can use index of to get the index of an item. And we know that if we have an index greater or equal than 0, a category is part of that meal, because if we would not find a given category ID in that array, index of would return -1. So here we now check for the index of cat ID in the category IDs of a meal item, and if that is greater or equal than 0, we return true, because then we have a match. This gives us our displayed meals. And now with those meals that should be displayed, or the meals that belong to this category, we can update this JSX code. We might still want this kind of view container, but instead of outputting a text here, I want to output a list of meals. Now, just as before with categories, in this dummy data, we have a pretty limited amount of meals. So we could actually manually map our list items, our array items, to JSX elements and wrap them in a scroll view to make them scrollable. But still, we will follow the common best practice of using a flat list when dealing with a list that could, if this would be a realistic app, contain a lot of items. Therefore, instead of importing text here in the meals overview screen, I'll import flat list and output a flat list here in my JSX code. Now, the data for this flat list is my displayed meals array here. And the key extractor needs to identify how we get a unique identifier for a given meal. If you take a look at the dummy data, you see that there seems to be some kind of ID set for every meal. And if we take a look at the meal constructor and the meal class here in general, we indeed see that we have this ID property. So therefore, again, we want to use this ID as a key. And to do this, for this key extractor here, we get our item and we know that we want to access the ID property of an item and use that as a key. Now we also want to add render item and point at a function that is responsible for rendering the different meal items. Again, we could outsource this into a separate function, as I did it here with categories, where I outsourced this into render category item. And I will do this here to keep things a bit more readable. I'll add a new function, render meal item, and I'll define this function inside the component function since I will need access to some prop later to navigate to yet another page. So therefore, we point at render meal item here, and render meal item receives that item data as you learned it. And now here, we want to return the JSX code that should be displayed or that should be used for every meal item that we have. Now, eventually, that will be a more complex item because we want to build an item that has an image and a couple of other things as well. But for a start, I'll simply output a view here and then a text. And actually, since this will become a more complex component, I will outsource it into a separate component in the components folder. I'll add my meal item component here in a meal item.js file and add a function called meal item, which is then exported here as a default meal item. And then here we want to return this view, which is imported from React Native. And we will also need a text eventually. And for the moment, I'll just output a view and a text. And I expect to get the title of a meal as a prop here. And I'll then output the title here in my text. Again, this is just a start. This will become a bit more complex later. But now we can use this meal item component in the meals overview screen. Here, we now use meal item. And we have to make sure that in order to use meal item here, we import meal item from our components folder. And then we pass the title to meal item. And the title, of course, is item data.item, referring to the individual item that will be output by flat list. And if we then take a look at the meal model, we see that indeed every meal will have a title property, so we can use that to output the title or to set a value for the title prop. So here we access .title. Now we should be outputting a bunch of meals. If we save this and we force a reload, if we go to Italian, I see one meal here. And if I go to German, I also see a meal. And there also should be categories where we eventually see multiple meals. For example, here, quick and easy, we have 4 meals here. And this is a scrollable list, even though it's not needed at the moment. Of course, this also works on Android, by the way. So that's pretty good. This is working. Now we can work on this meal item and make this look better. And of course, that's a great practice for you as well. Make sure that you display basically most of the information you have here in the meal model. especially also the image, and come up with a meal item of your choice, style it the way you want. In the next lecture, we'll build an example meal item together before we then thereafter dive back into navigation and learn more about navigation, because of course we're not done regarding that. But as a next step, let's focus on the meal item. So let's work on that meal item. Here in the meal item.js file, I already have a view and a text for the title. Now, I want to have a more complex meal item here that looks a bit better and is not just a bunch of text. Most importantly, it also should be pressable because we should be able to tap these meal items to go to a meal detail page where we get actual instructions on how to cook that meal. So therefore, we need the pressable component, and I will wrap that here inside that outer view, again for styling reasons, around my text. But it's not just the text which I want to have in there. Instead, I want to have another view for styling reasons. And of course, this is just for the layout and style I want to have. You can definitely come up with your own look and feel. But here I will now add my text inside this inner view. And then I'll add the image component here, which also has to be imported from React Native. Now we need images to load here, and these images are actually part of the dummy data. Here we got links to these images. Now we haven't learned how to load images from the web yet, but it is quite straightforward. And of course, the official React Navigation documentation is your friend if you want to learn all about it. But all you have to do is set the source as we did it before. But now instead of requiring a local file, you set an object as a value here on this source and add a URI key to that object. And the URI is that URL pointing to an image. Now here we can then expect to get this image URL as a prop on the meal item, and then simply use this here like that. Now what is important though is that if you're using an image from the web as we're doing it here, you have to add styles that define the width and height, since that can't be inferred from the image file. For local images, React Native will actually take a look at that file and use the width and height of that file as a default, which you often might want to overwrite, but still, that is what it would do. For web images, it can't even do that. Hence, I'll also import stylesheet here. We'll need it for other parts as well later too. And we can set up a styles object then with stylesheet create as we did it many times before. And then here we could add an image style, an image styling object, where we, for example, add a width of, let's say, 100% of the surrounding container. And we can control the surrounding container later. And maybe a height of 200 pixels. Of course, you can play around with these values. And then on the image, we add the style prop and point at styles.image like this. Whilst we're at it, we can also style the title already. And we can add a title property here, a title object, where we, for example, set a font weight of bold and maybe text align center to have this, well, text centered, and maybe a font size of 18. And now it's this title style, which I'll add here through the style prop to my title text. So now with those styles assigned, we must make sure that the image URL is provided to the meal item, that we get this prop. Otherwise, we won't see any image here. And therefore, now in the meals overview screen, we can now also set the image URL prop here. And we access item data.item.image URL. If we have a look at the meal model, we see that this kind of property exists there. So we can access this here to set the image URL on meal item. So with that, we're passing title and image URL. And hence, if we save everything, we can now also see images here, which is a huge step forward. But of course, this is still not the final look and feel I want to have here. Instead, for this final look and feel, more styling should be applied to the meal item. And it's not just more styling, I also want to output extra data there. For example, below that view, but still inside the pressable component, I want to add another view which actually will hold some extra information about the meal. Some extra information that is set up in the dummy data that basically tells us how expensive it is, how complex it is to create that meal, and so on. For that, I'll add 3 pieces of text here, 3 text components. And I want to output the duration, and that's just a placeholder for now, the duration, the complexity, and also the affordability. And all that information will be part of the dummy data. If you take a look at the meal model, you see we have complexity, affordability, and duration as properties on every meal object in that meals array, therefore. So in meal item.js, we can expect these extra props. We can expect a duration prop, a complexity prop, and an affordability prop. And then here we can output duration, and thereafter maybe a M to indicate that these will be minutes, because that's indeed what is set up in that dummy data. Duration is specified in minutes. And we have the complexity, which is this complexity prop, and that is a string already, which we can convert to an uppercase string by calling to uppercase on it. And we have the affordability, which is also a string already, which I'll also convert to uppercase by using the built-in to uppercase method, which is provided by standard JavaScript. Now we can pass this extra information in this component, and therefore here on the meals overview screen, besides title and image URL, I now also want to pass in affordability, complexity, and duration. And since this will get a lot here, I'll create a helper object, meal item props, which is a standard JavaScript object where I add the title, which is item data.item.title, and where I add the image URL, which is item data.item.image URL, and all these other fields. And since I will always repeat item data.item, we can also cut this and get our item here like this, so that we just have item.title and item.image URL thanks to this helper constant. And then here we add affordability, which is item.affordability. We add complexity, which is item.complexity. And we add the duration, which is item.duration. And now we use the meal item props as props on this meal item component by using this syntax, which is standard JavaScript syntax and standard in React to distribute all the properties inside this object here as props to that component. So that will be the prop names, and the values will be the values for the props. And with that, we see more extra information below every meal. Now, we still don't have the styling that we want, and therefore it's time to go back to meal item.js and add more styling. For example, on this outer container, I'll add this meal item styling object here. And there, it's up to you how this should be styled, but I will add a little bit of margin around this item. Let's say a margin of 16 pixels in all directions. I want to add a border radius of 8 to have some rounded corners. I will add overflow hidden here to make sure that no content goes outside of these rounded corners. And I'll add a background color of white. Now we can add meal item, this style, to this outer view here with styles meal item. And with that, it looks a bit nicer. Now, it would also be nice to have some padding below this image, so not around the image, but below this image, so that there is some padding for all this text. And therefore, we should actually make sure that this text here receives some padding and that this view receives some padding. So on the title, we can add padding or margin, both would work. Here I'll add some margin in all directions, let's say 8 pixels, so that now there is some distance around the title. And now for the items below the title and the image, for the duration and so on, I want to position those in a row and add some padding. So here I'll add my details styling object. That sounds like a fitting name. And on that details styling object, we can set the flex direction to row to position these items in a row. Add align items and set this to center them vertically. And also add a padding or a margin around them. Let's say a padding here to mix things up. Of, let's say, also 8 pixels. Now we add this details style object to this view here. So styles.details. And now they are positioned next to each other, but of course there's absolutely no space between them. So to change this, we should add a detail item styling object where we add a horizontal margin of, let's say, 4 pixels, so that there is a margin of 4 pixels to the left and right, because we're going to add that to these items. And we can add a font size of maybe 12 to make them a bit smaller. Now I want to add this detail item style to all these 3 text items here. So I'll just copy that and copy that over. With that, there is some spacing and they are a bit smaller. Now, it would be nice if they would be centered, and that can be achieved by going to their parent view again, which has the details styling object. And besides adding align items here, I'm also going to add justify content center to control how the items are positioned along the main axis, which in case of flex direction row is left to right. And by choosing center, they will be centered along that left to right main axis. So now this looks way better. If we take a look at that on Android, it also looks decent there. Now we might want some shadow there as well, and therefore we can of course again go to the meal item and add some elevation of 4. And then also add the same kind of shadow I added to the category grid tile. So I'll just copy it from there, and I will copy my shadow radius and all of that, copy that, and add that here below the elevation, like this. Now with that we have a little bit of shadow. And of course, we could now also build a reusable component that sets this shadow, since we are using this style in multiple different components. That is absolutely something you could do as an extra challenge. It's not something I will do here though, but it is something you could consider. By the way, here, I think I will ramp up this radius a little bit and the opacity a little bit. Now, a little side note about iOS though. Of course there, unlike on Android, the shadow is not visible because of overflow hidden. We had this problem here in the category grid tile as well. And therefore we want to copy the fix from there or create that reusable component that could give us this card wrapper wherever we need it. Here I'll just copy it real quick though. And add this for overflow. And of course, therefore, we need to import platform from React Native for this to work. So now with that, we got a shadow here on iOS as well. Now, since we now got no rounded corners at the top here, since we removed overflow hidden, what we should do, and what we did do before as well, is also set the border radius on the inner container. That doesn't exist at this point of time though. Therefore, I'll add another view inside of this pressable here that wraps both the container around image and title and the container around the details. And on this new inner container, I also want to set border radius 8. So here I'll have my inner container We set border radius 8 on that. We then also should set overflow to hidden though, because otherwise we still don't have the rounded corners. But now we have the rounded corners and still the shadow, because now overflow hidden here on iOS is set on a different container than the shadow. That's why it now works. If we would set overflow hidden on that outer container, we still would get rid of the shadow, as you saw it before. On the inner container, it works though. And with that, we have the rounded corners and the look we want. Now, last but not least, we want to make those items pressable. That's why we have the pressable component, and therefore they are pressable already. If we add on pressed, we can handle those presses, but we also might want to have some feedback when we press them. Now again, for Android, we can add the Android Ripple prop here and add an object where we set the color to this gray, for example. It's of course up to you which color you choose though. And now we got this nice ripple effect here on Android, as you can see. But we also might want some opacity effect on iOS, and therefore, just as before, we can copy that from the category grid tile to apply the appropriate look and feel. So we can set the style prop here on pressable and do this here in meal item.js as well. And now we need to prepare the style that should be added when this button is pressed. We don't need this default style, which we needed in category grid tile. We can get rid of that. We therefore don't need an array of styles either. And we can get rid of that comma here at the end. But we need the button pressed style. And here I'll just copy that button pressed style from my category grid tile and then define that here. So that now, let's say here maybe I have button pressed. And hence now on Android, we have the ripple effect and this opacity effect. On iOS, we have just opacity. And you could use the platform API to make sure that on Android you don't have the opacity effect, but here I actually like the combination of both. So this works. Now we got this added and styled. Now we can dive back into navigation related topics. So now we achieved quite a bit, and we have this basic navigation going on. Now, of course, we're missing the details page when we tap a single meal, but before we implement this feature, let's talk about the styling, the default styling we get, the default title we get here in the header, and how we can change those defaults. Because whilst it is nice to get these default settings, we do get a good looking shell for our content after all, we might want to fine-tune the settings. We might want to change the title, we might want to change the color of this header, and so on. And of course, all these things can be configured and changed. But where can we change things? Well, here in app.js, or in whichever place you define your screen setup, your screen configuration. Here, where we have the navigator and its screens, here we can configure it. And there are a couple of different ways of configuring things, and I want to show you all of them. And for this, let's start with this first screen here, meals categories. We got a title here, and as you can tell, this title here, which we have here, is in the end simply that name which we assigned here. Now, the idea behind this name really just is that we can navigate between screens. So that we can go to Meals Overview, for example, by navigating to it by its name. That's the primary idea behind these names. Now, React Navigation also uses these names as default header titles. And of course, we could use names here which make up for good header titles, but often you want to have a different title than name. And for this, you can add another prop to your screen component here, and that's the options prop. Options wants a JavaScript object, hence these inner curly braces, and then there are a ton of options we can set. You get autocompletion here, which makes setting options easier, But in addition, I can only recommend that you dive into the official docs. There, if you go to API Reference, Navigator's Native Stack, you'll learn about all the options you can set. For example, you'll learn that there is a title option you can set. But there also are many other options, and I can only encourage you to take a detailed look at these options if you want to achieve a certain look and to simply play around with them. Now here, we could, for example, set the title option to set the title to meals categories or all categories or whatever you want. And as soon as you do that and you save everything, this title is updated here in the header. So that's how you can configure this. Of course, you're not limited to the title. What if you want to change colors? Of course, that's possible as well. We could go here where we just set the title and also add our header style option here. Again, the official docs tell us that this option exists. Now, header style wants an object where you can set various header styles, or to be precise at the moment, at the point of time I'm recording this, there is only one style. You can set the background color, which is the style I do want to set though. And then you can choose any color you want. Here I'll use this extension which I have, which gives me a file picker here to pick a nice brownish color, maybe something like this. The hex code is 351401. If we save this, we get this background color. Now the text is not really readable anymore, and therefore we can change this as well, and that would be done with help of the header tint color. Again, the official docs tell us that this will set the color of the title and also of the back button and the back button text. Here I'll set this to white. And with that, this is readable again. Now, what about the background behind this grid? We actually did set a background color before in app.json, but this seems to have no effect anymore now that we added React Navigation. Indeed, if we want to change the background color of this default background which is provided to us, we can again set another option here. And that would be the content style option. Here we also pass an object as a value, and we can set all kinds of styling related options here, including the background color, now for the main screen content though. And that could be any color of your choice. Here I'll pick that brown as a starting point and then pick like a light brown grayish background color. In this case, it's the hex code 3F2F25. Now with that, if we save this, that's my background. Now, of course, pick any colors you want, but this is how you can set them. What you'll notice though, is that if you now navigate to a different page, these settings are lost. There is a nice transition between the colors, but still we're losing the colors. This is actually not a bug, but happening on purpose, because you could have an app where you do want different styles for different screens. That could be something you want. Here it's not something I want though. Now to fix this, we could copy these options to the other screen. That would work, but if we have a lot of screens, that means a lot of copy and pasting. It also means that if we ever change a setting, if we change the background color of the header, for example, we have to change it in multiple places. Therefore, React Navigation also gives us a way of setting default screen options. Instead of setting options on the individual screens, we can grab the options that should be applied to all screens and add them on the navigator. There, we don't add an options prop, but instead a screen options prop, which also wants an object full of screen options. And these are the default screen options that will be applied to all the screens registered in this navigator. So these two screens in this case. Now, if you had clashing settings, if we would also be setting a header style in one of the screens, the screen-specific settings would always win, but the default settings are used otherwise. And therefore now, with that, we can see that now on this category screen, if we select a category, we also got the header color and the background color. So this now works as expected. And that is how we can generally set options for our screens. But one thing is missing here. We can set options like this, but what if our options should be dynamic? What if I select a category and I then want to show the category name up here instead of meals overview or any other static text? Well, that's what we'll dive into in the next lecture. So how can we set options dynamically? Well, there are a couple of ways of achieving that. For example, we can use this options prop on a screen configuration component. And instead of passing an object to options as we did it before, which is a kind of value you can pass, you can also pass a function, an arrow function, for example. Now, this function, if you pass one, will then be executed by React Navigation, and it will receive an object with two pieces of data. And we can use object destructuring here in the argument list to get these two properties that will be part of that object, which we get automatically by React Navigation. And that would be the route and the navigation properties. So we get an object with these two properties automatically by React Navigation passed into this function when we define such a function here for options. And this function will be executed on our behalf by React Navigation. Now, this function will be executed whenever the screen becomes active, and this function should then return an options object. So the same kind of object we can set directly should be returned here. But since this is a function where we get information about the current route and navigation, we can actually set options dynamically here. For example, we know that inside of the route, we get our params. And we could get the category ID here by using route params category ID. That's how we also retrieved it on the meals overview screen. There we also use route params category ID. So that is what we could do here. And then here we could set the title equal to cat ID like this. With that, if we save this, we now have the category ID as a title here on this screen, as you can tell. Of course, that's not too useful, but we could also use this category ID now to get a category from the dummy data, from this categories array, and then get the title of that category with a certain ID. And we could do that all here in app.js. So that's one way of setting options dynamically and taking route-specific, screen-specific data into account. Nonetheless, I'll comment this out and I will not use this approach here because I want to show you an alternative. The alternative is that you set options from inside the component. For this here, in the meals overview screen, we can use this navigation prop, which we also get. We know that we get it because this component is registered as a screen, and screen components get route and navigation props automatically by React Navigation. Now, why do I want to use this navigation prop? Because this navigation prop does not just have that navigate method, which we used in a different place before, but this prop also has a set options method. And this set options method takes an object, which then will be set as options. And therefore, this options object takes all the configuration items, all the properties we saw before and we see here in the official docs. So now here we could also get our categories title by, for example, also importing this categories array. And we're already getting the category ID here. And then we would get the category title simply by using our categories array and finding an item with the default find method, which is part of vanilla JavaScript, which takes a function that should return true for the item we're looking for and false for other items. And this function then gets every category because this function will be executed for every item in categories. And here I want to return true if category.id is equal to cat_id, because then I know that I found the category with that ID. And I want to store the title here, so on that object returned by find, I access the title. Theoretically, this could be null, but we know that it won't be here because the only way of reaching this screen is through a navigation action that did set a valid category ID. And then we got the title here. We can therefore set the title option to category title. If we do that and save this, that works, and now we have the category title here. You will also notice that I get a warning down there though. Also on Android, where it also works, but I do get this warning. And I do get this warning because of how I set options. I'm setting it like this directly in the component function, and you should not do that. Instead, you should use useEffect. So therefore, we can import useEffect from React. And useEffect allows us to process this side effect, and setting the options of this screen is a side effect. So then here we can use useEffect, pass this effect function and the dependencies array. And then we want to get the title and set the options inside of useEffect. And our dependencies therefore are the cat ID and this navigation prop object. These are the two external things we use inside of this function. Categories is also external, but not part of the component function. It's being imported instead. And therefore, this will now set the options properly. With that, if we save this and reload, indeed, you will notice that the warning is gone. But you will also notice that now the title isn't set as smoothly as before. Instead, it jumps after the page has been loaded. So it's only set after the screen has been loaded. It's not set whilst the animation is in progress. Now this happens because useEffect actually executes this effect function after the component function was executed for the first time. That's why it's looking that ugly. This can be fixed by using the useLayoutEffect hook instead. Chances are that you may have never used this hook before, because indeed you do rarely need to use it. But you can use it in situations like this, where you typically have some kind of ongoing animation and you want to set or execute some side effect whilst this is still happening and before the component has been rendered. So before this component function has finished execution. Or to be precise, you want to run this effect simultaneously with the component function execution. Then we use useLayoutEffect instead of useEffect. And we use useLayoutEffect in the same way as we did use useEffect. It's just handled differently internally. And therefore, if we save this now, we got this smooth transition again, and the title is set appropriately now. So that is working. Please also note how React Navigation automatically either shows the previous screen's title here next to the back button, or just back if the title on this screen is too long. So there's a lot of nice magic which you get out of the box by React Navigation. And that is how you can set such settings dynamically, either directly from inside the screen configuration, or with set options and useLayoutEffect as I showed it to you here. As a last step, and not really related to dynamic configuration, I also want to adjust the status bar because it is too dark, and therefore in app.js I simply go to the status bar and change the style to light. And with that it's white and we can see it again. But that's it for configuring navigation, for the moment at least. Let's now see what else we can do. Now, with the configuration out of the way, let's make sure we can reach the detail page of such a meal. And for this, of course, we need to add that page or that screen as a first step. And this is a great exercise for you. Add this brand new screen. For a start, it can simply contain some dummy text that says this is the meal detail screen. But make sure that you add such a screen, that you register it as a screen, and that you navigate to that screen when such a meal item is pressed. Also make sure you pass some data to the screen, specifically the ID of the meal that was selected. Here's a short pause I give you to pause the video and try this on your own first. Thereafter, we're going to implement this together. So, did you succeed? Let's implement this together. And for this, it all starts by adding a new screen. I'll name it Meal Detail Screen because that is what it is. And in there, we create a function, the Meal Detail Screen function, which of course, as always, is exported. So that's important. And then here, for the moment, I'll just return some text. But of course, this component then must be imported from React Native, as you learned. So we want to import text from React Native and say this is the meal detail screen. And I also want to output the meal ID here in the future, but we'll get there in a second step. So for the moment, that's the dummy meal detail screen component. Now, to be able to go to that component, we must register it as a screen. And we have all our screens registered in app.js, so there I'll add it as an additional screen. Now, it doesn't matter where exactly you add it inside this stack navigator. The position doesn't matter, but here I'll add it at the bottom, add another stack screen component here, and give this a name of meal detail. Name is up to you, of course. Now we need to define which component should be loaded if we navigate to this screen, and that would be the meal detail screen component. And of course, this component must be imported in order to be available in this file. So with that, the screen is registered, and we can also already give this screen a title if you want to, but I'll come back to this in a second. For the moment, let's make sure we can get to this screen, and I want to be able to get to it by tapping on a meal item. Now we got this meal item component with the pressable component in there, but ultimately I want to start this navigation action, and we could start the navigation action from inside meal item. Now we could also start it from inside meal overview screen, and it's up to you where you want to take care about this. I will do it from inside meal item just so that we also see this alternative. Because before with the category, we did not start the navigation from inside the grid tile. Instead there we used categories screen. Now to show you the usage of the use navigation hook, I will do it from inside meal item.js. Because this component is not a screen component and therefore it does not get the navigation or route props. But we need access to these props, or at least to the navigation prop, and you learned already that you can get hold of it by using a special hook provided from @react-navigation/native. And that would be the use navigation hook. This hook can be executed in any component function, including meal item. And if we execute it, we get a navigation object which has the same shape as the object we get through props, through the navigation prop in a screen component. And on navigation, we therefore can call navigate. And then we first of all need the identifier of the screen to which we want to navigate. And in this case, that would be the meal detail here. So that's this identifier I want to use. So let's grab this and go back to meal item and use this identifier here. Now I mentioned before that I also want to pass in some data. I want to pass some params to this screen. To be precise, I want to pass the ID of the meal that was selected. We can achieve this by passing this second parameter value, which is our params object. And in there, we can set up any key value pairs we want. For example, add a meal ID param and set it to a value of ID, expecting ID to be a prop which we receive in meal item. So now I'm using this ID here. That's what I'm doing. But of course, for this to work, we must make sure that such an ID prop is set on meal item. So in the meal overview screen here, where we render all the meal items, we have to add ID to these props that are added to meal item. And thankfully, our meal item, which we have here, does have such an ID property. So we can access item.id and set the ID prop with help of this line of code. So now we should be able to navigate to meal detail now from inside this meal item component with help of the use navigation hook. And with that, if we save this and force a reload, I can tap this item and nothing happens. Instead, I go to this detail page whenever I select a category. Now, why is this happening? This happens because at the moment, I of course call navigate from directly inside the meal item component. We want to do that when this meal item is pressed instead. So what we should do is add a function here, the select meal item handler, for example, and trigger this navigate method from inside this function. And then this select meal item handler function should be connected to pressable, so to our button, with help of that onPress prop, like this. Now that's the proper setup, and if we now save this and reload, we can go here, select the detail, and go to the detail page. But of course, at the moment, we're not extracting that meal ID that we're setting as a param, but we did learn how that would work. In the meal detail screen component, we do receive the route and the navigation prop, because this is a component that is registered as a screen. And we don't need the navigation prop here, but the route prop gives us access to the params that were set for this route. And this gives us the meal ID, because on that params object, we do have this meal ID property, because when navigating to this meal detail screen, we do set meal ID here in this params object when calling the navigate method. So since I chose meal ID here, we also have meal ID available here in the meal detail screen when we get hold of our params. And now we can use this extracted meal ID here and output this for the moment. Of course, we're going to output more useful content in the near future. But with that, if we visit a meal, we see the ID of that meal here. And you see it changes as I select different meals. So that is working. And with that, we again practiced navigating to a new screen. Now there are still more React navigation related concepts into which we'll dive soon, but for the moment, I want to stick to this meal detail screen and add more details to it before we then thereafter dive into more React navigation concepts. So let's work on this meal detail screen now, and let's enrich it with actual details. For this, I'll get rid of this text here. Instead here, I want to have a view that surrounds my content. And then we could output an image again, this same image which we see on this screen, but now on the detail screen at the top. And below that image, we could output the title, so inside of a text component. And then below that, we could have a view with those details, which we also see here already. So the duration, the complexity, and the affordability. So we could have this here. And for this, we could actually copy the view that we have in our meal item component, where we already are outputting these three items, and also copy their styles. Or since we plan on reusing this, we could create a reusable component, and I'll do the latter. But that is something I want to add here as well on this detail screen. And then below this view, which will have this reusable component I just talked about in a second, below that I then want to have a little title where I say ingredients and where I then output a list of ingredients. And then below that, I want to have another title, so to say, where I say steps, and I then output all the steps it takes to cook this meal. So below every text here, every title, I want to have a list of ingredients and then a list of steps. Of course, that's just the general structure I'd like to have, but I think that this should be a structure that should work quite well for outputting meal information. Now, of course, that also means that we need all that meal data. So we should actually import the meals from going up one level, data, dummy data, so that with help of that meal ID, which we already have, we can get the right meal and the data that belongs to that meal, therefore. So here we then have the selected meal, which we get by using meals.find, the built-in find method, to find that one meal where the meal ID is equal to that meal ID we got through params. And then this selected meal will give us access to the image, to the title, and to all the properties that are set up in this meal model. Now we don't need all of them here, though you could add extra properties in your meal detail screen, but I want to use some properties like image URL, title, the steps, and so on. So therefore now here for the image, we could then set the source, though for this of course we need to import image from React Native. We should also import the view, by the way. And then we can set the source on the image, and as you learned, if it's a network image, we set the source equal to an object. And in that object, we set the URI to that URL which we're trying to load. And in this case, we then set selectedMeal.image URL. Below that, I want to output the title, so that is selectedMeal.title. Then here, I want to have these little pieces of extra information, the duration and so on. And therefore, since we also use this in the meal item component, I'll build a reusable component, which I'll name meal details. The name, of course, is up to you. And that is a regular component function, meal details, which we, of course, export as we always do, like this. And then in here, I want to return this view here with these three pieces of information. And I'm going to cut this from the meal item.js file and return this here instead. And therefore, of course, in this meal details.js file, we need to import view and text from React Native. And we also actually need to import style sheet already because we'll need to define some styles here. So I'll add a styles object with style sheet create, because we also need to bring over the appropriate styles, of course, the details and detail item styles. So from meal item.js, we also copy details and detail item, or we cut these styles to be precise and add them in meal details.js in this style sheet. Of course, we also must make sure that we get duration, complexity, and affordability. And therefore here, I will use object destructuring to pull out some props. And I do expect to get the duration, the complexity, and the affordability like this. Now we can use meal details in the meal item component again. So in here, where we previously had that view with the details, we now use meal details. And of course, for that, we must make sure that we import meal details here. And then we want to forward duration, complexity, and affordability by setting the duration prop equal to the duration value we have here in this meal item.js file, by setting affordability equal to affordability, and the complexity equal to complexity. And now we can use that same meal details component in the meal details screen here. Instead of this view, I will use the meal details component we just worked on. And for this, of course, we must import it in that file as well. And then we can set the duration equal to selected meal.duration. And we set the complexity equal to selected meal.complexity. And we set the affordability equal to selected meal.affordability, like this. So now we have these three elements here. Of course, we will still have to add styling to some of the other elements, but this is a start. Now we also have all these ingredients and steps which we want to output here. And for this, we could use two flat lists, but for this dummy data, and in general for meal data, it's unlikely that we have a super long list of ingredients or a super long list of steps. It could be the case for very complex meals, but most likely you just have 5 or 6 or 7 steps and maybe like 10 or so ingredients or less. And therefore, you might not need a flat list and its performance benefits it can give you, and instead outputting a regular list of elements could be enough. And that's therefore what I will do here. In the meal detail screen here, for the ingredients, I will simply use my selected meal.ingredients and map all these ingredient items into JSX elements. Now, again, this is not something you have to do, but something I will do here. Now, if we take a look at the dummy data, we see that ingredients are just strings. So therefore, I will simply output a text here for every ingredient for the moment and output it like this. And now here, since we map a list manually, we must add the key prop again. And then we could use ingredient as a prop since every ingredient will be unique per meal. And for steps, I'll do exactly the same. I will map my steps here and use step here as a value and as a key, because my steps, if you take a look at the dummy data, are also just a bunch of strings. So that's what I output here then. Again, this is not the final styling, but that's generally the data which I want to output. Now, if we save this, this is what we get. The image is missing because when using a network image, so an image that's fetched from a URL, you must set up width and height because React Native doesn't know which dimensions it should use otherwise. It can't infer the width and height from the image, so we'll have to add that image styling later. But we see that the rest of the data seems to be there. So therefore now, in the next lecture, let's work on that styling here. Let's work on the styling, and let's start with the image. For this, in the meal detail screen, we need to add a style sheet. Alternatively, we split this into a bunch of other components that are stored in the components folder, and we style those components. I work with less components here for this demo. It would of course be fine to work with way more components. So therefore here I'll stay in this meal detail screen and add a style sheet. And with the style sheet imported, we can add our styles object here with style sheet create, of course. And then we can start with setting up some styling for the image. Here I want to use 100% of the available width based on the parent in which the image is placed, so based on this outer view. And I'll give this a height of, let's say, 350 pixels. As always, play around with these values to find the values that best suit your needs. With that defined, we can go to the image and add our style here and add the image style. With that, our image is here. Now we can work on the title below the image, so on this text. For this, I will add a title property here and give this a font weight of bold, a font size of maybe 24 to have a big title, and I also will add a margin in all directions of 8 so that we have some spacing around the title. I also want to make sure it's centered, so I'll add text align center. And then this title style object can be added to this text here. with styles title. Now with that, we have this kind of title here. Now it is a bit hard to read like this because we have this brown background. So therefore I want to change the color, and I will simply set this to white here. So color white. That's the color I'll choose here. And with that, it's way better, way easier to read. By the way, of course, these details are also hard to read. And here the problem is that I can't change the color in meal details in the component where we have the code for these details, because if I would do it here, the color would be changed on this page as well. And here I want to have black text. But we learned a solution for this problem earlier in the course already. We can kind of build cascading styles in React Native by simply accepting an extra style property. Here in meal details, we can accept a style property and merge that incoming style with the default styles by putting the default styles into an array and adding the incoming style as an extra element in the array. So whatever we receive here will then also be added as a style on this view and will override the style set here. That, however, won't help us with the text color, as you learned, because the text color is set on the text elements. So with the style on the text elements, not on the wrapping container. That's why I will add a second property, the more important property for our use case here, which I'll name text style, which will be merged with these text styles here. So here, same logic as before, I add this as a second element in these arrays here, so that I have some default styling, and then we add that text style that could be set from outside, so from inside the component where the meal details component gets used. And this allows us to go back to meal details screen and add this special text style property here on meal details, and then set up a specific style that should be applied to these detail items. And for this, I'll add my detail text style property, and all I want to change here is that the color should be white instead of black, which was the default. So now here, as a text style, I will set styles.detailText. And therefore now this is also white. Now we got the ingredients and we got our steps here. For that, we basically have two subtitles, so to say, ingredients and steps, and I'll add an appropriate style object here. Subtitle. And the text color should be white. I also want to use a bigger font size, but not 24, but maybe 18. And I also want to use font weight bold. In addition, there should be some spacing around the subtitle, so margin 8 probably makes sense here as well. Or maybe margin 6 to have a little bit less margin than around the main title. And then this subtitle style object can be used on this ingredients text here with style.subtitle, and on this step text here with styles.subtitle. And here it should also be styles.subtitle. With that, we got this. Now we could also center that here, and therefore also add text align center here on the subtitle, so that these subtitles also are centered. Now what I will also do here is I will add a little bit of padding of 6 and actually reduce the margin to 4 therefore, and then add a border bottom color of white and a border bottom width of 2 to have a little bit of a border. 2 should be a number though, which we can't add like this though, because subtitle gets added to a text, and it turns out that texts can't receive borders in React Native. Therefore, I'll add extra view here, which is wrapped around this text, which I'll give a style of, let's say, subtitle container. And this subtitle container will now receive some styles, and the styles added there are the border and the padding, and also the margin now that we have it. So that this is our subtitle, that's our subtitle container, And with that, we have this border below ingredients. And I will do the same for steps. And actually, I want the border to not go as far towards the edges. And therefore, I'll ramp up the margin horizontal here to, let's say, 24. And use a margin vertical of 4 and get rid of the general margin so that we have more spacing to the left and right, and therefore this line doesn't go all the way to the edges. So therefore now we got this, and we can now use this same kind of container, this view with the subtitle container, around our other text here, the steps text. So that there we now also got this little border. Now what I actually also would like to do is change the color of these subtitles and of the border from white to a light brown, just to mix it up. Therefore, I actually will grab some color that was set up in app.js, this light brown hex code here. I will grab that, go to the meal detail screen, and on the subtitle, I'll change this color here to this light brown, but I'll pick an even lighter brown. Maybe a little bit browner. Like this, like E2B497. Yeah, that looks good. And use the same color for the border. So copy that and set this as a border bottom color so that this looks nicer. And now we just have to style these steps here. Now for this, I want to have the same look for both lists, and therefore we can create a reusable component. And actually, we can create such a reusable component for these subtitles as well. Now for that, I will create a new component file, and I'll first of all create a component subfolder to group these screen-specific components together here. And I'll name the subfolder meal detail. And then in there, we can add a subtitle.js file, and then also a list.js file. Now, subtitle is a component function that's exported. And of course, so is list, and we can therefore just copy this and name it list. Now in subtitle.js, I want to output this view and text and just make the actual title text configurable. But therefore, I'll cut this from meal detail screen and add it here as the returned JSX code. And of course, therefore, we need to import view and text and also already style sheet, because we will need it, from React Native. And we should create our styles here with style sheet create, because of course we also need to bring over the styles that we need for this subtitle. And therefore, from meal detail screen, we can grab the subtitle and the subtitle container, cut that, and bring that over to subtitle.js. And now just make the actual text configurable by using props. So here we get the children prop, let's say, this default children prop, so that whatever we pass between the opening and closing tags of our custom subtitle component will be used as a text here. And now we can use this subtitle component anywhere in this app, in this case in the meal detail screen, and use it here to output our subtitle of steps. Of course, for that, subtitle must be imported, so make sure you add this import in the meal detail screen.js file. We can use the same subtitle here for ingredients, subtitle, ingredients, like this. With that, nothing changed visually, but we're reusing this code. And we can do the same thing for the list now. For this, we can cut this list code and go to list.js and return our list here. Now we don't need curly braces here. And of course, for that, import text and actually also view, because I plan on styling this in a little bit of a more fancy way, and also style sheet from React Native. Now then we can set up our styles here with style sheet create. And now for the styling, I wrap this text in a view because I want to add some styles that can only be added to views, not to text. And now we need to make sure that the actual data that we want to output is received from outside. So through props, I expect to get my data for this list, and data should be an array so that we can actually map through that data, get our data point here, and then use this data point as a key in this case, since we know that this list will only be used on data where the data point itself can be the key. And we then also output the data point value here. And with that, we should move the key to this view, because this is now the outer element in this mapped list. And we can now get started with styling. For example, I want to set up a style for this overall list item, where I add a border radius of, let's say, 6 pixels, and a padding of, actually a padding horizontal of 8, so to left and right, and padding vertical of 4, so top and bottom. And then a margin around this list item of vertically 8 and horizontally 12. Actually, vertically, it should be 4. I also want to add a background color here, and that background color should be that same color that we used in the subtitle for the text color and for the border color. So this light brown, I'll use that here as well as a background color. And then the item text style here should set a color that actually should be the dark brown. So for this, we can go to app.js and pick this dark brown again, which should now be a nice contrast against this light brown background. We can also use text align center. Now we need to assign these styles. So to this view, I'll add a style of list item, and to this text here, I'll add this style item text. Now we can use this list component in the meal detail screen, for example here. And of course, for that, we must make sure that we import it. So we should import list from components meal detail list. And then here, we need to set that data prop, which in this case is selected meal.ingredients. And then for that second list here, data should be set equal to selected meal.steps. If we save this, that's what we get. Now what you'll notice is that this is problematic here, because we can't scroll the page and we actually have content that's now, well, outside the page boundaries. What's also not looking that great is that this is too wide here. Now we'll work around the width in just a second, but let's first of all make sure that this is scrollable. So let's first of all fix that width problem real quick. And to fix this, what we can do is we can put this into an extra container. So these two blocks of content, the ingredients and the steps, and set a max width on that container, for example. So here we have our list container, you could say. And in there, in this list container, or on this list container, we give this a width or a certain max width. Here I'll give this a width of, let's say, 80% of the available width, like this. And then add this list container on this view here. So style is styles.listContainer. Now to make sure that it's centered again, we have to center the content in the parent container. And that would be this outer view here. Alternatively, we add another wrapper view around our list container and give this view the entire width and center its children, so this inner container, in the center horizontally. Both would work, and I'll go for this second approach. So here I'll add my list outer container and just add align items center here, because this should then center the items appropriately. And we add this style to this outer container. Now, there will always be more than one way of achieving a certain result, but this gets the job done. Now, last but not least, I want to make a tiny tweak here and actually go to my subtitle and reduce the margin horizontal here back to 12 so that this border actually has the same length, so to say, or the same outer margins than the items below it. So now that's that styling thing, but we also need scrollability. Now we could make these individual lists scrollable. We could also just make the part down there scrollable with ingredients and steps. But actually, I think the best user experience is if the entire page is scrollable. And therefore, to achieve this, all we have to do is on meal detail screen, we wrap this all with a scroll view instead of a regular view. So besides importing the regular view, we also import the scroll view and replace this outer view with scroll view. With that, it is scrollable and we can view all these items. Now I just want to have a little bit of extra margin to the bottom so that we can scroll this a bit wider. And for this, I'll add a new style object here, root or root container, as we often called it, where we add a little bit of margin to the bottom, let's say of 32 pixels. And we now add this here to this scroll view. So here we add the style prop and point at styles.root container. And with that added, now we can scroll down further. So that's working. And of course, that is also working on Android. There we can now scroll as well, as you can tell. So that is the meal detail screen. And with that added, we can dive into more React navigation related concepts again. Back to more React navigation topics. We added this detail screen, which is nice to have. But now let's say, in the header here, we want to have a little button that allows us to save this detail as a favorite. And of course, we could have the need for such a button on any screen. But here, for example, let's say it's on the meal detail screen. Again, React Navigation makes that quite easy. Adding buttons to the header with which you can interact is quite straightforward and not too difficult. So how can you add buttons or elements to the header? Well, with the options that you can set on a screen, because there we configured other aspects of the header as well, like for example the title or the background color. Now therefore what we can do is in app.js, we could go to the screen where we want to add a button. Let's for example say that's this screen here, the meal detail screen. And then there we can add our screen specific options. And we can add the header right or left option here. And this allows us to add an element to the left or right of our title. And here I'll choose header right. Now you can add any element here. What you should provide here is in the end a React component function. So you can create a separate React component function in a separate file, or you create a function inline here, and what you should return in this function is JSX, since again, the value for header right should be a component function. So here we can return JSX, and for example, we could return some text here where we say in the header. Now we just need to make sure that text is being imported from React Native. Otherwise, we would get an error. And with that import added and with that header right setting added here, if we save this, we see in the header here. It's a black on brown and therefore a little bit hard to see, but it is there and we could style it as we always did it. You can add styles, whatever you want, because this here is just a standard React component. And therefore, of course, besides adding text, you could also add a button. So here, besides adding this text, we could use the built-in button, and therefore, of course, import this built-in button instead of the text. And then, as you learned, give this button a title of Tap Me. And we could add the onPress prop to then do something when the button gets pressed. So now with that, we have this button here. also of course on Android. So that's how we can add such a button. Now this is not super beautiful. We will learn how we can add something more beautiful later, but it generally works. However, before we talk about styling this and maybe building a custom button, let's talk about interaction. Of course, as mentioned, we could add onPress here, but what if this button needs to interact with the actual screen component? So in this case, with the meal detail screen component. Since we define it here in the screen setup, so in app.js, that wouldn't really be possible. Therefore, this is one way of adding an element to the header, but it's only a good way if you don't need direct interaction with the component that is responsible for rendering the screen content. If you need direct communication, then you should go to that screen component, so in this case to meal detail screen, and set the options as you learned it before, with help of use layout effect and the set options method. So here from React, we can import use layout effect, and then we can call this here in our meal detail screen component function. And we can use the navigation prop, which we get from React Navigation, in our layout effect function to call navigation set options. And then here, to set options, we pass an object which takes the same options as we could define here in our screen setup in app.js. So therefore here we can also set header right and turn this into a component function. And then return our button here. Again, we'll use a different element later. For now, let's use a button, and therefore let's import button from React Native. Then we can add a title, tab me. But now here in onPress, since we are inside of the component function, we could call another function that we define here, like the header button press handler function. In there, I will simply console log pressed so that we see that it worked, but we could do anything in here. Switch to a different page, send a HTTP request, whatever you want to do. So now here I connect this to onPress like this. And we should add any dependencies to this array of dependencies on use layout effect. And in this case, we have two dependencies. We have navigation as a dependency and our function handler here. Now we should also add header button press handler as a dependency here, since we also use this function inside of use layout effect and it's defined outside of it. Now with that, if we save that and force a reload maybe to make sure that the code gets applied everywhere, now we can tap this, and if I tap this, you see pressed here in the terminal. And of course, if I tap this multiple times, we see pressed multiple times. So that is working, and that is how we could interact with a component then. We don't need it here, but it's nice to notice. This is how we can generally add items like buttons to a header. Now let's see how we can build a custom button, maybe an icon button, so a tappable icon that we use instead of this standard button. Though I will say that this won't be anything React Navigation specific. We're just going to build another React and React Native component. Therefore, you might want to try building this on your own. In the next lecture, we'll build this pressable icon button together. So let's build this icon button together. For this, in components, I'll add a new component, the icon button JS file. And in there, of course, I define the icon button, and as always, we then export it like that. And then in there, we in the end want to have a pressable icon. So what we can do to achieve this is use the pressable component from React Native and therefore add the import, and use an icon. And for icons, we already learned that we can use icons from @expo vector icons. And there I like the Ionicons quite a bit, but it's up to you which icons you want to use. Then you use the imported icons here as a component, so in my case Ionicons. And we now just have to set the name, which identifies the icon. And here I'll use a star for this demo. Give it a size, maybe of 24. Let's see how that works, if that looks good. And a color, and here I'll hard code this to white. Now we can add more styling in a bit. For the moment, that's my component. And now in Meal Detail Screen, instead of using this standard button here, I will use my icon button. Therefore, we can get rid of the standard button import and make sure our icon button gets imported instead. Now we of course want to make sure that when it's tapped, we still trigger this function. And therefore in the icon button, we should add the onPress prop on pressable and expect some props here on the icon button as well. For example, on press or on tapped or however you want to name it. It's your prop, so the name is up to you. And then we forward that to the onPress prop of pressable. So whichever function we receive on this prop will be bound to pressable. And therefore now in the Meal Detail screen, we can now add onPress here and point at the header button press handler. With that, we got this pressable star. We don't get any visual feedback right now, but we can see a bunch of press logs in the console, so this worked. Now, of course, some visual feedback would be nice, and the icon also should be configurable. Therefore, I'll add an icon prop, which I use instead of the hard-coded star here. And we can also make the color configurable instead of the hard-coded white, so that we could use this icon somewhere else where white maybe is not the best color, even though I'm only using it in the header here, but still. And we also want to add some styling to pressable, as mentioned. Therefore, we need to import the style sheet from React Native so that we can add our styles object here with style sheet create. And then regarding the styling, on pressable, in the end, I want to make sure that when we press this, we have a little bit of an opacity effect. So I'll add my pressed styling object where I set the opacity to 0.5 or 0.7 maybe. And then on pressable, we add style, accept this function about which you learned earlier, which gets an object, which holds a pressed property, which is a Boolean, which is true if the button is pressed and false otherwise. And then we check if pressed is true, and if that is the case, we add styles.pressed. And otherwise, no specific style is set. And with that, it's gone, because we now have to set icon and color now that I added these new props. So back in Meal Detail screen, we now can set the new icon prop and set this to star or any other Ionic icon. And the color, I'll still set this to white here. So now with this, we added the icon button, and now we got this little feedback when we tap it. And of course, we also got this button here on Android. You could also add a ripple effect there or do whatever you want to do, but I'm quite happy with this button and this effect. And now we learned how we can add such a header button, even though it's just a dummy button here. But in your app, you might have a use case where you need an actual button that does something. And then this is how you can add it. Build your own button or use a default button and simply add it to the header with help of set options and header right as an option. So by now, we spent quite a lot of time on React navigation and on adding navigation to this Meals app. We will get back to that app in a couple of minutes, but for the moment, I actually switched to a brand new app, which you find attached. You find the starting code for this app attached. And this is a super simple app. It's almost not an app. It's just the app.js file with some dummy text and then 2 dummy screens prepared by me, which aren't too fancy, but which we will use to dive into some other navigators. Because if we take a look at the official documentation of React navigation, and there at the API reference, and there at the navigators, we learn that we don't just have the stack and the native stack navigator, but also a drawer navigator, and then various tab-related navigators. And these are simply different navigation patterns that you could also require in your application. Therefore, in the next minutes, we're going to take a look at how we could use the drawer and the tabs navigators before we then switch back to the Meals app and see how we can add one of these navigators in addition to the Stack navigator to that app. But first, let's dive into these navigators. So let's dive into the other navigators and let's start with the drawer navigator. This allows us to add such a side drawer to our app, and as always, the official docs are the best place to learn all about it. What we do learn here is that we can install this navigator by running npm install @react navigation/drawer. So therefore, here in this dummy app which I prepared, I want to add this navigator. So hence, in a new terminal tab, I will run npm install @react navigation/drawer to install this package. And then thereafter, we will also need to install these packages. Here with Expo install, if you're using Expo, which we are, because these are packages that are used under the hood by this drawer navigator. So therefore, once the drawer navigator installation finished, I will also install these other packages with Expo install. So now this installs all the packages we need to install in order to use this drawer navigator. And therefore, once this is installed, we can start using it. And that's why I kept the app.js file super lean, because the goal now is to add this navigator there. And for this, we want to set up navigation from scratch again. Now, the first thing we need to do for this is that we need to import something from @react navigation/native. So not from the drawer package or the stack package, but from the React Navigation Core package. And that is this navigation container component, which we used before as well. You learned that we need to wrap this around our navigation configuration, so to say, and the navigation configuration where we set up all the screens will be the next step. We can also get rid of this text import since we don't use this text component in this file anymore. So that's always step number one, no matter which navigator you're using. But now, of course, we want to use this drawer navigator, and for this we can import from @react navigation/drawer and import the create drawer navigator function. And then, just as before we created a stack, we now create a, let's say, drawer by calling create drawer navigator. You can, of course, name this constant however you want, but just as before, this stack object which we created, this drawer object actually has two main properties which hold React components or React Native components that you can use to configure the drawer and the screens that should be served by that drawer. Therefore, we use them here in our navigation container, and we start with drawer.navigator. That sets up the navigator, the drawer navigator, and then just as before, inside of that navigator, we have to register our screens. So for this, we use drawer.screen. So that's the same as with the stack before, now just with that drawer. The difference will be how it then looks and behaves later. Now, just as before with the screen on the stack navigator, we have to assign a name as an identifier. This doesn't change. And I want to register this welcome screen, so the name I pick here is welcome. And then we set up the component that will act as the screen. And in my case, that's this welcome screen, this component here, which is exported. And therefore, I will simply import welcome screen from screens welcome screen and then point at this welcome screen here. So that is exactly the same as before. And that's, of course, very convenient. I can also already say that you can set various options here on the screens if you would want to configure your screens, just as we could do it with the stack navigator earlier. You can also add a screen options prop here to the drawer navigator itself, even though I'm not getting any auto completion here. but this option is supported there as well, as we also learned from the official docs. There we see that a screen options prop is supported on the navigator. For the moment, I don't have any specific options that I would want to set up, and therefore I'll just configure it like this. And then I also have my other screen, the user screen, which I therefore want to point at here, the user screen. And we have to import that screen as well, and import user screen from /screens user screen like this. So that's this other screen here. I'm importing this here as well, and I'm pointing at it here in this second screen. Now, by default, the topmost screen is rendered as a starting screen. You could always set the initial route name here on the navigator to, for example, say that user should be rendered as a default. If I set this and we force a reload of the apps, I actually get an error. And this is an error coming from the reanimated package, which you might not be getting when you're viewing this, because this, to my knowledge, is simply a bug with this package and React Navigation. A fix that I found to work is to install a different version of that package, so that you install a different version of this React Native reanimated package, and you npm install react-native-reanimated @1 and execute this with save and save exact. And this will now install this version, which then should do the trick. If you're not getting any error, you of course don't need to do that. Now with all of that, the apps should work though. If they still don't work, if you're still getting an error, try restarting the npm start process. So simply cancel this process here and restart npm start, and then rerun the app on Android and iOS. So make sure that it's restarted there. Manually reload by pressing R in that terminal to force a reload, and with that it should reload and show you the working app. And we see that we start on the user screen here on Android, and after closing the app and restarting it here on iOS, we also see it here. So that's the drawer navigation-based app in action, starting on the user screen because of initial route name, which we can remove to start on the topmost screen, the welcome screen instead. As you will see if you save that and then force a reload, now we're on the welcome screen. And now what you can see is that just as before with the stack navigation, we are getting a default shell, you could say, with a header and a nice background color. And in the header, you will notice this drawer icon here. And if you click this drawer, if you tap it, a drawer opens up from the side on both Android and iOS. And this drawer contains all your screens, and you can select a different screen to switch to it, to the user screen and back to the welcome screen. And that's what you get from this drawer navigator. Now, of course, you can configure all the details here, and that is what we'll take a look at next. Now, just as with the stack navigator, you can configure your drawer navigation. For example, with the options prop on the drawer screen, and then you can pass an object to options to set all kinds of details here. Just as before, you can, for example, set the header style to set a background color and set this to, actually maybe, let's say, I don't know, maybe a dark purple color, like the hex code 3C0A6B. And if I set this, we have this dark header. If we reload, that also is applied to Android. Now, just as before, you then might want to change the text color, and that's the header tint color still, which you can set to white. And if you do that, you see the header text is updated, but also the icon color, which is very convenient. The icon is also added by default. So therefore, you can still style all these things, though certain options will also differ between stack navigation and drawer navigation. And therefore, as always, it's the official documentation that you should dive in to learn about all the options you can set, because of course, there also are plenty drawer-specific options. For example, and I think that's quite interesting, you can also set how a screen is represented in that drawer. By default, here we have the title, and therefore by default the name of a screen here in that drawer, but you can fine-tune all these things. For example, with drawer label, you can also add an icon with drawer icon, and you can change the colors that are applied in that drawer. So to play around with that, we could, for example, say that for this screen, if it is represented in a drawer, we want to set the label to welcome screen instead of just welcome. And if we do this and save this, we have welcome screen here in the drawer. We can also play around with the colors. And for example, we can set the drawer active background color and choose this purple color as a base, and then go to a lighter version like F0E1FF. And now this light purple is used as a background. We can also change the active tint color of the text by setting the drawer active tint color here and setting this to our purple, to our dark purple color here. So that now we have this look. We can also target the overall drawer style and assign an object to this to, for example, set the background color of the overall drawer to this light gray with the hex code CCC. With this, we have this gray background here. If you want that or not is a different question, but you can set all these things. Now, please note that if I switch to the user screen, that background color is gone, and the background color of the selected item also changed again, because I set all these options on the welcome screen configuration. You can do that, but just as before with the stack screen, that means that these options only apply to this welcome screen. If you have general options like the drawer active background color and the drawer style and so on, you therefore typically want to extract them from here and instead add them here on the drawer navigator to screen options. And now I'm getting some auto-completion here, which is convenient. I also will extract the header style and header tint color like this. And with that, we now set these options as a default for all screens, and it's now just a drawer label, which is screen specific as it should be, because that's the label of this screen if represented in the drawer. But now the drawer has the same look no matter on which screen we are. And I'm not a fan of that gray background here, so I will actually get rid of that or comment it out, but it is worth knowing that you can style all these things. You can also add icons if you want to, and that's another interesting thing, but just as the label, the icon typically should be screen specific because the different screens should have different icons when represented in the drawer. Now you can set the drawer icon here, and this wants a function, actually a React component function, where you get some default props, like for example the color, which is influenced by the active tint color you set here. So the color chosen by the drawer navigator, because the color of course is different based on whether that item is currently selected or not. And then you can return your icon here. For example, we can use the good old Ionicons from @expo vector icons as we did it before. So these Ionicons here. And we can then render such an item. And for the welcome screen, we can therefore render an icon, let's say the home icon, and set the color to that color which is given to us from the navigator, because again, that is different based on whether this item is currently selected in the drawer or not. And maybe a size of, let's say, 18. We can play around with that, of course. By the way, besides the color, here we also get a boolean that tells us whether this item is currently selected in the drawer or not, and we actually also get a size, so I will use that instead. And with that, we now have this home icon here. And if I select this, the color of the icon changes, as you can tell. And it's also nicely positioned by default. So we don't have to play around with positioning that or do any tricky things. Instead, that is all handled by React Navigation. And of course, we now might want to add some options to the second screen as well. And I'm happy with the label there, but here we can also add our icon just as before, where we then use destructuring to pull out the color and size props, which are provided by React Navigation, to then display another icon. And here, let's say we have the person icon with a color of color and a size of size to use the values provided by the drawer navigator. And with that, if we save this, we also have a nice icon here. Now, as mentioned, take a close look at the official docs. There's way more you can configure. You can basically control everything about this drawer, and you could render a custom component in the drawer as well, instead of just configuring these pre-built items that are added automatically. You can do lots of things there, and therefore definitely take a closer look at this configuration. But it is now hopefully clear how you can generally configure this drawer. So that's how we can configure this drawer. Before we move to tabs navigation, there's one last thing I want to do with this drawer. I want to show you how you could interact with it besides using this default header button which you get out of the box, which is of course very convenient. Let's say in the user screen, we want to have a button, and for this I'll just use the built-in button provided by React Native. And this button should also open the drawer for whatever reason. Now you can do that with the onPress prop and then the, let's say, open drawer handler function, which I define here. And then this function is connected to this button. Now you can easily open the drawer with help of a prop that's passed in automatically by React Navigation. Just as with the stack navigator, whenever you register a component as a screen, as we're doing it here with the user screen, React Navigation will give you a route and a navigation prop. That doesn't change. Now we don't need the route prop here, but the navigation prop now actually has a new method which it didn't have when we were only using stack navigation. When we use drawer navigation, then this navigation prop actually has a toggle drawer method, which we can call. And this does what the name implies. It toggles the drawer, so it opens it if it's closed and closes it if it's open. So therefore now with this added, we can go back, and if I now click open drawer, it opens up. And of course, the same works on Android. So that's just a little side note that we have this extra method when using this drawer navigation. But of course, that is also something which you do learn from inside the official documentation. And with that, we learned enough about the drawer. As a next step, let's take a look at one of the tab-based navigators. So that was drawer navigation. We also have multiple tab navigators, and we have different navigators here because the tabs are placed in different places of the screen, at the bottom or at the top, and they might be Android specific, though you can also use the material tabs, which are a bit more Android specific on iOS, but they have a very Android-like look. Therefore, I will use bottom tabs, which are very good for iOS and Android, but you can play around with all three. And you should, of course, as always, take a look at the official documentation to learn about all the details and about all the configuration options. So here it's the bottom tabs navigator, which I want to use. And therefore, just as before with the drawer, we first of all have to install it by copying this command. And then here in a new terminal window, I will paste this in to install this bottom tabs navigator. Now, once this installation finished, we can start using it. And here, we don't need to install any other packages, at least not at the point of time I'm recording this. And we now do set it up as we did it before. We have a wrapping navigator component and we register our screens inside of that component. So therefore, back in app.js, if we want to use the tabs instead of the drawer, I get rid of that create drawer navigator import and instead import something from @React Navigation bottom tabs. And that something is that create bottom tab navigator function. And then we create our bottom tab navigator like this. And then we set up our bottom tab navigator like this. And we register our screens just as we did it before. Now, of course, we now have to get rid of these options because these drawer specific options obviously don't work with the tab navigator. So we should get rid of them and also update this closing JSX element here, this closing tag. But then after we got rid of all the drawer specific options, if we save that, that should already be all. With this saved, if we go back, we have our tabs here. Now, these tabs don't have any icons because we haven't set any icons, and by default they want icons, but they work. We can switch between these pages. And just as before with the drawer, this tab bar at the bottom is rendered automatically, it gets some default styling, and it just works. But of course, we can now also configure this, just as we before were able to configure our drawer. Now again, the official docs give us all the details, and we can also render an entirely customized tab bar if we wanted to. But we can also use the default tab bar and then adjust things like the labels of the different screens when represented in that tab bar, whether the label should be shown or not, if the label should be below the icon or next to the icon. Though the default will, for example, take the device width into account, which is pretty nice. And we can also set an icon and then also set different styles for the tab bar. So therefore, what I will do here is I will set some screen-specific styles first of all to set an icon for the welcome screen. For this, we can add the tab bar icon option here, which just as before wants a function, a React component function, where we get some default props provided automatically by this bottom tab navigator. And we again get the color and the size here. And we then can return our icons component to, for example, have our home icon here with a color of color and a size of size. And I again use the color and size provided by the bottom tab navigator so that if we later change the general settings for the active color and so on, this will be adjusted automatically. So we can add this here and of course also on our other screen. And there use this person icon. And with that, if we save this, our tab bar now has proper icons. And again, the positioning and all of that is taken care of by this navigator, which is super convenient. Now we might want to change some colors, and we can do this on a per screen basis, but then again, the colors would be different between different screens, which you might want, but which you also might not want. And therefore, I will instead use the default screen options here to set my options there. Now, unfortunately here, I'm again not getting any auto-completion. Therefore, we can take a look at the official docs. You might get auto-completion. And in the official docs, we learn that we can set an active tint color and an inactive tint color. And here I'll use the active tint color and set this to this purple here. Now, with that set on the navigator screen options, the active tint color is no longer that default blue, but instead a nice purple, which is applied to both the text and the icon. Now, of course, you can change way more. You can also change background colors and all of that, and you can overall change the entire tab bar style. So definitely feel free to play around with that as always. I just wanted to get started here and not change the overall look and feel, but now you also know how you could add such tabs here to your React Native application. And as you see, it's super simple. You get a great looking result out of the box, and then you have all these options to configure it such that it meets exactly your requirements and needs. Now I'm back in the Meals app, which we worked on earlier in the course, because now I want to build up on what we learned about these other navigators and combine it with the Stack navigator, which we have here, to dive into nested navigators, which are basically combined navigators in one and the same app. Now, don't get me wrong, you of course don't need to combine navigators, and especially the Stack navigator is a super common type of navigator. But sometimes you want to have certain patterns, certain features in an app that require the combination of navigators. And indeed, with React Navigation, nesting navigators and combining navigators is quite simple. You could, for example, have one set of screens that's combined in a Stack navigator, then another screen, which are then combined with a common drawer navigator above them. That's not the exact setup we built, but that is something you could build. And indeed, in this app, which we have here, we will build it such that we actually will have a drawer navigator on this main screen here, so that we can then choose to go either to this categories screen here, or to a favorites screen, which we have yet to add, because we have this favorites icon here, which doesn't do anything. But if this would be a real app, we might be able to add favorites here, and then it would probably make sense to have some favorites page to which we can go. And I want to go to that page with help of a drawer navigator on that starting screen. So for all of that, I'm back here in this Meals app, and here as a first step, we will have to install the drawer navigator. We'll have to add a dummy favorites screen for a start, and then we can see how we can combine these navigators. Now let's start with setting everything up. For this, we first of all have to install the drawer navigator, as we learned it before, and I will stop my npm start process here since I plan on restarting it thereafter anyways. And I will then npm install at React Navigation drawer as a first step, and then also install these extra dependencies needed by the drawer. So I will then install these extra dependencies, and because of this bug which we saw before, I will make sure that of the React Native reanimated dependency, I force version 1 instead of this version 2, which is broken for me. So I will run npm install React Native reanimated at 1, save exact to save exactly that version. So to force the usage of version 1 here. Then we can restart this and then make sure that this runs on both the iOS and Android device. For this, I will actually restart it here on iOS, close the app and restart it, force a reload, and with that we got the latest app running on both platforms thereafter. At least that is what should happen. Here we go, that is the app as we left it, running on both emulators. Now it's time to add the drawer navigator. And for this I'm back here in app.js where I did set up my Stack navigator thus far. I will get rid of this commented out code, just so that this is all a little bit more compact. And now we can start nesting navigators. And there will be different ways of combining navigators, but what I want to achieve is that I want to be able to switch either between this Stack screen here or a favorites screen, which we have yet to add, which would show us all the favorites we have in this app. And to achieve this, I actually want to replace this first screen, this Meals category screen, with a drawer navigator setup that then knows this screen, but also that other favorites screen. And thankfully, that is something that is supported by React Navigation. You can register other navigators, other navigation setups with their screens as screens in yet other navigation setups. Now, to show you how this could work, I will add a new function, which I will name drawer. Navigator, though the name is up to you. But this is a React component function. We could define it in a separate file. That would be perfectly fine. I'm just doing it here because this function will also hold some navigation setup, and I want to keep all the navigation related setup close to each other in this demo here. But you could put it into a new file. Now in here, I want to set up my drawer navigator. That is my idea here. And for this, we first of all have to add an import from React Navigation Drawer. And from that package, we import Create Drawer Navigator. We also keep the Create Native Stack Navigator import because we still need that, but we also add this import in addition. And then after creating our stack constant, we can create a drawer constant by calling Create Drawer Navigator. Here in the Drawer Navigator component function, we can then set up a Drawer Navigator as we did it before with drawer.navigator and drawer.screen. And I will use this Drawer Navigator instead of this stack screen here, or to be precise, instead of the categories screen here, like this. I point at Drawer Navigator now. We also don't need to set the title here anymore. We can set this somewhere else if we want to. So I still have this stack screen here, but I replaced my meals categories screen here with that Drawer Navigator component function, which sets up its own navigation setup, a nested navigator, because this Drawer Navigator will be nested inside this stack navigator. Now inside the Drawer Navigator configuration, we can now bring back that categories screen. We can add a new screen here and give it a name of categories, let's say. You should make sure that you don't use the same name as you did down here. You can do it, but you will get a warning because you should avoid duplicate names, as these names act as identifiers when navigating around. So you should try to enforce unique names. And therefore, maybe we name this here drawer screen, something like this, or just drawer. It's up to you. But then here I have my categories, and the component is the categories component, just as before, the categories screen component to be precise. So the component which we previously had here in the stack screen is now in that drawer screen because that drawer is now in that stack screen. And then we can add another drawer screen here, and that should lead to a new screen which we have yet to add, which is the favorites screen in the favorites screen.js file. And this is a standard React component. And for the moment, I'll just create a dummy component here, which isn't too fancy. So for the moment, I just want to import text from React Native and just output some text here and return the favorites screen or anything like this. So it's really just a dummy component, but it is a regular React component. And we can use this in app.js now as a component for that second drawer screen. So here the name is favorites, and the idea would be to show our favorite meals on this screen later. But for the moment, I will just point at favorites screen, which of course also must be imported. Now we got the drawer navigation nested in this stack navigation. With that, if we save this and we force a reload, we get a crashing Android app, so let me restart that. And with that restarted, we have the app almost as it looked before, but of course a bit different. We can see the background color behind all these items is gone, and we now have two headers, which doesn't look too great. We have two headers because we have two navigators, and when nesting navigators, every navigator brings its own header. This can be what you want, but it also might not be what you want. So thankfully, that is something we can change. But you will notice that this drawer header is only here on the first screen. If I tap into Italian, it instead is removed and we're back in our regular stack flow. And we can open this drawer to go to favorites, for example. So this is working as it should. But how can we now configure this such that the header has the right look, we have the background color, and we only have one header? To get rid of the extra header and change the styling, we will have to set some options. Now first, let's decide which header should be removed. And I would say it's the top header because we want to keep the header here that has this drawer icon, because we need that icon in order to open the drawer. Therefore, I want to get rid of that stack header if we are inside of one of the screens based on the drawer navigator. This is very easy to do because React Navigation gives us a setting we can set to get rid of a header. Here, in the Stack Navigator, if we are on this screen, which is the screen that loads the drawer navigator, we want to get rid of the header because we want to get rid of the stack-based header, so the header defined by the Stack Navigator, and hence we have to do it on the stack screen. And then on this screen, we can set the option header shown false. The default is true, and as the name suggests, this then adds a header, but you can set it to false to remove a header. Therefore, we can also remove the title here because we don't need it here anymore, because this header, this stack screen header, will be hidden anyways. With that, we only have one header and the stack header is gone. If we navigate to a nested screen in the Stack Navigator, we get back our stack navigation though. But on the starting page, it is gone as it should. Now we can of course change the styling by copying our styles from the Stack Navigator and also adding them to the Drawer Navigator, here to Screen Options. I add them here. Just one note, for some reason, the content style is named Scene Container Style in the Drawer Navigator. So for setting that background color behind all the items, behind the main content, you have to use Scene Container Style instead of Content Style when styling this on the Drawer Navigator. At least at the point of time where I'm recording this. With this saved, the drawer has a nice look, and it looks like our Stack Navigator, but we can now switch between these different pages here and then still dive deeper with the Stack Navigator. And that's in a nutshell how we can nest our different navigators and combine them. Now, of course, we could still change the title here, for example, if we wanted to, and in the Drawer Navigator, go to the options of this Categories screen to then set the title here to all categories as we had it before. This is still possible, we just have to do it here because that is now the screen that points at the Categories screen component. So that's where we have to set the title for that screen. With that, we got our all categories back. Now, speaking of titles, I also noticed that on the meal detail screen, I'm not happy with the title. That's just a side note, not too important, but here I will add a hard-coded title of About the Meal. Of course, you can choose any title you want. You could also set the title dynamically, but here I'll use the hard-coded title like this. And with that, we got the title fixed here, but most importantly, we got our nested navigators set up. Now for some fine-tuning. Regarding the fine-tuning, I want to work on that drawer. I want to give it this brown or some brown background color overall, and I want to change the colors of the selected items. And we did learn how we can configure this, so we can simply apply what we learned here. Of course, feel free to do this on your own first before we then do it together. I will apply my settings by going to the screen options of the Drawer Navigator, because I want to have these style options applied to all the screens that are part of the Drawer Navigator. And I will set the drawer content style to an object where I set the background color to a dark brown, like this. If I do that, the drawer has this brown background. Now, of course, I want to change the colors of my drawer items, because otherwise I can't see them. And to achieve this, we can add the drawer inactive tint color and set this to white. So that's the color our text and icons will have if they're not selected. If items are selected, I want to change the text and background color, and therefore we can set the drawer active tint color, let's say to a dark brown actually, because I will set the drawer active background color to a light brown, to let's say this brown, or maybe a different one. We'll see. If I save this, that's how it looks. Not too good, so actually I will switch to a way lighter color for the background of active items. And with that, that's the look I want here. Of course, feel free to come up with a totally different look if you prefer that. I also want to add some icons, and the icons should be different for the screens. Hence, we don't do it here in the general screen options on the overall navigator, but instead in the screen-specific options. Here for the categories screen, we can add a drawer icon, and you learned that this is a function, a React component function, where you receive some props automatically by the drawer navigator, like the color and the size. And then we can render our own icons. And for this, I will use the good old Ionicons set again from @expo vector icons, which we used before already. Get my Ionicons, and then choose some fitting icons here. And for this here, I'll render Ionicons, set the color to color, and the size to size. And now the icon I do want to render for the categories is a list icon. Of course, feel free to browse through all the Ionicons on this Expo Vector Icons page to find the icon you like most. I will go with that. And then copy that to my other screen, to the favorites screen, and add some options there as well. And here, I want to use that star icon, since that is about favorites. This screen is about favorites, so that star icon should make a lot of sense. With that, we get the icons added, and now here we can see them. And I think that looks quite decent. At least that's the look I want. As mentioned, you can of course go with a different look and feel. Now, we don't have any favorites at this point of time, and that is something you could add right now, but it's actually a feature I will work on in the next course section when we dive into app-wide state management. So that's it for this course section. We practiced a lot of core React and React Native concepts. We worked a lot with styling and layouts, but most importantly, we had a look at navigation. We learned how to use the React Navigation package to add different kinds of navigators that give us different behaviors and different ways of switching pages, like the stack navigator, where we can dive deeper and deeper into a stack of screens to view more and more details and get the results we want. A very common navigator which you learned how to use in depth. You did not just learn how to set it up, but also how to configure it, how to change styling of the header, for example, or the title, how to set the title dynamically, how to add extra icons or buttons to the header like this star button. You also learned how to pass data around, how you can use params and how you can extract params to get data that's passed in from another page, like this categories screen, which navigates with the navigate method as you learned, and then passes a category ID as params to another page, to another screen. That's a common pattern, and you learned about that in depth as well. But it's also not just that. You learned about parameters, you learned about configuring screens both statically and dynamically, but you also learned about different kinds of navigators, like this drawer navigator or also the tabs navigator earlier. You learned how you can combine navigators, how you can nest them, as you saw it here in the last minutes of this section, and that nesting in the end is pretty straightforward, simply because it is a feature supported out of the box by React Navigation. And now, speaking of features provided by React Navigation, as mentioned multiple times throughout this section already, definitely check out the official docs. This is a powerful package packed with features. Some of the features are just niche features which you might need very rarely, but still having a look at all these features, at the different navigators and the different configuration options is a great idea, because chances are that you can build any kind of user interface with React Native and React Navigation. Here we learned a lot about navigation, and now we can move on and dive deeper into React and building React Native apps with it. Now, to come to an end in this course section, there is one last component I want to talk about, and that's the status bar. We actually did see this earlier in the course already, and I want to reintroduce it here. The status bar component is a component exposed by Expo, which allows us to control how the status bar looks like. And typically you want to include that in your app.js file, though you can include it in specific component files, specifically components that take up the entire screen, to style the status bar differently inside of different components. Now for this, we need to import from Expo status bar, and this is a package that should already be installed by default. And what we import from there is the status bar between curly braces like this. Now we can use this here in my app component in this case, next to my root component here, which in this case is the linear gradient. There I will render my status bar, and now since I have two sibling root components, I will wrap this with this fragment component here. Otherwise this wouldn't be allowed. And on status bar, you can now set the style to light, like this, and you get a white status bar. Now also on iOS where it was gone before. Alternatively, you could set this to dark to get a dark status bar. Now here I'd say light looks a little bit better, so I'll go for a style light, but as always, you can choose the style you prefer. But it is worth noting that this status bar component is a key component that allows you to control whether a status bar is shown, as you saw it was missing before, and how it looks like. And therefore, typically you want to add it because you want a status bar and you want that status bar to look good. So here you go, the status bar component has got you covered.